The demand of Airflow developers is growing in 2026, and you can take advantage of that because I have created this complete zero to hero Airflow course which will make you job ready. How? Let me tell you. First of all, this is a beginner friendly course. That means you do not need any kind of prior knowledge. Second, you will gain deep knowledge of each concept by doing it with the practical labs with the modern Airflow SDK, because Airflow is totally changed now. Third, the entire course is organized in the form of structured chapters so that you can just learn step by step. And I have used cool graphics so that you can just understand the concepts easily. One bonus thing, I will be writing each and every single word in the definition, concept, coding, everything, so that you will feel that you are sitting in the live class. That is the best thing. Plus, we will cover the industry level real-time scenarios which will make you a pro Airflow developer, such as branching, XCOMs, assets, Kwargs, incremental loading, inherited DAGs, and much more. And you know what? All of the notes plus resources plus installation guide plus code files, everything is available to you for free. In short, you will start this video as a beginner and you will end up becoming a pro Airflow developer. Wow. I literally put my heart in creating these long format courses and providing it for free. You will hardly take 0.5 seconds to hit that subscribe button because it really matters to me. And I really want that this 40% of people will also hit the subscribe button and will bring that smile on my face. And now, just grab your coffee and bring your laptop and let's get started with this amazing Airflow master. So what's up my fam? Finally we are going to master Apache Airflow in 2026. Ansh, Lamba, first of all, why did you take so long to create this course? See, you will know the reason, okay? And this Airflow is actually upgraded, okay? We have recently Apache 3.0, 3.1 versions, which is totally changed and totally upgraded, okay? And it has like launched significant changes in the code, concepts, and added so many things. So I was like, let's create like one-stop solution. And obviously, in order to create this one-stop solution, it takes time, bro. Okay. So now the good thing is the course is finally here, and one best thing about this course is you do not need any kind of prerequisite, nothing. Just basic Python understanding is more than enough because we are just going to cover everything from scratch. You do not even need to require to know the meaning of Airflow. Okay, makes sense. Very good. Without wasting any time, let's directly jump onto the agenda of this particular video is very simple. You are a total beginner. I'm expecting this thing. Even if you have some knowledge, let's say you are a developer who was working with Airflow 2.0, 2.1, whatever version, still this video is for you because this is like totally upgraded version of Apache Airflow. If you are totally beginner, then yes, this video is for you. And after completing this video, one promise I would need from you, you would need to follow along with the labs as well, because I have created this particular masterclass in such a way where I will be demonstrating everything with the lab, with the code, with the example. So you need to follow along with all of these code examples because I have explained everything, the installation step, everything. So it's not just about like watching, it's also about doing it. Okay. And once you have completed this particular course, then you will become an Airflow developer who can confidently build applications, or you can say ETL pipelines, DAGs with the Apache Airflow. Simple, very simple agenda. That's it. Because I am very excited to directly jump onto the, you can say, course, because I am really excited. And you know what? You will also get one particular recommendation from me in this particular video, because I will just also tell you about one code editor, which is a kind of AI code editor that you can use to boost or enhance your productivity. We will just talk about it later in the video. Okay. And now I want to just come on my favorite part. So congratulations, my data family members who have recently cracked their dream role, dream job, dream offers. And I am really happy. Why? Because you are happy. And you actually make me feel proud, right? So congratulations everyone. And we have some more people here, so congratulations to all of you, and very congratulations, and congratulations. Well done, well done, well done, well done, well done, and well done. So I want this list to be so big, because that is a kind of credibility that we are carrying. That is the identity of this data family. And if you also want to join our data family, just hit the subscribe button right now, because once you hit the subscribe button, then you will become the part of my data family member, or you can say my data family, and you will become one of the members. Okay, simple. And let me just quickly share about my profile. So this is my profile. If you just want to go check and follow, you can just do whatever you want. Simple. So now let me just take you directly on this particular masterclass. Let's see. So now let's talk about, or I can say let's now only talk about Airflow. So first of all, I know a lot of you are like very eager to learn Airflow, and I know the reason, because Airflow is in demand. But first you need to understand why you need to learn Airflow, and for that you all need to understand first of all the fundamentals of Airflow. So in short, you need to gain a very strong foundation around Airflow before directly jumping onto the Airflow code. Makes sense? If you want to understand Airflow, the choices is yours. My duty is just to provide you the right guidance. So first of all, let's talk about what exactly is Airflow. Let's talk about it. Okay, because once you understand what is Airflow, only then you can work with Airflow. Common question, and obviously common sense. Okay, so when we talk about Airflow, now what exactly, like according to you, what is Airflow? Like in your mind, what exactly you have the picture in your mind for Airflow? So Airflow is, first of all, which is a great news, and that is why it is in demand. So Airflow is an open source framework which can be used as an orchestrator. Now this is very important. This word is very important. Why this is very important? So when we talk about orchestration, you need to understand like why we are just stressing all the time. Like this is very important. Orchestration. Perfect. So when you understand this concept, you can actually work with Airflow better. Orchestrator. So now let's talk about like what exactly is orchestration and why do we need to worry about Airflow as an orchestrator. So first of all, let's say you have a series of tasks. For example, you are a data engineer. Forget about Airflow for now. Okay, forget about Airflow. Just forget, like we do not even have Airflow in the picture. Let's say you have some tasks. For example, you have a source. It can be a SQL database, right? It can be anything. Let's say we have multiple sources. We have one SQL database, right? And we have one, let's say, API, any kind of API or any kind of source. Let's say this is the API. Let's keep two sources for now. So these are our sources. So now you as a data engineer obviously need to load the data from here. Perfect. Common scenario you would have used. Okay. So now you need to just load this data into any location, let's say S3. If you have worked with S3, AWS S3 or any kind of data lake, it can be ADLS Gen 2 as well. But you need to obviously load this data. So how would you load this data? Let's say you are using a Python script, right? Let's say you are just using Python SDK for loading this data into S3, right? So let's bring Python script. Okay, perfect. So you will load this data. So let's say this data is loaded. Okay, this data is loaded. Now after this step, you need to further process this data, right? You need to clean this data, let's say, or you need to transform this data, anything. Let's say now you will use PySpark, for example. Let's say you will use PySpark. And then you will load this data into a warehouse, right? It can be Redshift, it can be Snowflake, it can be anything. Let's say you will load this data into Redshift. and any of your favorite data warehouses. Simple. Okay. Now just tell me one thing. Let's say this task is also done. Okay. Now you need to then provide this data to the downstream stakeholders. It can be data analyst, data scientist, or anything, right? So you are, let's say this is the only task that you need to do. The rest of the stuff other people will do. Let's say you just need to do this work. Now just tell me one thing. You have two problems actually. Problem number one is you need to perform these two tasks in a proper sequence. What do I mean? First of all, you will first extract the data, right? This is the first task that you need to perform, right? First extract the data. Once the data is extracted, then you need to process the data, or let's say process and load the data. Okay. Makes sense? So you need to perform these two tasks in a proper sequence. You cannot perform this task before then this task. So you have to follow the sequence. Problem number one. Okay. Problem number two. Let's say you somehow followed one solution which will, let's say, follow the sequence, let's say. But now you need to repeat these steps, or you can say repeat this cycle, this flow, this workflow again and again multiple times. Let's say on a daily basis, on an hourly basis, on you can say weekly basis, anything. But you need to repeat this thing. So how can you do that? So these are the two big challenges. Okay, that's where Airflow comes into the picture. And now the meaning of orchestration means you need to orchestrate the workflow. Orchestrate word actually comes from the, I think, music industry, where we orchestrate the flow. So let's say you are an orchestrator, right? And you have a team of people who can play multiple instruments, but you need to make sure that, let's say, a person who is playing flute needs to play the flute after someone who's playing guitar, or they both need to play both the instruments in parallel, and then someone who is playing, let's say, piano will be just playing piano after these two things. So you need to just do all of these things. You would have like seen those things in the cartoon, like person doing this. What is that? That is orchestration. The person is guiding, hey, you just do this, you just do that. So that is orchestration, right? Airflow is actually doing the same thing. Airflow is also doing these things back in the scenes, right? And how? Obviously you will know how, because we are mastering Airflow, but this is the thing that is solving Airflow. This is the problem that Airflow is solving. This is not the only problem, but this is the major problem. Okay. So this is Apache Airflow, which is an open, you can say, source platform or framework, which can act as an orchestrator. And this is the very simple, very basic example of it. Very basic. Okay. Now you will say, okay, what are the benefits of Airflow? Like, why can't we use something else, or why should we use Airflow? First of all, it is very Pythonic. That means if you already know Python, you can easily work with Airflow, because Airflow has a Python SDK, or I can say Airflow is actually a kind of Python library that you can just learn and you can easily work with Airflow. So you do not need to learn something out of the box. You know Python, you can work with Airflow. That is the biggest advantage. Make sense? And then obviously Airflow provides you an amazing UI that I will just show you. Don't worry, we will be just mastering everything. This is like very fundamental thing. And I know in order to master Airflow, you have to go through fundamental, because Airflow is something which is very, very rare. Like if you will go and try to find resources, I know it is very, very rare, but the best resource is the one which will cover everything from the scratch, right? Okay. So now we got to know like what is Airflow. Okay. So now let's talk about what Airflow is not. Okay. Why? Because see, whenever we are just learning Airflow, we can be confused at the later stages by comparing Airflow with some other frameworks which are already doing some other work, we can do this mistake, because when we actually start working with Airflow, we feel like, hey, I can also do this thing with Airflow. Hey, I can also do this. I can also do that thing with Airflow. But actually, you should not do all of those things, even if it is possible. Oh, really? Really? Even if it is possible, yeah. So I will just now talk about what are the things that you should not do with Airflow and what Airflow is not. This is actually very important question. Okay, let's talk about what Airflow is not. So, what do you think? If I ask you, like, what do you think? What Airflow would not? So, what Airflow is not? So, Airflow, first of all, is not a data processing framework. Airflow is not a data processing framework. That being said, you should never rely on Airflow to process your data. Make sense? That means, again, I'm repeating, you do not need to process data with Airflow. Why? Why? Just tell us why as well. So first of all, when we talk about data processing, we already have this framework, right? Apache Spark. Yes. Do you know why people get confused between processing data in Airflow and Spark? Like, why people think like we should process data in Airflow? Because Airflow also has an architecture which distributes the processing. Basically, not processing data, processing of DAGs. So people think that, hey, we can just distribute the work and let's process data with this framework as well. Let's process everything. You should never do that. You should never do that. Okay, so this is the first point. And then Airflow was built when it was built. Like, I know it is an amazing framework, and lot of organization use Airflow, okay, on a daily basis. But Airflow is not a real-time processing framework. Or real-time, you can say, data or DAG running framework, because it's all about DAG. Don't worry, even if you don't know about DAG, we will just talk about it. Don't worry. So if you don't know about DAG, let me just give you another example. Let's say you are working in an architecture where you are receiving data on a daily basis. It's fine. Airflow is good there. If you are receiving data on an hourly basis, still it is good. It is good. Even I would say in every 15, 20, 30 minutes, it's good. But if you are receiving data on a real-time manner, or let's say you are receiving data immediately, or let's say in microseconds, for example, IoT is a very good example for this. Let's say if you have sensors, let's say you have this IoT means, like, examples of IoT are sensors, all those devices such as thermostats, digital ones. So IoT. So here you receive data on a daily, like, real-time manner. You will get the data like this in a continuous manner. Tuck, 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 tuck. It will never stop. It is a kind of stream that you receive. Let's say like this. You're receiving the data in a continuous manner. In that particular scenario, Airflow is not a good choice. You cannot say, hey, I will dump my data in a real-time manner using Airflow. No, Airflow cannot handle that. Airflow cannot. Let me just say Airflow is not a good choice. This can't be handled by Airflow. Simple. Let's use red. Okay, perfect. Just remember this thing, because yes, this can be your interview question as well. This can be your, see, whenever I create masterclass, it's not just about interviews. It's about how you can become a pro with that particular technology. How can you actually gain the knowledge? Because when we talk about knowledge, interviews and all these things are very small. Because when you have knowledge, you know how to use the technology, how to work with that particular framework. So just forget about these interviews and all, because this will be like a very small thing then. Okay, so Airflow cannot handle this real-time frameworks. And then now you will say, Ansh, Lamba, you said that we need to extract the data, then we can process the data and load the data. So it is very similar to ETL. Can we say that Airflow is an ETL framework? Not at all. Not at all. Let me talk about that as well. Airflow is not an ETL framework. No. Never, never, never. So why? See, Ansh, Lamba, it is very similar. Extract, transform, load. Let me just tell you. When we talk about ETL tools are complete ETL tools. That means if I say, for example, very popular ETL tool is Azure Data Factory, right? When I say Azure Data Factory is an ETL tool, yes, that makes sense, because Azure Data Factory can extract the data, Azure Data Factory can transform the data, Azure Data Factory can load the data as well. So that is why it is an ETL tool. Okay. If we talk about AWS Glue, we can say that AWS Glue is an ETL tool. Why? It can extract the data, it can load the data, it can transform the data. Are you getting a point? Yes. But why Airflow is not an ETL tool? Why? You know the answer. Because Airflow can only schedule, it can only orchestrate. See, for example, it will say you can extract this data using this Python script. That's it. It will simply say run this Python script. Done. Then second step, it will not process this data using Apache Spark on its own, you can say, framework. No, it will only make an API call, or basically you can say it will just invoke the function which will process this data. Airflow will never process data on its own. It will simply say, now I need to process this data. Whichever entity is responsible for processing the data, just process it. I do not care. I will simply tell you when to process and what to process, and that's it. That is why it is not processing the data. It is just telling that, hey, now you need to process this data. Make sense? So that is a difference. It doesn't have that, you can say, kind of built-in capability to process this data. That is the difference. Okay, so it is not an ETL framework. It is just an orchestration framework. Now, when we talk about Azure Data Factory and AWS Glue, those kind of tools and technologies, they are complete ETL tool. They can orchestrate as well, and they can process the data as well. But Airflow is just an orchestration tool. Then why do we use Airflow? Why can't we just use ADF or Glue? See, Airflow is first of all open source, and Airflow can actually handle those parallel tasks and can actually run DAGs in parallel with much more scaling, because it is its power, right? So it's all about the requirements. It's all about, you can say, choosing one over other according to the requirements. Let me just give you a very good example. Have you ever heard about the tool called Fabric, Microsoft Fabric? Okay, very good. Microsoft Fabric has an amazing framework which is called Azure Data Factory, now which is called as Fabric Data Factory in Fabric environment, right? It has the Fabric, right? Like Fabric Data Factory, it has Fabric Data Factory. Do you know what? In Fabric, in Microsoft Fabric, they have introduced managed Airflow jobs. Do you know why? Because they know whenever we want to orchestrate the, you can say, code with much more control, with much more scaling, Airflow is the answer. So just think about it. When fully low no code solution like Microsoft Fabric is encouraging Apache Airflow jobs, that means it is important. It is important for like orchestrating DAGs. Make sense? Now I hope you know, like, still Airflow is very important. Okay, and obviously Airflow like has so many other use cases as well. We will talk about that as well, don't worry. It supports incremental loading, so many things. Okay, so now you know like what exactly is Airflow and what exactly Airflow is not, because this concept is very important. Simple. Okay, so now let's talk about one more topic, which is what happens inside a DAG. Okay, and why can't we just use a simple script? Because if you are familiar with Python, if you are a Python developer, you can say Ansh Lamba, do you know what? Whatever things you are saying here, I can simply build a Python script. Why do I need to learn a different framework called Apache Airflow? Why? Okay, let's answer this question. Because see, these are the questions which sound like very, very simple. But when someone asks you in the interviews or wherever you are working, then you will be like, whoa, I just know how to code in Airflow, but I do not know about these questions. That shows that you just learned the code. That's it. You didn't learn the concept. You didn't learn the why. You didn't learn the problem it is trying to solve. You just learned the tool because someone asked you to learn, and that's it. But you need to know why you are learning that. Make sense? Ansh Lamba's philosophy class. Should I start philosophy classes? Okay. So now, why not script? That's your question. Because if you are familiar with Python, you will simply say, hey, I can just create a function for this. I can just create a function for this, and I will just run these functions one after other. I can do this. Why are you just making things complex? I'm not making things complex. I'm just making things simpler. So now let me just tell you why. So when you have a framework, or let's say when you have the workflow, the flow that you need to run like this, that let's say you have the flow like this. Let's say first task. Okay. Task 1. Okay. Then you have task 2. Or let's copy this one. And you have task 3 like this. This is very easy, and I can process this particular DAG. Or what is DAG, Ansh Lamba? You are using DAG again and again. Okay, I didn't use DAG. Let me just say this flow. So task 1, task 2, task 3. So let's say we have this particular flow. You can easily execute it with Python. I agree. I totally agree. And I'm with you, bro. I will also write Python functions for you. Perfect. But you know what? This flow is very simple. Simple flow. Let me just say simple flow. Right? This is very simple. But now, if I say my flow looks like this, let's say task 1 is here. Okay, and we have one more task in parallel, which is, let's say, task 3, and we need to do this. And once both the tasks are done, then you need to run your task 4, and then you have, let's say, some conditions, some if conditions, and so on. Like, you will be having these two things. Then let's say if this, if not this. So let me just write it for you. So let's say this. This is a decision maker, and then let's say task 4 and task 5. Now just try to build this thing with Python. Build it. I'm not saying it is not possible. I'm not saying that. But now it will be complex. Right? It will be complex. I'm not saying it is not possible. It will be complex. And it's not just about that. Now you need to just, first of all, orchestrate this. Okay, you need to maintain the flow like one after other. Then at the same time, you also need to take care of the state or context. Complex, first of all, plus state management. If you are coming from, let's say, or let's say if you are not coming from any AI engineering background, you would not have heard about the frameworks like LangGraph. Do you know what? I feel so bad that I love LangGraph, first of all. I feel so bad that Airflow didn't come up with those things that LangGraph came with. Do you know why? Airflow does the same thing, exactly same thing, that lang graph is doing in terms of orchestration. In terms of orchestration. And lang graph then started building so many connections, so many integrations with those LLM tools and all, and then connections with LLM providers and so many things. But Airflow didn't do anything. So I was like, if Airflow would have done that, then Airflow would be the only framework, or you can say only library, that would be required for data engineering and AI engineering. Airflow would have won the game. But it is what it is. But if you are coming from AI engineering background, Airflow is very similar to your lang graph when I talk about state. Okay, only state. I'm talking about only state. How it travels the state from one node to another. If you're not coming from AI engineering background, then obviously you can totally skip this point. Okay. Yeah. And yes, then lang graph started doing so many other things as well, because initially lang graph was all about like nodes and orchestration. Then it introduced so many things like long-term memory, short-term memory, and I would say human in the loop. All things are amazing. Obviously we are not learning lang graph here, but yeah, I'm just giving you some context because you are human living in the AI era. If you do not know about these things, like it will be very, very tough in the upcoming years, I'm telling you. So you need to know about these things as well. Do not feel like, hey, why are you talking about AI engineering in the middle of Airflow? Okay, it's up to you. So now this is a complex graph, plus we need to manage the state. So now this will become very, very complex if you need to run with just a script, just a Python script, because it is not just about automation, or you can say managing the order. It's about much more than that. Simple. Okay. Now you got the answer, why not script? And then let me just show you how process works. This will be like very cool. Let me just show you. So how our Airflow will execute the tasks. So these are all the tasks: task 1, task 2, task 3, task 4, task 5. Task is like just like a task, like just a work, a piece of work, right? So first of all, it will run this particular node. What is node? Just a technical name for, you can say, the isolated area where you run that particular work. Don't worry, it is just like a technical term, like node and edges. So you can just call this line as edge in the technical term. That's it. You can just call this box as node. Simple. Just technical term, so that people will feel like, hey, it is very complex, but it is not. Especially when you are on this channel, it is not complex. So now, first of all, task 1 will be executed. Anyone knows the answer? Any one of you? Why task 1 will be executed? Because Ansh Lamba, it is at the first place. That's not the answer. It will be running as my first task because there is no other task that this task is dependent on. That is the technical answer. That is the real answer. Task 1 will be running because there is no dependency. That means this task can run now. Now I can just make this task as triggered. Let's say like this. Okay, simple. Now what will happen? This task is completed because I have marked it as green. Okay. Now these two tasks will run in parallel and at the same time. At the same time, yes, because these are in parallel. And you need to understand this concept very carefully, because we will be just writing the code for this very, very soon. So this task will be running immediately. So this will be green, this will be green, like this. Oh, then it will go to this task. So now let's say due to any reason, this task failed. This task is failed. Let's say like this. Do you know what will happen? This will never go to this task. Never. It will be skipped. Why? Because this task can only be executed once all of these two tasks are successful. If any one of these tasks fails, then it cannot be executed. See, because these are two arrows. That means both tasks need to be successful. Oh, okay. Yes, that is the concept. Okay. So if it fails, it will never go to the further tasks. But let's say it is passed, then it will go here. And let's say this is the if condition, decider node. And let's say this is yellow. And then this task, let's say this is a decider node which decides which task to execute. So this will be, let's say, executed here, and this will be skipped. Why this will be skipped? Because according to the you can say logic, this task should be executed. Let's say this is a task which is deciding, hey, you need to run this task if the data is coming from SQL source, and you need to run this task if the data is coming from the API. So like this. Make sense? So that's how you manage the state. So this will be skipped and this will run. Simple. So that's how you run the, or basically not you, Airflow runs the tasks under the hood. Simple. Now I will just take your few minutes because I want to introduce you to an amazing AI code editor that I was exploring more recently, and that is also the sponsor of this particular video. And what is that particular code editor that is like so popular that you're talking about, Ansh Lamba? Okay. This is Verdent AI, an amazing AI code editor which can perform the parallel tasking, and being a data engineer, that's exactly what we need. You already know that I love trying new AI code editors, and let me just tell you, I love this one, and let me show you why. First of all, go to your favorite browser and just type verdent.ai. And then you will just land on this website. Quickly click on sign in and then just click on download button so that you can download the Verdent AI application on your desktop. So being a data engineer, we fetch data from so many APIs, and obviously we need to perform multiple tasks at the same time. The problem is we have to write the boilerplate code again and again for all those tasks. And you know what? This AI code editor can actually do everything with just one single prompt, and I am not kidding. Let me just show you. Here I have opened my Verdent application on my desktop, and this is the home page that you can see on my screen. So first of all, you will see this agent tab, and then you have the projects tab. So being a data engineer, you first need to create a project so that you can just start working with Verdent within your existing project. So let me just quickly create a project here. Click on open project. This is very similar to create a folder in any other code editor. So this has created a project for me. As you can see, DE project, and all the files and directories are listed here. So as you know that we need customization in our code editor, so you can quickly click on this drag button and you can drag it towards left if you want the traditional coding style in your code editor. So let me just do that. So now you can see that all the files will be appearing here, and on the right hand side we have all the tasks. So as you can see that I have provided the prompt in which I have said that, hey, I want to fetch the data from these APIs with multi-threading because I want to perform parallel tasking on my Python task, and just save all of the data fetched from APIs in a new directory called sync. And you can see that I have literally used the natural language to perform this task. Now let me just hit enter and let's see what it has created. So as you can see that it has started creating the script for me, and first of all it is creating this to do. So that means it is not directly generating all of the code randomly. First of all, it will plan it, then code it, and then it will verify it as well. So I can see that I have my Python file called fetchdata.py, and it has also figured out the error called import request error in module 1, and now it is also installing the request library automatically for my environment so that I can run this task. This is amazing. So as you can see, it has performed all of the agentic tasks. That means it has fetched all the data and created all the things, and now it is saying, hey, I have done this task, and this task. Done. And I will literally show you, this is the sync folder, and here I can see all of the data created for me, and I have literally not touched any Python file in front of you. Let me just show you the file it has created first of all. So this is the code that it has written for me in this file, and it has automatically imported this package for me, and then it automatically ran this code, and as you can see that it also troubleshooted the error on its own. This is amazing. I have worked with many agentic notebooks, many agentic code editors, but this is amazing. The powerful thing is you can literally perform parallel tasks without losing the context. Let me show you that as well. And so now I just want to get started with the new task. So I will simply click on this plus button, and now let me just ask it. So here I have just provided a new prompt where I'm saying just download the data from those APIs without providing any context, because our task will see the context automatically from the other task. So let me just hit enter. So now as you can see, it has started generating the thing, and let me just show you. So it will automatically fetch the content from this particular file, and it will automatically fetch the context for you. That means you can perform parallel tasks without losing the context. This is the feature that I have never seen in any other code editor. So if you as a data engineer want to enhance your productivity in your day-to-day activities, you should try Verdent now. Just check the link in the description. Now we are just going to talk about the very important concept, or basically very important topic. It is called core components of Airflow. Okay, core components of Airflow. So now let's talk about the core components. And do you know what? If you are familiar with Apache Spark, you know one of the most important concepts in Apache Spark is Spark architecture, right? Similarly, in Airflow as well, this is the most important topic. One of the most important topics in Airflow is Airflow architecture. And do you know what? Before understanding the Airflow architecture, you need to know all of the core components of Airflow. And you will get to know about all of the core components. Don't worry. So let's talk about the core components. Core components of Airflow. Simple. And this will be very, very fun because we have so many components for Apache Airflow. Okay, so now core components, and you need to be double focused here for core components. Okay, so first of all, the core component that we have is, any guesses? It is called metadata base or metadata database. Okay, metadata database. Simple. This is the first component. Okay, so what is metadata database? In order to understand metadata database, you need to first of all understand what is metadata. See, that is a valid point. We know database, but what is metadata database? So what is metadata database? Let's talk about it. So let's say, let me first of all put here metadata database, any database. Ideally, I should just pick Postgres, and you will know the reason very, very soon. So let's say metadata database. Simple. Okay. So this is the first component. Now let's talk about the metadata. Metadata means data about data. Wow, Ansh, Lamba, very cool definition. Just explain this stuff. So let's say you have your data. Data means, let's say I have the data about orders. Simple. I have the data about orders. Now I want more information about orders. That means, what is the table name? Like in which table I have stored the data? That is metadata. What is the schema name in which I have created the table? That is the metadata. Okay, what is the database, or you can say catalog name, in which I have created the schema and table? That is a metadata. That means any information about data, about the real data, is called metadata. Okay, so what will be the metadata in terms of Airflow? Because Ansh, Lamba, you said like we never process the data, and obviously Airflow cannot be a data storage service. So what kind of metadata are we trying to save here? You know the answer. Whenever you ask a question, just ask a question from yourself. You know the answer. What do we create in Airflow? What? Okay, what? We create flows, DAGs, whatever, right? Exactly. That is your metadata. So whenever you are creating DAGs, Ansh, Lamba, can you please explain what is a DAG? I will explain, because that is a kind of component. But for now, you can imagine DAG is a kind of workflow like this. Okay, this is a DAG. This is a DAG for you, because this is a flow. Any workflow can be called as DAG. But I will just talk about more about DAG technically. But for now, for your understanding, just imagine, whenever I say DAG, imagine this. Okay, simple, cool, good. So let's say I want to store information about this DAG. Okay, what type of information? First of all, definition. Task 1, task 2, task 3, task 4, task 5. All of this information, obviously. Okay, first thing. Okay, when it is scheduled? Oh, obviously. Do I need to run this DAG at 5 p.m., 4 p.m., 3 p.m., 12 a.m., 2 a.m.? 2 a.m. Who runs the DAG at 2 a.m.? Bro, they run the DAG at 2 a.m. and then they just call the developers, hey, this DAG is broken, just wake up and fix the DAG. What? Just run the DAG in the morning. Let us sleep. We are also the humans. Okay, so task 1, task 2, task 3, task 4, task 5. And this DAG will be running, let's say, at 2 a.m. Metadata. Then, okay, this DAG is running and this DAG is failed. That is also metadata, a kind of information. Then, all of the task instances, that means all of the independent tasks, let's say this task is failed. Obviously, if DAG can be failed, individual tasks can also be failed due to any reason. Let's say API is not working, connection is failed, anything. So all of that information need to be stored somewhere, or you will be taking care of all of the things. You will just create a notebook and you will write everything manually. Obviously, no, right? So this is the metadata. That means Airflow needs to store all the metadata about the DAGs. For instance, DAG runs, schedule, status, right? DAG status and task instance, etc. Simple. Airflow needs to store all of that information. This is your first component. The second component is, and by the way, this is the backbone for this in the new architecture. Earlier as well, it was important, but now it is even more important. Okay, and you will get to know the reason because it's all about database now. Okay, so first thing is metadata. Second thing is DAG file processor. Okay, and I think this is self-explanatory, but still I will just tell you. So let's say you have this kind of thing. Okay, keep it like this. It can't be rotated. So DAG file processor. So let's say we want to write the DAG, and this cool thing is not something magical. We have written the code for this, right? We developers have done everything, by the way, in this life, but yeah, managers also contributed something this much, but yeah. So same thing. See, whenever let's say a building is in progress, so who builds the building? Workers, right? Who gets the recognition? The manager. The person who takes care of all the workers. But who actually built the building? Those workers. Who actually deserves the recognition? Those workers. Okay. Ansh, Lamba, bring some change so that developers will get the recognition. Okay, for sure. So now DAG file processor. So let's say I want to build this DAG, and currently you are seeing this DAG visually. Cool. But obviously someone has written the code for it. Let's say I have written the code for it, you have written the code for it. So whenever we write any code, DAG file processor task is just to go to independent DAG and just try to render it or just try to read it. Okay. So what happens in Airflow? We have a special folder called DAGs. I will just show you, don't worry. See, currently just understand the concept first of all. You will know everything in the code as well, because code writing is not a big thing now. AI is here. They can just write the code like tuck, and your DAG is ready. What will make you AI proof is this kind of understanding, this deep understanding. Now just forget about like the era where you will just learn the code and see, I am this, I am that. Not really. You need to understand the concept in very much depth. Okay. So now let's say whenever you just build anything in Airflow, we create a special folder called DAGs. Okay. Let me just use a different color. Let's say this is my, let's use this here and let's bring here. This is cool. Okay. So let's say I have a folder called DAGs. Okay. In the Airflow. So what happens? This folder DAGs, my DAG file processor will continuously scan this thing. Let's say I want to use this because this will be more relevant. Otherwise, you'll be confused. Okay.
So let's say this is the DAG file processor. So this DAG file processor will continuously scan this thing, continuously scan this folder, and then it will try to render it. Okay, it just goes to that DAG folder, whatever we have. Okay, and it renders, or you can say parses the DAG files and extracts the DAG structure and stores the serialized DAG metadata in the Airflow database. See here, who does that? DAG file processor. So it DAG file processor will go to your DAGs folder and will parse it and store the serialized DAG, you can say, not metadata, serialized DAG into the DB. And don't worry, this is just like high level, you can say, architecture. We are just going to discuss architecture in detail as well, but this is like the working of DAG file processor. Now you will say, what is a serialized DAG? So serialized DAG is nothing but just, you can say, whatever code you write. Obviously you are writing the code in Python, so it converts that particular code for that DAG, just for that DAG, not for the other things. Okay, because we have so many things in that particular file, in code file. So it will create a kind of JSON like representation. Oh, and it will store that particular thing in the database. I will show you that as well, because I am going to go in very much depth in this particular course. I will just go to each, you can say, container, and I will just show you everything. So it will simply parse that thing like this. Let's say JSON and some XYZ, and the value will be something. Let's say ABC. So this will be parsing or serialized DAG. Simple. This will be serialized DAG. Simple. Okay. So this does that particular thing, DAG file processor. Then we have a kind of third component, which is API server, and this is the backbone for you. Why? Because you will interact with Airflow just with this. You cannot do anything without this API server. API, or you can say front end. This is your front end as well. Okay, simple. So API server. So what is the API server in, can we just color it? Wow, it's cool. Let's use this API server. So if we just talk about the API server is your Airflow web server. Okay, you can just use this name as well, web server. This is the center point to which almost all of the other components communicate. All of the other components, obviously these two, plus more that I'm just going to discuss. Make sense? The most common use of API server is for us as users to interact with Airflow using web UI. This is, for now, you can treat it as like the middleman for both the things. First, for your front end. Okay, first for your front end, because see, let's say you are this user. Let's bring that handsome guy. Let's say you are this person. Okay, all of my female learners, let's say this as well. Okay, so let's say these two are the developers, and who is this? I don't know. So let's say, why she's holding a stick? Let me just remove it. Yeah, now it's good. Okay, so now let's say these two are the developers. Okay, now these two developers want to use or want to work with Airflow, and obviously they will be just writing all the code, but obviously they need to see the UI. They need to interact with UI. So what will happen? Airflow will provide us the web UI as well, and it is available at the local host 8080. Do not worry, you do not need to remember this because I will just show you. Don't worry at all. So where is that particular web application thing? Let me just get it for you. Yeah, here. So this is a kind of UI, front end. Or let's say front end. You will interact with this front end, and this is the Airflow front end. Okay. You will only interact with this thing, because you cannot go in the backend. Like you can go in the containers, but usually you do not. Okay. So let's say this is your front end. So now in the front end, obviously this is a kind of just a front end which is written in React. Now in the backend, I think the backend is written in Fast API. Okay. So that particular thing, whatever you click, let's say there is an option here. Let's say this is the button here. Simple. You click this button to view your DAGs. Let's say. Okay. Let me just remove this. Let's create our own, you can say, UI. Oh wow, man. We did it. Okay. So let's say you can see the DAGs like this. Simple. Okay, simple. So this is the Airflow front end. Now you clicked on DAGs. So what will happen? You see the DAGs. But how did you see the DAGs? How? Because there is an API attached to it. So there is an API. There is an API attached to it, to this DAGs button, like this. And it will go to your database to bring that information to you. Right? Or how would you see the database? Or how would you see the results? Like this. So you just click on DAGs, but this API goes to the database and brings the data back to you. This is one work of it, of the API server. Because you interact with all of the services, or basically all of the things in the front end using API. Because front end is nothing. Front end is just a design. Front end is just the, you can say, fancy boxes, colors and whatever. When we click on it, real work starts using API, right? If you have some fundamental knowledge about APIs. I'm not asking you to master Fast API or Flask, but just the basic understanding if you have ever worked with APIs, right? So this is the one thing. And not just that, it also interacts with the other components like scheduler, workers, that we're just going to discuss very, very soon. So what will happen? This is just you. Now let's say this DAG file processor wants to write data into the database, right? So what do you think? How it will do that? Does it have like any kind of magic? No, it will bring API into the picture and then it will write that thing. Oh, so API is the, you can say, middleman for every task. API is the middleman. Whatever thing you want to do, just call the API. That's it. Simple? Very good. Now let's talk about our next component, which is, and do you know what? If you are actually understanding all of these parts now carefully, you will hardly take 10 minutes to understand the Airflow architecture. And just ask anyone who would have learned Airflow in the past or who is currently learning Airflow, just ask how long did you take to understand the Airflow architecture. Okay, so you need to know like what is important before learning what thing. And just forget about everything, because you do not need to know about all of those stuff. I will just take care of everything. You just need to sit back, relax, and just hit the subscribe button. I don't know why are you just waiting so much before hitting that subscribe button. Just hit that button like this. That's it. How long will it take? Just half millisecond. And what are you getting in return? The knowledge, the skills that is like actually building your career. Simple. Now let's talk about the scheduler. Now what is the scheduler? This is actually very important concept. Actually, every concept is important, but this is a kind of, you can say, most talked about. So let's use this one. So let's say this is the scheduler. Perfect. Yeah, it's fine. Yeah, like this. Okay, let's say scheduler. It's fine, it's good. So let's say scheduler. So now what this scheduler will do, as the name suggests, it schedules. So let's say you have defined this DAG and you want to schedule this DAG on a daily basis at 4 p.m., at 3 p.m., at 2 a.m. So scheduler is just responsible for determining what and when tasks need to be executed, and that's it. Oh, okay. Yep. So scheduler is responsible for what and when tasks need to be executed. Simple. Just what and when. Just what and when. Just remember these two things. What and when. Okay. Let's use this one. Perfect. What and when. Simple. Just remember this because this is important. What and when. Simple. It will not do anything else. Just what and when. That's it. Okay. And this is very simple. We do not need to just talk about much about this thing. Now let's talk about the very important thing and the most confusing part of this particular entire Airflow thing is, don't worry at all. I'm here. Executor. Now why? First of all, it is confusing. Let me just tell you. So whenever, let's say this is the executor, let's say this one, this is nice. So now why it is confusing and what exactly it does. When you read this word executor and when you actually come from Spark background, you will say, we know that this will execute the code. So actually it will not execute your code. What? Then why do we call it as executor? Hold on. So now just listen to me. I know executor name starts with like execute and it is common sense that it will execute the data or it will execute the DAG. No, it will not execute the DAG. It doesn't execute the DAG at all. So what it does? So executor will only decide how and where. How and where. Let me just write it for you. Executor will decide the how and where task need to run. Make sense? How and where. Okay. So what does it mean like how and where? What does it mean? Okay. So executor is just a kind of contractor. Remember, I talked about the building. Like who actually built the building? Workers. What did I say? Workers. Have you ever seen any building which is in progress? You would see workers are working the work, and out of those workers, there is a kind of head who is called as contractor. And because I have seen like buildings a lot, like because I am from a background where there were like lots of construction when I was like in my childhood. So I have seen like lots of buildings. So we used to see like workers were doing the work and there was like a kind of contractor who was just managing the workers. Hey, just do this. Hey, you need to come tomorrow for the painting. You need to come tomorrow for this, for that, and that particular thing. So that person is called contractor. And you would have heard this word in, you can say, in the civil engineering as well, where we just talk about, hey, just need to build this bridge and these are the workers and there'll be like one contractor. It can be like multiple contractors, but let's say there's just one contractor. Let's say you just want to build a house. You just need one contractor. So contractor is the middleman between what? Between the workers and between you, or let's say the person who has ordered that you want to build a building. And here, who is the person who ordered? Scheduler. So scheduler said, I want to build a building, let's say. Or let's say scheduler said, I want to run this DAG at 4 p.m. Contractor will come into the picture. Contractor will say, okay, I will make sure it will be running. Okay. Then contractor will call the workers. Hey, I want to run this DAG and just run this DAG. Then contractor will bring all the workers and all the work will be done. Right? That's how it actually works in the real life. And this is the same way it works in the IT, in the code industry as well. See, nothing has changed. Coding is nothing like different from the real world. It is exactly the same. It is exactly the same. All these frameworks are built by taking the inspiration from the real world scenarios. Do you know this thing? Because who build these things are also human beings. I hope so. So now contractor is just the middleman between scheduler and worker. Scheduler who ordered, worker who is doing the task. Now, okay, makes sense. But how, like what it actually decides, like what is how and where? What is how and where? That is a good question. Like what is how and where? So basically there are so many different types of executors that we have. Okay. We have local executor. We have salary executor. We have Kubernetes executor. You do not need to know about all of these things for now, but we have different types of executors. Okay. So now when we say that it needs to know how and where. So as I said that there are like multiple types of executors. So for example, let's say you are running Airflow locally and you'll be running Airflow locally. So what will happen in that particular scenario? Executor will decide that I can run the tasks in parallel, and obviously depending upon the number of cores or number of processing units that you have, I can just show you in the task manager. So how much of computation actually do you have in your system? Because every system is different, because you would not have like same system. So it decides that particular thing, like how and where it needs to run. So let's say you are not using or running Airflow in locally, which is a normal practice in the real world. You are using, let's say, Kubernetes. So in that particular scenario, each task can go to a different machine, right? There can be so many machines, so many workers. So who will decide that thing? Obviously executor. So executor will not do anything actually. It will simply take the orders from the scheduler and put and will put the, you can say, how and where tag along with that particular task and just put it in the queue. Hey, you need to just do this. Hey, you just need to do this. Hey, you just need to do this. Make sense? Then comes the real thing, which is workers. And now you know what is worker or what are workers. Okay. So workers are nothing but the real, you can say, layer where your DAGs will be processed. Simple. So it will actually execute or not execute, like process. Okay. So workers are the components that actually execute the task. Actually, it's not executor. Okay. Workers will process the DAG. Whatever is written in the DAG, if it's an API call, if it's a, you can say, bash command, if it's like a Python function, anything. Simple. So executor is just a strategy layer that defines how tasks are submitted for run. But it is the workers who actually process it. Make sense? Make sense? Okay. So workers are the real, you can say, real layer for execution. Simple. Okay, makes sense. So okay, that is also done. The last, or I would say second last, or I would say last, because the last one is optional. So one thing is called queue. So just look at that particular thing. Whatever tasks we are just getting from the scheduler, we can get so many tasks, right? Let's say this is the DAG that we are processing. There are so many tasks, one, and then we have two tasks, and then we have two, three, and then we can like have so many tasks. And then maybe this DAG is running, and within that DAG, or maybe with respect to this DAG, one more DAG is running, and then let's say 10 more DAGs are running. So we need to have a kind of system where we can prioritize the tasks, right? And that prioritization layer is called queue. That layer is called queue. Queue means like there'll be kind of, have you ever seen like any kind of queue in your school where you stand like highways? So that is also kind of queue, right? Or let's say you are just going to a picnic spot in school. You just make a queue, make sure no one is lost. So that is a kind of queue, right? So all those things are actually related to this concept when we just talk about the queue. So let's say, let's create a queue. It will look like this. Let's say this is a queue and you have events in this. Let's say this, let's say this, let's say this, and yeah, let's say this. Okay, simple. So let's say this is our queue. So this task, this task, this task, this task, we need to put all of this information in the queue so that workers can see. Let's say we have just three workers. Now those three workers, yes, can do the task, but they need to know the order. They need to know the, you can say, prioritization. Let's say your two more friends, okay, are the only workers in the organization. Now your manager, your contractor, okay, is continuously giving you a task. Hey, just do this. Hey, just do that. Hey, just do this. Hey, just do that. Just ask them, create a queue and put the task in that queue so that that developer can take the task according to the prioritization. It is not possible to work on 10 different things parallelly. I know this is the thing that is going on in the corporate industry right now. So they also need to build a system where there will be a queue so that developer knows the real prioritization. Second, manager knows the, you can say, priority, what you need to ask from a developer to do. Instead of just throwing 10 tasks, the one person cannot perform 10 tasks in parallel. No, not at all. So this is that queue. I know this doesn't exist in the real world, in the industry right now for the corporate world, but this exists for Airflow. Very well done, because Airflow is actually built by a developer and developer knows the pain of that particular thing. So what will happen? This worker will not just take random tasks. No, this executor, this, you can say, what was the name? Conductor? No, conductor. What was the name? Wait, I have just written it here. Yeah, contractor. So contractor. So this contractor will put the task in this queue so that workers can work on the tasks which are prioritized. They know that, let's say, this is the latest task. So they need, latest means like this is the first priority. So workers will, any available worker will take this task which is the prioritized one, not the random one, or not you can say the least prioritized one. So that's how queue works. And by the way, if you do not know, and this is actually a kind of advanced thing, there are two types of queue. One is execution queue and the second one is the actual queue, Redis queue. Okay, and we will just talk more about this thing in the architecture, don't worry. And then we have, let's create this queue here. Oh yeah, that is fine. Let's talk about the triggerer. Ansh, Lamba, it's called trigger. I am talking about triggerer. It's triggerer. What is triggerer? So let's say you are working on a task. Okay, let's say you are a developer. Again, you and your two friends. Okay, you three are working on different tasks. Now, let's say you are assigned a task. Okay, and the task is very simple. What is the task? Let's say I have let's say run a pipeline, and you just need to monitor it. Or let's say I have made an API call, okay, and I am waiting for the response, right? Or let's say you have written the email, so you were assigned a task where you need to write an email to, let's say, a stakeholder, and you need to resolve the query, whatever error they are facing. Simple. Now you just send an email to that stakeholder, right? And you need to resolve the query, resolve the, you can say, problem what they are facing. But now you know that you are idle, right? Not IDOL. You are IDLE. You are idle. That means you sent an email, but you are not working right now. You are just waiting for the response. You are just waiting for the email reply from the other end. In that particular scenario, you cannot say like, I am busy. You are not busy. You need to pick another task in the meantime that you receive the response. That is the work of triggerer. So what triggerer will do, triggerer will take your work. So let's say you send an email, okay, And what will happen then? You will hand over that task to the triggerer. Who is triggerer? Let's say triggerer is the junior developer in your team who is just shadowing you all three, right? So what will happen? You have sent an email. Now you know that you are free and you will only respond or you will only help the other person when you will receive that email back, right? Simple. Now what will happen? You will send an email. Okay, let me just draw it for you. Then you will understand better. Let's bring those two developers. Let's say this one. Let's say this is the senior developer and this is the junior one. Okay. Just a hypothetical situation. No favorism here. So let's say this is the senior developer. Okay. She sent an email to the other person, to the stakeholders. Okay. Let's say these are the stakeholders. Make sense? Okay. Now this was the task to resolve their problem because they are facing some problem, maybe some technical glitch or something else. So you need to assess them. Okay. So now what will happen? Now let's say, okay. So now what will happen? You have sent them the email, but now you know that you haven't received the email back. So you are free. So now what you will do, you will take another task. Okay. Let's say this was the queue. This was the first task, email. Okay. And you are working on this task for now. You have completed some percentage of this task because you sent an email, but you are waiting for the response. Now you are free. You are logically free. You cannot sit free, right? So now what you will do, you will hand over this task to this particular person and you will say, "Hey," respectfully, "Hey, okay." You will say, "Could you please take care of this? Could you please take care of this task? In the meantime, I receive any response so that I can take the other task." Let's say this task. This task is, let's say, writing a script or processing the data or making an API call. Let's say API. So what will happen? Now this worker will start working on this task, and in the meantime, this user has responded to that email back. So now what will happen? Now triggerer will know this thing because now this person is working on this task. Now this person will go back to this person, this senior developer, and will say, "Hey, I have received the task." Okay. So now this person can say, "I am currently working on API call, but I can take your task as per the prioritization." As per the prioritization, let's say this is the prioritization, or let's say there were already some tasks given here. So let's say this, like this. And then after this task, I can take this task as well. And it will be decided by obviously the scheduler. But now it will go back to her bucket, right? See, like this. This is the flow. This is the concept of triggerer. And obviously, like, you should just talk to this junior developer with respect, obviously. So that's how it works. That's how it works. Okay. This is the concept of triggerer. And these are all of the core components. And let me just tell you one good thing. You have already understood at least 50% of the architecture already. So that is a very good thing because now you know how things are communicating, how things are like actually doing the stuff. Now I just need to, you can say, combine all of the things that we have studied, putting it all together, and that's it. And you will actually understand it. But now the actual hard work to understand the architecture is 50% done. Or I would say more than that, more than 50%, 60%, I would say 60% done. So that is a good thing. So that's how we learn with fun. Okay. And that is why this channel is specifically for those learners. And again, I'm saying just hit that subscribe button because you need to do that. You need to do that to support my hard work. Okay. Because I need your support. Okay. So now let's actually talk about the architecture. Okay. So now let's talk about the architecture, the Airflow architecture. And this will be like very important. But it will be easy now because now you know all the components, right? Okay, so now just talk about Airflow architecture. Important, everything is important, but this is very, very important. And if I just talk about the interviews, a lot of questions will come from this area alone. Okay, so what actually happens in the Airflow architecture? Okay, let's try to now put all the things together. How does it work under the hood? So let's say you are a user. So let's first of all get the user. So let's say this is the user. Perfect. So this is the user. Okay, so now user is just a developer, you can say. Developer who develops the DAGs, who writes the code for DAGs. Simple. Okay, so now first of all let's bring the DAG. So let's say you created the folder, which is the DAG folder. Okay, DAGs folder. So this folder is created by you, obviously, because you own these folders, and these are nothing but just the Python files. Okay, and you can just rename it as, let's say, dag.py, whatever name you want to give. Okay, perfect. So this will be my DAGs, all the DAGs. So all the DAGs are now contained in this particular thing. Okay, simple. Okay, simple. This is my development. Okay, this is my development. So now what will happen once I have written the DAG, then we know that DAG processor, what DAG processor, let's say this is the DAG processor, let's imagine. Okay, DAG processor will do what? Will parse these DAGs, right? Okay, and what will it do after parsing it? It will store this DAG into the database, right? Let's bring the database, and for this particular case we use Postgres database, if you do not know about this. So I will say metadata DB. Remember, this is our metadata DB. Perfect. So this is a database where you want to store the serialized DAG. Perfect. Let's do it. Simple. So this will do this particular thing. Okay, nothing fancy, nothing special. Okay, now as I just mentioned earlier, this will not do this particular storing directly. How will it do that thing? Using API. Okay, let's bring that API. Let's say this is our API. Where is that DNS? Where is that DNS? Let me bring it from here. Okay, API. So let's say this API. So now as your fundamentals are clear, now you can just understand this thing. So it will use this API to store this data into this metadata database. Okay, first of all, just a kind of quick information. All of this architecture that I'm referring to is from the latest upgrade, because in the previous version of Apache Airflow it was totally different. So if you're coming from the previous Apache versions, do not feel like, hey, what this guy is telling, this is not true, this is not right. So this is as per the most recent architecture upgrade. Okay, so just cool. So now this will use this API, and then this API will just store this data inside this database. Simple. Okay, perfect. Because we cannot directly talk to the database in the recent upgrade. Okay, this is a kind of in-place API, or basically you can say you do not need to actually hit an API. This is API which is integrated within the DAG processor. You do not need to do anything here. It will do everything on its own. Okay, so first task is done. Now once the DAG is stored in the database, immediately scheduler will come into the picture, right? Scheduler, let's say this is our scheduler. let's say here, this is our scheduler. So now what this scheduler will do, scheduler will process the information. Process means it will read all the DAGs, okay, and it will create the DAG runs, okay. And how it will just read that? Same thing, using API, okay, simple. So scheduler will talk to the database because it needs to fetch the information, right? Let me just say, let's say reads DAG, okay, reads DAG, and because it needs to schedule, it needs to see like what information you have provided in the DAG, at what time it needs to schedule. So it needs to get all of that information that you have provided in the dag.py file. Simple, simple. Then once scheduler gets that information, scheduler will store all of that information in a queue. Remember queue, we talked about it, right? This queue will have all the tasks like this. Let's say this, let's say this, and this queue is the execution queue. Remember I told you that there are two different types of queue. So this is called execution queue. This is not the final queue. This is the queue for the executor, not for the workers. Makes sense? Now once we have the tasks ready in the execution queue, then executor will come into the picture. Executor will come into the picture. Let's say this is an executor, okay. Let's say this is an executor. Now executor will decide what strategy for these tasks. Remember we talked about it. So all of the strategies will be decided by the executor, and now this executor will create a kind of, or basically not create, will put all of the tasks in the real queue, or basically in the Redis queue, which is the queue that everyone talks about, but with the strategy by executor. Simple, very good. So this is that particular thing. Let me just change the color just for the simplicity. Let's say this, or this, or let's say keep the color same for the tasks. Let me just change the color for this. Let's say this one, okay, simple. So this is my Redis queue, okay. Now once we have the tasks in the Redis queue, then we can call our executor, worker, executor. I'm just taking your attention. So now you can say your worker will come into the picture. Well, let's use a different icon. Let's say this is good. This is nice. Let's say this is the worker. So now this worker will come into the picture, and worker will say, okay, I will do the work, okay, and I can take the work from this particular Redis queue. Remember the prioritization order? Same logic. Perfect. Now worker has also you can say taken the work. Perfect. Now what it will do? It will execute the task, obviously, because worker will execute the task, and it will write back the results, whatever the status is, back to the database, but via API. Very good. This is important. Right? Now if by any chance we have, you can say, any task which can be deferred, that means it is in the idle state and we do not want to do that. So what we do, we mention the defer function in our DAG. So let's say I'm just making an API call to process the data using a notebook. It can be an API call to AWS, Databricks, Azure, anything. And I know that processing a notebook will take time because we are using Spark notebooks to process the big data. I know it will take time. So I can use a defer function. So now what defer function will do? Defer function will call our triggerer. So then that work can be, you can say, handed over to the triggerer. Make sense? So this can be linked like this. This is a kind of triggerer. Simple. Or let's say this one. This is my triggerer. Okay. And once the tasks are done, basically, once the idle state is over, then obviously the rest of the code need to be executed, because let's say I have used defer function in the middle of my code because I know it will take time, but after that middle of the code, rest of the code need to be executed. And who will execute that? Obviously worker. Triggerer cannot do that thing. It is just a junior developer which just monitor it. That's it. But then triggerer cannot directly hand over the task to worker. No. Triggerer will simply change the state of the task, and that state will be stored in the database. So I can just create one arrow like this, which will contribute through the worker. Makes sense? Like this. And then this information will be saved in the metadata database. And then again, scheduler will pick that information. It will put that task in the execution queue, then Redis queue, and then the same thing. This is the complete cycle. Or you can say this is the complete architecture for Airflow. This is the complete architecture that I have taken from the most recent upgrade. Make sense? Now, let's talk about one important thing. If you will go on, let's say, Google or any browser, if you try to, so first of all, this is the most recent one. That means all of the potential changes are here. So how do I know about the potential changes? No, I cannot like do the time travel, but let me just tell you how do I know and how these changes will be coming, even if it is not in the official documentation, because these can be like in progress or in process changes. So if you go to the documentation, okay, and why I'm just telling you this thing, so that you, because you are representing our community, right? Our data fam community. So you need to tell this architecture, first of all, because this is the most authentic one. But along with this, you need to tell one more thing. You can say, if you just go to the Airflow documentation, Airflow architecture, and if I go here, you will see only one difference here. This is the one. So if you see the arrow in the latest one, we only have the arrow with the API server, and we cannot directly talk to the metadata database through any other component. Make sense? This is according to the documentation. Okay. I know there'll be like so many changes here as well, but I'm just telling you one thing. So, okay, there's like just one connection. But if we just see our architecture, we do not have any other way to talk to the metadata database through API. And do you know why? Let me just tell you. Because in this particular official architecture, all these components are also talking to, you can say, database through API, but these are in place APIs. These are not actually the API that you are considering, let's say API server. Because see, you as an Airflow user obviously click on a button and then it triggers an API. So this is a kind of explicit, you can say, action. But when scheduling, parsing, executing, all of that information need to talk to database, they will also call APIs, but those APIs will not be like very explicit action. These will be like in place actions. So you need to remember this thing. This is very important. That is why you are seeing arrow from here as well. But this API is the same API. You need API server to talk to metadata database. You cannot talk to metadata database directly in API, or basically in Airflow 3.0 plus or 3.1 plus. Make sense? How do I know all of this information? Let me just tell you. So this is the answer. So if you already are familiar with Airflow and all, you would know that this is the most popular book, or I would say this was the, or first edition was the most popular book, and I can say this was the source of information, source of learning for every developer who learned Airflow in the past. Recently, this same book, which is called Manning publication, okay, this same book has recently launched the second edition. Most recently, I think it was launched on 25th or 26th of January. Today is 28th of January, so it is just launched 2 days back. I was waiting for this book since last year because I knew like they've launched something called an early access book, but I knew like it would be coming next year. So today, or I can say like 2 days back, they have officially launched this book. And if you see the architecture within this book, this is the architecture that they are talking about. Same thing. Okay. And this is the book that is also, or I would say that is also highlighted on the official website of Astronomer, which is the most trusted and most reliable way to host or basically deploy your Airflow, DAGs and all. So this is the kind of architecture that you would see there as well. And you know the reason between the confusion. So this is not actually a confusion. You need to be very clear while explaining the stuff. Make sense? Because not everyone will say you, hey, you need to just call these things through API. But when you actually read the book, when you just get the details in, you can say knowledge in detail, then you know like what is the reason behind it. Make sense? So yes, this architecture is also correct, but they are just making the in-place APIs, or you can say APIs which do not need any kind of explicit action from your end or from your, you can say, development. But yes, they are talking to this database directly through this API, not directly through this, you can say, database itself. No, every communication will be made through API. Just remember this thing. And yes, if you are interested to read this book, obviously go and just read this book. This is an amazing book. Okay, so you should just know about these things. So that's why I thought of just sharing this information with you. I think they have recently launched on 25th or 26th of January. I'm not sure, but yeah, it was recently launched. Okay, so this was information that I was very excited to give you, because you will say, hey, we are just seeing something different in the documentation, we are seeing something different, blah, blah, blah. So this is the answer. You need to know about these things. Okay, makes sense? So that's how your Apache Airflow architecture work under the hood. And I hope now you know every single component, every single thing, when I just put all of these things together. Make sense? Okay, now let's see what do we have next. So now let's talk about the core components, and these are like very, you can say, development specific thing which you can just learn on the fly when we'll be just learning the code as well. But still, it's my duty to give you all of the information. So let's say core components of Airflow. I think we discussed the components. Oh, sorry, not components. Like these are concepts, I guess. Yeah, because I think we discussed the components. Concepts. So these are just, you can say, like concept, because I don't know like how to explain concept. What is concept? Concept is just a concept that we build, that we deploy, that we render, that we parse, all of these concepts. The first thing is DAG. Oh, finally. See, you already know DAG. Let me just tell you. This is just a fancy name for workflows. So DAG means directed acyclic graph. Now you know that we have talked about this particular workflow, right? This one. If I just say this is a DAG, okay, why this is a DAG? Because this is a workflow. So can we say every workflow is a DAG? Like every flow, every series of steps or nodes is a DAG? No. This word is important. Acyclic. This is important. Directed acyclic graph. Directed means we need to tell the direction. Like this will go from here and then from here to here, then from here to here. Basically the order. Graph is graph, like the edges and nodes. This is the box, this is the edge, this is a box, this is the edge, these things. Acyclic means this cannot create a cycle. That means after running the task 4 or task 5, it cannot run like this. Let's say like this. It cannot go back. This is the definition of acyclic. It cannot create this cyclic graph. Because what will happen? This will create a recursive loop if we just create this thing. Oh yeah, makes sense. Because let's say this task is running, and then after this task is running, this will just create another instance, and then it will be like keep on going and going and going. So this is the only difference between DAG and a workflow. Only difference between DAG and workflow. Simple. So you cannot restart the DAG or basically restart the workflow on your own within your logic. Okay. So this is the only difference. So this is not allowed. Okay. So I can simply say this is not a DAG. Wow. Okay. And what is a DAG? Without this cyclic graph. Simple. So if I just remove this thing, it will become a DAG, a cyclic graph. Simple. This is the only difference. That's why I told you like DAG is very simple, just a technical name. Now let's talk about the task instance. Now what is a task instance? Okay, let's talk about it. So if we say task instance, now you would know that, see, this is my task, right? This is my task, this is my task, this is my task, this is my task. What is a task? Task is just a single unit of work, right? Single unit of work that I want to perform, let's say, an API call. Here I want to perform or basically run the SQL script. Here I want to run a bash script. So task, just a piece of work that what I want to do. It's just a unit of work. Simple. Or you can say it's just a single unit of work. Simple. Got it? Okay. So this is a task, this is a task, this is a task, this is a task. Task is just a work that you want to do. And one pro tip, in each task, try to be granular as much as you can. Let me repeat. Try to be as granular as you can while defining the task, because task should be very, very specific and very, very granular. What is the advantage of it? Let's say in your task, you have written 50 lines of code and you are just doing so much of stuff in that task. Let's say that task failed. And now out of those 50 lines of code, you will take so much of time to debug what actually went wrong. But when you have granular tasks, you can easily debug the things very, very quickly. Trust me. So just try to make your tasks as granular as you can. It will be very helpful. It's a pro tip. Otherwise, it's your choice. You can just write 1,000 lines of code in one task and just keep debugging and keep debugging. Okay? Just your choice. Then we have one more thing. Operator. Now what is operator? Operator. And a lot of people get confused between task instance and operator. Operator is what? Operator is basically, you can say, the category of task. Like what type or what kind of task you want to run. Let's say I want to run a Python task. So there will be a Python operator. Let's say I want to run a bash task. There will be a bash task, bash operator. Let's say I want to run a SQL task. There will be a SQL operator. So there are so many operators. So operator is nothing but just a predefined kind of template that defines a specific type of task, or basically what category of task it is. Make sense? I'm just explaining you the concept from the understanding point of view. I can just show you the official documentation and I can just show you the definition written in that documentation, and then I will just ask, hey, keep learning and just try to remember everything. You need to understand what is an operator. If I just go on, let's say, any browser, what is operator? Operator in Airflow. Oops. So it is doing whatever. So operators. Okay. Operator is conceptually a template for predefined tasks that you can just define declarative inside your DAG. Did you understand anything? So fair. That's what I'm saying. Airflow has a very extensive set of operators available with some built into core pre-installed providers. Some popular operators from core include. What is this? What is this? What is this? What is an operator? It is the category of a task. Simple. Simple. This is like half line of definition that you need to write in your documentation. Simple. Why are you just using so much of technical language? It's not just about technical language. It's like writing something else. So in short, operator is nothing but just a kind of category of what type of task you are running. You are running Python task, SQL task, a bash task, or any other task. Just tell me. It is just a category. Okay. And the good thing is it is kind of template, pre-built template. That means it can save a lot of time for you. For example, let's say you want to run a SQL script, right? So if I would ask you just do it on your own. So what you will do, first of all, you will create a connection with your database. Then you will create a cursor. Then you will write your command. Then you will execute it. Then you will just close the connection. In Airflow, there is an operator called SQL operator. It will automatically create the connection. It will automatically run the query. It will automatically close the connection. So that means there are some predefined categories that we can directly use. Obviously, we can do everything on our own. I know like you are very, very talented. You can do everything on your own, but there are some operators that we can leverage to save time and to make our development efficient. Okay. It's the pre-built template for our tasks. It basically tells Airflow what type of task we are running. Simple. Yes. So these are the, you can say, core concepts of Airflow. Perfect. So now let's quickly jump on to the Airflow installation. Now there's a very good news for you. And the good news is Airflow installation is the most critical part of the entire thing. I would say more critical than learning because one small mistake, one small, you can say, due diligence will just mess up with the whole on installation. So just be very, 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 very careful. Okay. Okay. Makes sense. But don't worry. I will just help you as much as I can to install Apache Airflow because do you know what? Airflow is an amazing framework. And in order to deploy and in order to manage Airflow is not an easy task. It's not an easy task at all. That is why we have solutions such as Astronomer, and obviously in AWS as well, we have the managed Airflow solution. In Fabric as well, we have managed Airflow solution because it is very similar to Apache Spark. Because in order to scale Apache Spark, it requires a lot of networking resources and so much of things, right? So similarly, Airflow as well. But don't worry, I will just show you everything, how you can just install Airflow. And the best way to install Airflow locally is using Docker. Yes, using Docker. Without Docker, it is next to impossible to work with Airflow locally. And you just need a Docker installed on your machine. Okay. Okay, makes sense. And before that, let me just tell you quickly one more thing, a very quick thing. By the way, it is not actually required, but still, because I want you to know everything. So if I just talk about the architecture, because I was just looking at the list that I just need to cover here. So I was just looking at the point. So let's say we are just talking about the Airflow architecture. So here the thing is, whatever thing we are doing here, we are doing on a single machine. Because we are learning Airflow within our machine. So this is a kind of single node architecture. Makes sense? But in the real world, when you have more and more resources, when you have more budget because you are working in an organization, this particular architecture can be isolated for each specific component. For example, you will have a dedicated machine for API server. You will have a dedicated machine for database. You will have a dedicated machine for worker or multiple machines for workers because there can be like so many workers, right? There will be a dedicated machine for executor. So that's how it works in the real world. It's not like actually a very big thing to, you can say, understand because it's very obvious because we are just learning Airflow locally. So everything will be running on our machine. If we just go in the industry, there'll be like clusters running. There will be like each component be running separately. It's not a big thing, but still I wanted to mention this thing and I can just show you multi-node architecture. Airflow architecture. Let's see if we have it here. Oh yeah. So this is a kind of distributed airflow architecture. So here you can see that parsing, scheduling, executing is actually working on different, you can say, environment, and then you have DAG files in a different environment, then you have API server in a different environment, you have metadata database in a different environment. So you can just keep all of these things separate. And you know what, there's not just one architecture for keeping things differently, because it's totally dependent upon the requirements. Let's say I will just run all of the things in one machine, and I will run the database in other machine. It's my choice. But yes, I would need to take care of the communication between those machines as well. So that is why you see a lot of architectures here. So one is this is the standard one, like how things communicate to each other. This is like the architecture for the component level. But then they just talk about the multi-node architectures, where we just talk about so many machines, right? So that's why you are seeing so many things. See, this architecture is totally different from this one in terms of communication. Then you will see this one, because it's my choice how I need to just put all of these components in different machines. Because when I am the owner of so many machines, it's my choice how I just need to scale it up, right? So it's all about that. Small thing, but you should be aware of it. Perfect. So now let's talk about the installation. And when we just talk about installation, I will simply ask you to do one thing. What is that? First of all, download Docker. Yes. So go to your favorite browser and simply search Docker download. And go to Docker desktop. Perfect. Do not download the Docker engine only, download the Docker desktop. So download Docker desktop, you can just download it. If you are on Mac, download Mac. If you are on Windows, download for Windows, AMD 64 or ARM 64, whatever. And if you are on Ubuntu Linux, download it for Linux. Okay. You need to download Docker for sure. Okay, good. Now, this is not the only thing. Okay. And even before downloading Docker, you need to make sure a lot of things. You need to have some prerequisites. Okay, so just hold on. Do not just directly click on download Docker. You need to know some things. Okay, let me just bring it here. What are the things that you need to know? So I have already created a very detailed video on Docker. If you haven't watched that video, I don't know what are you doing, bro, because you should know Docker in 2026. Because in the world of AI, you need to know Docker, and you do not need to learn Docker for this particular course. Don't worry about that. But if you want to download Docker, I will also show you in this video as well. Don't worry. But if you stuck anywhere, I will just provide you the resource so that you will have a helping hand by your side. Okay, just go to your favorite browser, just search Docker full course, or just search Docker Ansh Lamba. Whatever topic you want to learn, just name that topic and just put Ansh Lamba after that, and that's it. Okay, so this is a masterclass that you can just watch. Okay, in this masterclass, obviously it is a full course for Docker, but there is a dedicated chapter for Docker installation. Just click on that chapter directly and just see if you feel stuck. Okay, wherever. If not, then obviously it is good. But I have provided you a kind of helping hand which will take care of you if you feel stuck. Okay, good. So now what are the prerequisites that you need to take care of? First of all, virtualization. Your virtualization should be enabled. Now, how can you just check virtualization? So just go to task manager. Just go to task manager, and this is a task manager. In the task manager, you can go to performance, and in the performance, you will see virtualization enabled here. See, so this is automatically enabled if you are on Windows 11, and if you are on Windows 10 as well, I think it should be auto enabled. If not, then you have to enable it using BIOS. Okay, but I think so it will be enabled in your case. If not, you can just simply search for like how to enable virtualization. There are like so many resources, so you do not need to worry about that. Okay, this is the first thing. Then you need to enable WSL2, which is Windows subsystem for Linux, because see, you need to use a Linux machine under the hood if you just want to run Docker. So you need to enable WSL2. Okay, so how you can just enable WSL2? So what you can do, you can simply search Windows features on or off. Okay, so obviously I can just show you Windows features. Simply go to your search bar of the Windows and search Windows system or services. Windows features. Where's my machine? Example, Windows features. where is that pop-up? Yeah, Windows turn features. See, it will be like this. So simply search Windows features in the search bar of your laptop and then just look for two things. Okay, two things. Windows subsystem for Linux. Just scroll down, you will find this Windows subsystem for Linux, first thing, and virtual machine platform. These two things should be enabled both, and just say okay and restart your machine. Yes, because it will take time to be affected. So you just need to restart your machine. Once it is restarted, once the machine is restarted, okay, then install Docker. Then just download Docker from here. Okay, then once you install a Docker, then also restart your machine. Yes, you have to do it. Once you have restarted your machine, and if you open Docker, okay, because your application is installed, just simply click on that on that application, Docker desktop, and it will ask you to sign up. It's a good thing you can sign up, okay, because it will help you to create your account and you can just access it to create or push the images to Docker Hub. It's totally out of the box, but you can just create account. It's good for you. Okay, now we know that after installing Docker, okay, and we have just restarted the computer as well, it can prompt you to install WSL2. Just say yes, because it is very important. It will just make your life easy. Okay, it will ask you. If by any chance you ignored or you didn't say yes, then what you can do, you can manually install WSL2 using the command line in the PowerShell or in the command prompt. So simply go to your PowerShell, Windows PowerShell, and simply search, or not search, simply type WSL install and hit enter. Invalid command line. Very good. Let me just open command prompt. Command prompt. Okay. WSL install --. So in my case, it is showing that it already exists. So in your case, it will be installed. Okay. Once it is installed, you need to check that it is downloaded or not. Then you need to say WSL and list and then V. Then it will show you, in your case, it will just show you one thing. Don't worry about that, but you should see something. Okay. You should see Docker desktop running because you do not have Ubuntu for now. You will just see Docker desktop running. If you see both, it's good, but you should see something. Make sense? Okay. This is also done. Now what you need to do, you need to open your Docker desktop setting. Okay. First of all, let me just open the Docker desktop. Let me click on Docker desktop. And just ignore if you see any of the stuff that is not in your case, because I have some development. So I have started Docker desktop. Here it is starting the engine, and I can directly go to the settings tab here, and it will take some time. Okay, so this is my settings page. So in this, you should see the resources. So this is my resources tab. Now here you should see that you are using WSL2 backend. So resource limits are managed by Windows. So you should see this thing. In the backend, you are using WSL. Very good. Now you are all set to install the, let me minimize it. So now you are all set to install the Ubuntu. Okay, Ubuntu, which is a kind of Linux distro. So now you need to install an Ubuntu distribution. So you can run the following command that I'm just showing you. So it is saying WSL and then install -d Ubuntu. Make sense? Then just simply hit enter. Invalid distribution. Yes, Ubuntu. What is Ubuntu? Ubuntu. So in my case, it already exists. In your case, it will ask you to enter new password, enter new username and password. You can just put username and password, whatever you want to put. Okay, it will not ask you again and again, but you can just simply put it. Okay, then you can simply say WSL list -v, and that's it. Now you will see Ubuntu running, Docker desktop running. Make sense? Now your Docker is fine. So congratulations, because you need to follow all of the things step by step. Do you know what? When I was learning Docker, oh man, I was like, I was totally like checking so much of things. Because I'm not saying like there were no resources, there were no structured guide how we can just download it. I'm not saying that, but I don't know. But then I thought like let me just create one simple step-by-step approach which can actually help others to learn Docker, and it worked. Okay, so now our Docker setup is done. Now we need to set up the Airflow. Okay, now what we need to do, now we simply need to open any code editor. So now you can use any code editor. Okay, you can also use VS Code if you want to. You can use anti-gravity. You can use PyCharm as well, whatever you want to use. I don't like PyCharm, but you can just use if you want to. So let me just quickly open my VS Code editor. Okay, let me just do that. So this is my VS Code editor, as you can see. So currently we do not have anything in the VS Code folder that we have opened. As you can see, I have created this folder, Airflow tutorial. If you do not know how to create folder in VS Code editor, very good. Go on file and click on open folder and open the favorite folder that you want to open, but make sure it should be empty, because we will be just putting so much of stuff here. It should be empty. Very good. So now once everything is done, once we have Airflow, not Airflow, Docker ready. Now what we need to do, we need to first of all make sure our Docker is up and running in the background. How you can confirm? Just make sure like Docker app is running like this. And you know what? Let me just tell you one pro tip about Docker, because it can just trip you or trick you if you do not know about Docker. If you just close this task, right? And then if you try to open the Docker desktop again, it won't open. Do you know why? Because it is already running in the background. So how can you open in that particular scenario? If you just go in the right bottom corner of your screen, and you will see a little arrow like this, and it will say show hidden icons, right? The small upwards arrow in the bottom right corner that pops up a tray. In that tray, you should see a Docker icon, the white color Docker icon. And if you hover over that icon, you will see it is showing Docker desktop running. So you can click on that button, then it will just open the Docker desktop app. Otherwise, if you will just try to open it after closing it, it won't open. So it is like how that Docker desktop runs. In simpler case, restart your computer, bro. Okay, simple. Okay, make sure Docker desktop is up and running. Simple. So now my Docker desktop is up and running. Now what I will do, I will create a kind of directory. What type of directory? This directory, Airflow tutorial. In your case, you can also create the same one, but don't worry, I will also push this code to my GitHub so that you can just download the resources, all the code files, everything. Perfect. And you will find everything there, notes, code, and requirements.txt if I am just downloading anything extra, everything. Okay, so do not worry at all. You will get everything. Because see, I'm really possessive for you. Do you know what? I learned about this word when I was in class 8, because there was a trend going on at that time. Hey, he is possessive. Hey, she is possessive. I was like, what does it mean? And then I got to know. Okay. So now what we need to do, so we will simply create 4 different folders under this root directory. Folder number 1 is DAGs. Perfect. Folder number 2 is plugins. Okay. Folder number 3 is config. Okay. Folder number 4 is logs. I want you to create these 4 folders for sure. Okay. These 4 folders: DAGs, logs, plugins, config. Make sure the spelling SSS, DAGs, logs, and plugins, and config, only config. Okay. Don't worry. All of these folders will be fully filled with the resources very soon, but these are empty for now. Now what you need to do, you need to go to your favorite browser and simply search Airflow Docker Compose, because there is a file, official file, which is provided by the Airflow itself if we want to run Airflow on Docker. Okay, and if you just scroll down a little bit, then you can see that file. Don't worry, I will just provide the file, by the way, in my GitHub repo. You can directly download it from here, but let me just search it. You should fetch this one. Let me just click here. It will download this file, docker compose.yaml. Okay, this is the file that I need to docker compose.yaml. I think so. This is the one. Let me just check. I will just check. So you need to download this file. Okay, cool. Let me bring this file in my root directory. Remember, in the root directory. So this is the file. Let me just check. Yeah, this is the file. Perfect. So this is the file that I have brought. Make sure I'm repeating it again and again because you can mess up. So you need to make sure that, let me just move my camera a little bit here. Perfect. So you need to make sure that your Docker compose file is available at the root directory level where you have all the folders listed. Make sense? Very good. Now this is the kind of Docker compose file which will create all of the containers, all of the Docker containers. Ansh, Lamba, we do not know anything about Docker container. Okay, so it will create all of those components that we have discussed, the web server, database, worker, scheduler, executor, everything. It will create everything for you so that you can work with Airflow. Simple? Very good. But before running this file, there are some changes that you should make in your file. Okay, now what are those changes? So first of all, once you have downloaded this Docker file, Docker. So once you have downloaded this Docker file, and you can obviously easily download it from GitHub. So you need to just look for two things. First thing is, if you just scroll down, I can directly search it. Simply say Control F and go to 5432. Okay, there's no 5432. Wow. Just go to port. Okay. I want to go to different port. Okay. Where is that? Oh, okay. I can go to Postgres because I know they do not define it. I don't know why, but it is what it is. So just go to Postgres. Okay. So what I'm trying to do, I want to see, this is the Postgres service. This is what? This is actually the metadata database that we create in Airflow. Everything is perfect. Everything is perfect. Just one thing is missing. So let's say I want to access this database that I want to. So in order to access this database, I want to allow its port mapping with my local machine because everything is running in Docker. That's why I always ask you to learn at least the fundamentals of everything. Here, if you would know the fundamentals of Docker, it would help you a lot, but don't worry, I will just tell you. So what happens is, whatever you run in Docker, okay, is isolated, is running in an isolated environment, is totally unaware of your local machine. Okay. So whenever you run Postgres database, you access the database on the port called 5432 of your machine. But Docker is running in an isolated environment. We cannot talk to that database. We need to allow port mapping. It is called port mapping, right? Okay, very good. So now I will simply write one code and do not worry, just copy and paste. But I wanted to explain you this thing because you should know why are you just doing that and what are you doing, right? So it's very simple. Simply go to your service, whatever you have, okay, and just simply type this word. It's kind of YAML format, so just make sure you are not adding any extra space or any tab. It is very important. So simply go here and hit enter, okay, and hit backspace because you need to make sure that you are at this level, at the same level. Let me just expand. Ooh, it is fine. So let's say at this level and simply type ports. And I'm getting a suggestion. Very good. 5432 and 5432. What does it mean? And save the file. It means 5432 port of Docker should be available on the 5432 port of my local machine. Perfect. This is the one thing that you need to do. Second thing is, which is very, very annoying, that we need to turn off, which is called Airflow examples. Do you know what? Whenever we just create or basically start our Airflow, all the services, what is it saying? Yeah, it's fine. So whenever we just start anything, it creates 80 plus DAGs out of nowhere just for the samples, and it is very annoying because if we are learning something new, it will be next to impossible to find your particular DAG within those 80 plus DAGs. So let me just turn it off quickly and let me just search. It's called, I think, Airflow something, I think examples, I think load examples. Oh yeah. See, Airflow core load examples. It is saying true. I want to say false. Perfect. Once you have made these two changes, you are good. You are good. So now what you need to do, you simply need to write or basically run a very, very, very popular command. Okay. And this command is called docker compose up. But before this command, I want to just create a virtual environment. Why? See, everything will be running in Docker for sure. But you know what? When we will be writing our code, we will be using Airflow libraries and all, obviously, right? In that particular scenario, we will be seeing so many warnings, so many, you can say, type errors. And I do not like that particular thing when I'm developing something. So just to eliminate that particular thing, we can create our own virtual environment where we'll be having Airflow library installed. Okay, Airflow library installed. It is not required to run your code. It is just for your own development. Okay, it has nothing to do with your, you can say, your Airflow container which is running in Docker. No, it is just for your particulars, you can say, development. Okay, makes sense. So how can you just create a virtual environment? It's very easy in Python. Okay, there are multiple ways, but I personally prefer creating virtual environment with UV. I love UV. And if you do not have UV, just simply type pip install UV and it will install UV in your particular case. In my case, it is already installed, so it is saying requirement already satisfied. UV is a kind of modern Python package manager which has totally just change the game of how you manage the packages. Okay, so now UV is installed. I can simply say UV and hit enter, and you will see this particular guide. And if you see this guide, that means an extremely fast Python package manager. Wow, it is actually fast. It is, I think, written in Rust. It is very fast. So you should see this thing that make sure that you have successfully installed UV. Now I will simply say UV init, and that's it. And it will just create all the things automatically. And it has already started the Git as well. We do not need to create Git, but it creates that thing as well. I love it. So now, perfect. If I just go to Python version, I can just see the Python version. And in your case, it will just pick the default Python version of your system. Perfect. Now I will simply say UV sync. It will simply sync all of the dependencies and it will create a virtual environment automatically. Hit enter. Boom. Okay, perfect. I can see the virtual environment created for me. And this is the best way to create virtual environment in 2026 onwards. Okay. Just a pro tip. Perfect. So now I want to install any library in this virtual environment. First of all, I need to enable it. So the best thing about VS Code Editor is if I just close this terminal and if I open it again, it will automatically enable this virtual environment automatically. It will take, I think, just few seconds. And bro, I was just talking good about you. And now see, you are not working. Very good. Slow clap. So if it doesn't work, we can also manually enable our virtual environment. So how you can just do that? Simply go to .venv, .scripts, then .activate. Hit enter and then it is activated. As you can see, Airflow tutorial, that is my folder name. That means like I am now inside my virtual environment, not the global environment. Pro tip for data engineers. Okay, Airflow tutorial. Now I will simply go to this particular environment. Make sure you are also inside this. Then I will simply write UV add Airflow. I think the name of the library, let me just search. I think it is called Apache Airflow because they recently renamed it. Earlier it was just Airflow. Apache Airflow. Hit enter. And now it is downloading that package in my virtual environment. Perfect. Oh, wow. There are so many files. So in order to confirm this particular package is installed, you can simply see this package in the toml file. See Apache Airflow 3.1.6. Perfect. So that's how it manages all of the dependencies in the UV. We do not need requirements.txt. So it was an old school method. Perfect. So now we are all set to start our Airflow. I will simply write one command now and make sure you are inside this virtual environment. I will simply say, and just make sure that you are inside this dedicated folder where we have this docker compose.yaml. See, I have the docker compose at this level Airflow tutorial and I'm running this command from here because we need to run this command where we have the docker compose file. So I'll simply say docker compose up -d. -d is very important because it will open the or basically run the docker containers in the detached mode. And it is a good practice. Otherwise you will be seeing all of the logs flowing in your terminal and you will be like, what's happening? Simply hit enter and boom. Oh, very good. That happens and that should happen in your case as well. You need one more thing which is called Airflow UID, which is a kind of environment variable that you have set. Not you, basically Airflow has set it for you. If you just go here, you will see Airflow UID. Let me just search it for you. See, Airflow UID that you have to pass. See, Airflow UID. So now I will simply pass this value in the .env file. Just create .env file at the same level where we have this folder. So I will say .env and I will say Airflow, what was the name? Airflow UID? Yeah, Airflow UID equals to 50,000. Make sure 50,000. Okay. Now let's run the same command again. And perfect. Now it will pull all the images. From where? From the Docker Hub. See, Airflow trigger, Airflow init, Airflow worker, scheduler, API server, DAG processor, all of these components are familiar to you now because you know all of these things. That's why I first build your concept and fundamentals. Then I take you to the code so that you can understand what are you doing. Instead of just downloading the Docker Compose file, running Docker Compose up D. Oh, Airflow is running. Okay, how it is running? We don't know. We just know how to write the code. Wow, 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 wow. Well done, well done, well done. Bro, just learn in the right way. Okay. It takes time, but it prepares you for the future. Let's wait. It will take some time because these images are very, very big. As you can see, 631 MB. Can you imagine? Can you imagine? It will take, I think, almost 2 to 3 minutes. Let me just fast forward this particular process. So as you can see that I have got this error and I know why this error is coming. In your case, it will not be coming because I already had one Docker container running for the Airflow. So that is why it created a conflict, but don't worry at all, bro. Don't worry at all. Now I have, let me just quickly turn off all of my containers from the Docker desktop. Let me do it. Okay, perfect. Now let me just run the command again. Docker compose upd. So now, as you can see, again, it has started. And this time it will not pull all the images because it already downloaded all the images. And now you need to wait for it to be healthy for all the services. Okay. Perfect, perfect, perfect. And meanwhile it is running, I can just also show you what is happening in the Docker. So this is my Docker desktop and just ignore this thing. This was for another video, LLM project. And this is the container. See, this is actually not a container. This is a stack of containers because in the Docker Compose, we write all of the containers that we need, right? So if I just click on this drop down, I will see all of these containers. So as you can see, one container is for Redis, one is for Postgres, one is for Airflow init, which is just for the initialization, one is for DAG processor, one is for triggerer, one is for API server, one is for scheduler, one is for worker. So we have all of these containers running independently in their isolated environment, but they can talk to each other because this is built using same Docker Compose file. That means they can just talk to each container using the same network. Some technical stuff about Docker, but that's what I like. So now as you can see, our Postgres is available at 5432 port. Why? Because I did the port mapping manually. Very good. This port mapping is already done by Airflow so that you can just use Apache Airflow UI using 8080 port. Makes sense? Other ports are not available for our machine and we do not need that. Makes sense. So now if you see the terminal, it should be like this. It should be free. If it is not free, you need to wait. Okay. Now as you can see, this is free. This terminal is free. I can literally write anything. So this should be free. One important thing which is interesting, if you see the Docker desktop, you will see that in our Airflow init, like all the services are green except Airflow init, because this is a kind of initializer. Once the Airflow services are initiated, it will be turned off. That is why it is in gray or exited. Other services are running because we do not need this thing. We need all the other components, and all these components are familiar to you now because we have seen what each component actually does. Simple. Good. Now, first thing first, I want to take you to the Airflow UI. Okay. How does it look like? Because you will be very, very excited. Like, how does it look like? And let me just show you that. So if I just go to, let's say, any browser, simply search local, or let's say HTTPS localhost and then 8080, hit enter. The connection for this site is not secure. Are you serious? Are you serious, bro? Yeah, just remove HTTP. Just remove S from HTTP because this is like local host. So here you need to put username and password. You will say, Ansh Lamba, I don't know my username and password. So it is actually defined in the Docker Compose file. So if you just see username and password, just search username. So this is the username and password for the Postgres database. And if I just search down, so this is the username for environment. By the way, it is Airflow, but I'm just still showing you. Postgres, blah, 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 blah. You can just search it. So the default username and password will be Airflow, and password will also be Airflow. Okay, and then click on sign in. And this is your Apache Airflow. Ta-da! It is cool, right? They have upgraded their UI as well, and it is amazing now. I think it is built in React, but we do not care. We just want nice UI. Build that UI in React, Next.js, whatever. So now this is the home page for the Airflow, and this is like very normal that you would see in any other technology. Home page where you see failed DAGs, running DAGs, active DAG 000 because we have 0 DAGs. The main component of this particular UI, let me just give you a quick 2 to 3 minutes overview. If you go to DAGs, this is your go-to panel where you will spend most of your time. Here you will see all of the DAGs. Currently you are seeing 0 DAGs, no DAG found because we removed the flag. We basically flag the example DAGs to false because we didn't want to see the DAGs. Otherwise you will see 81 or 82 whatever DAGs out of nowhere. Okay, these are just sample DAGs that you can just use. Perfect. Then you can just go to DAG runs, and here you will see all of the DAG runs, failed, succeeded, everything. Then task instances, that means whatever task you will create here in your DAG will appear here. This UI you will, I would say, eventually be familiar with when you will just writing code, but let me be honest, it's still like my duty to give you a quick overview. But take my guidance, you will learn UI automatically. There's nothing to learn specially. But let's go to assets. Assets is basically a new addition in the Airflow 3 that we'll just discuss later on. Then we have the browse feature. Here we can just browse all the audit logs, XCOMs, required actions. I do not like using this particular button because I can access XCOMs directly in the DAGs, and I will just talk about XCOM because XCOM is something that I personally love a lot because it helps to build stateful DAGs, and I love this feature, XCOM. Then go to admin. This is important because here you can just create variables, pools, providers, plugins, connections. Connection is very important because connection is, what is a connection? Let's say you want to connect your DAG to Postgres database, or let's say to Synapse Analytics, let's say to S3. So you will first create the connection with that particular services. There are some pre-built connections available. You can click on add connection, and here you will say connection ID, blah, blah, something. And you can just simply select what type of connection you want. I want, let's say, web services, Athena, Redshift, blob storage. There are so many connections available. You can pick any connection. Okay, Postgres, whatever. So this is that particular tab. Then if I just go to security where we have users, roles, actions, and obviously this is the kind of admin stuff where you will allow some developers to see some DAGs. You will allow some developers to run some DAGs, but currently we are the admin, so we are good. And if you just go to users, you will find all of the thing that you want. Dark mode, light mode. I want dark mode. So this is the dark mode, then language, then default to graph. You would need to just enable this thing because whatever DAG you will build, by default you will see the grid view, and then you can just enable the graph view. It is a good one. Then time zone, this is like my personal time zone. In your case, it will be like your time zone, and then logout, and then some documentations, which are very, very, very helpful. Okay, then home. This is your quick overview that you need, and I would say that's all you need for Airflow UI. You do not need to spend much time here because you will eventually learn everything. Simple. Okay, now we are all set to write our first DAG. And remember, I was just talking about the DAGs folder in the, you can say, example. This is the same folder that we will be just using to create and write DAGs. Now I know you have so many questions like you will write your DAGs here how will it just run in Docker, how it will be like synced to that Docker. I know because I also had those questions. Don't worry, I will just clear all of your questions because this is like complete guide for Apache Airflow. Make sense? So let's see step by step how we can just build our first DAG, and then how we can just make sure like how this DAG is visible in Docker, how we can just do all of those things. I will just tell you everything. So are you ready to write your very first DAG? And you know what? The first DAG is very, very special. Ooh, first DAG is always special. So now in order to just write your first DAG, you need to first of all close all the unnecessary windows. Perfect. Now what we will do, we will simply go to this DAGs folder. Okay. And here we will create our DAGs, all the DAGs. And obviously we are just learning step by step. So we'll be creating multiple DAGs, and just for the better order management, I will just put the numbers like 1, 2, 3, 4, 5, so that you can just get to know like which DAG you need to learn first, and then second, and then third. So just click on this folder and click on this new file, and you will be creating your very first DAG. So I will name it as one first dag.py. Perfect. And hit enter. So this is your Python file where you will write all of your code. Simple. So first thing first, you need to import the Airflow SDK, Airflow package, so that you can write your DAGs. Okay. So I will import from Airflow .sdk import, not capital D. You need to import small DAG, because this is the latest, you can say, API SDK that they have provided with Apache 3.1 plus, and they are also recommending to use this particular API because this is an amazing one, and we use Decorator with this particular API. And in this particular course, we will also learn the most recent API SDK so that you can become future proof, and obviously in the future they'll be just migrating all of their code to this new API, so you should be well versed with this one. Simple. Perfect. So we need to import one more thing, which is task. Perfect. Now I will write my first DAG. So how you can just create DAG? There are multiple ways to write DAG. Earlier we used to just write with like context manager. Okay, you can still write it like that. Let's say with, and that, let's say then DAG, and then you will just write all of your code. But the way that I prefer and I recommend is using a decorator, because this is the most recent code that they are recommending to every single person to use, and you should also use this particular one, and it is actually very good. If you will compare the code readability, in order to manage the code, maintain the code, it is very, very good, and I really appreciate this particular upgrade that they have made in Apache Airflow 3.0 plus onwards. So you simply use a decorator called @DAG. So if you do not know about decorator is just like kind of fundamental feature of Python. If you have your fundamentals clear in Python, you can simply understand what is a decorator. Decorator is nothing but just a kind of function within function. So it takes your function and it decorates it. Obviously we are not learning about decorators, but this is that particular thing, @DAG. And after that, I will simply say my first DAG. Right? Okay. So this is the name of my DAG, which is called first DAG. Now Ansh, Lamba, we didn't provide any name to this DAG. So how do you know like the name of this DAG is first DAG? So if you do not provide any kind of DAG name, then whatever the function name is, it will register that DAG with that particular name. And this is a very, you can say, very basic practice in the industry. But yes, you can specify the name as well with the parameter called DAG ID. So I can write it like this as well. DAG ID, which is first DAG. DAG ID, which is first DAG. Perfect. So this is the code for it. Simple. Good. But usually we do not define it like this because it is very obvious that whatever the function name is will be our DAG. But still, for the first DAG name, it's fine. Then within this DAG, obviously we will be having multiple tasks. Obviously, right? Remember our DAG here. If I just open that particular task, see, so let's say we have these many tasks. Obviously for the first DAG, we'll not be creating this complex DAG. Let's say we just want to create this simple DAG, like one task after other, like let's say this one, simple flow, because we need to grow step by step, right? So let's say this is our DAG. So now we need to define independent or basically individual tasks, not independent because obviously this is independent, but this is dependent. Individual tasks, right? Whatever task I need to pick in my DAG. Perfect. Now I will say first DAG, and within that I will create my first task, and I will say task, and let me just mute this agent mode for 5 minutes. Perfect. @task. So similar to @DAG decorator, we have a decorator called @task. Now you do not need to create any kind of specific variable, and then you need to create a Python function, and then you need to define a parameter called Python callable, nothing. Just write @task. So this decorator will automatically parse your function that you will define now. Let's say I want to create a simple Python function, which is def, let's say, first task. Simple. So this is my function. And now whatever code I will write within this particular function will be registered as my task automatically. Simple. Okay. Now there's a very cool thing about this task decorator. We have multiple options. If you remember our fundamentals, we have multiple categories of tasks. It can be a Python task, it can be a bash operator task, it can be so many things. So Ansh, Lamba, how Airflow will know that this is a Python task or a bash task or whatever? Very good question. So how it will identify it? You can say @task dot, then you will see all of the option: bash, branch, external Python, branch, virtual environment, and all of these things. Okay, what is branch? We'll just talk about it. Branch is nothing but just, you can say, a kind of decider, like where you want to go. Simple. So here I can write Python. So if I do not define anything here, I can literally write like this @task. So by default, it will automatically convert this particular task and it will treat that task as a Python task. Okay, but just for the simplicity, I can provide this thing like Python, because it will make your code more readable, and whoever person is reading, the person would know, okay, this is a Python task. Simple. Okay, so within that particular function, we are not going to do anything fancy. I will simply say print, this is the first task. Simple. Now similarly, I will create second task. And this is the second task. And now let me just turn on the agent mode because I just need to perform repetitive tasks. Okay. Okay, perfect. @task, Python, third task, and this is a third task. Perfect. So I have created all of my 3 tasks, right? Now I will define the dependencies. So now if I just go back to that particular documentation, or basically our personal nodes, we know that task 1 should run first task, and then task 2 should run only if task 1 is succeeded, and task 3 should run only if task 2 is succeeded. Simple. Good. Now if I want to define that dependencies, I have to use, like, there are so many options to define the dependencies, but I personally like the arrow method. There's a technical name for that. I don't know what the technical name is, and it's called, I think, big shift, whatever. So what I can do, I can simply say first, or I can just add a comment first of all, defining the task dependencies. First equals to first, second equals to second, third equals to third. So this is just a kind of variables that I have created for my functions, or basically my tasks. But now I will define the dependencies, as you can see the suggestion as well. So first of all, I want to run first task, then second task, and then third task. That's how you define the dependencies: first, second, and third. Simple. Very good. So now we have also defined the dependencies. Just make sure that whatever dependencies you are defining at the DAG level, not inside the task, because these are the dependencies for the DAG, right? Good. So now what you can do, you are done with the DAG creation. Very good. Now come out of this DAG. Perfect. Now you need to register this DAG. So how you can just register this DAG? Simply you need to write the function name. Let's say first DAG and that's it. Okay. Or basically instantiating the DAG. Basically you are registering the DAG. Okay, so this is done. Now do you know what will happen? Let me just show you what will happen. If you just check the logs, okay, just click on this drop down. Currently it doesn't have anything because logs are currently empty, right? Makes sense. But do you know what? You have written the DAGs in your folder. Yes. Whatever DAGs you are writing in your folder will automatically be synced. Will automatically be synced inside the Docker container. Okay. Because in the Docker, they also have a special folder called DAGs. Oh, so whatever DAGs you are writing here in this particular folder, that's why I told you that just keep the, just make sure like spelling is correct, will automatically fetch your DAGs and it will just sync that folder with the folder which is in the container. Make sense? Now, if you see what happened, it happened automatically. Let me explain what actually happened. So if you see the DAGs, if I just check the logs folder, I have a special folder called DAG processor. Remember the DAG processor? What it does, it simply parses the DAG, right? So usually it parses the DAG, I think in every 5 seconds and in every, I think 10 seconds, 15 seconds, you can just change this time in the config file. It's not a big deal. So what will happen, whatever DAG you will write here, okay, whatever DAG you will write here, first of all, it is automatically synced with the DAGs folder inside the Docker container. Simple. Okay. And let me just draw it for you so that it will be like simpler for you, because it is a little bit complex, but once you know this thing, things will be much easier with you for you. So now let's say how DAGs are synced, right? This is our question. And like you would have question like, I am writing my DAG here and what's actually happening behind the scenes. So let's say you are writing your DAG here in your local machine, in your VS Code. Okay, this is your VS Code. Simple, perfect. So you have created this DAG folder, which looks amazing. Okay, you created this. Simple. Now what will happen? This DAGs folder will be synced with another folder inside the Docker. Don't I have Docker image? Are you serious? Docker is here finally. I love Docker. So let's say this is inside Docker, right? So within that Docker, we have this folder as well. And but the location for this Docker is this one, OPT, Airflow, and then DAGs. Okay. So whatever you write here is automatically synced using bind mounts, not volume, bind mounts. Both are different. Like both are types of storage layers, but both are different. It's called bind mounts. In bind mounts, you actually do not persist the data. You simply bind mount it at the time of running the container. So this is bind mounts. So this is exactly your DAGs are synced. So that means whatever I am writing here locally here, let's say in this folder, are automatically synced in the container. And let me just show you that as well, because we need to just see everything. So this is my Docker, right? Now these are all the containers. As you can see, there are so many containers. You can just open any container. Let's say I want to open this container. You can literally open any container. It's not restricted to any specific container. Just click on this container and that's it. Now you simply need to go to this section called bind mounts. You will see all of these locations which are my local, you can say path or file system is actually synced to this particular location. OPT Airflow DAGs, OPT Airflow config, and blah blah blah. Right? Make sense? Let me just put it here as well so that you will just use it in your notes. So as you can see here, perfect. So see, that's how you access the DAGs in the Docker. Because see, what everything is running in Docker. Nothing is running on your machine. Nothing. Everything is running in Docker. So that's how you sync all of the DAGs in the Docker container. Simple, very good. Now what will happen once your DAG is synced to this particular folder, right? In the DAGs folder, then what you can do, you can literally, not you basically, then you can say DAG processor. DAG processor will simply parse the DAG, okay, into the database, right? Very good. Once database knows that we have a DAG, then it will simply portray or basically display that particular thing in the Airflow UI. Where is the Airflow UI? 8080. I will just show you, don't worry. But this step is very important. This is like high level thing, or you can say senior level thing, but in AI era, no one is junior or senior. You just need to have skills and that's it. And that's what I love about AI era. Forget about 10 years of experience, 15 years of experience, 20 years of experience. It's all about skills now. Perfect. So now this is the log. Do you know what is this? This is the log. That means this DAG is now parsed. This DAG is now available in the UI, Airflow UI. You can even change this particular duration, like how long it takes, but usually it is like 5 seconds or I don't know, maybe 10 seconds, 15 seconds. Sometimes I just increase the time size. Why? Because let's say your DAG are some complex things and you are just reading so many libraries. In that particular scenario, it can take longer than that. So in that scenario, you can customize it as well. It's not a big deal at all. But yes, you can just do it within your, you can say, file. I can just show you that particular information as well. If you just go to config here in the airflow.config, so this file is automatically created when you created your first DAG. Okay, if you just open this and if you just scroll at the top, because it is in the beginning, I would say. Okay, so this is the DAGs folder, and just scroll down a little bit and you should see that particular, I saw it, I think. You can also search. Oh yeah, here it is. DAG bag import time. So currently it is set as 30 seconds. You can just change it. You can just call it as 5 seconds, 10 seconds, 30 seconds. 30 seconds is like the default one that we have got. Earlier it was just 5 seconds. Maybe now they have increased the time, but I think 30 seconds is nice. Or let's make it as 10 seconds because it's fine. Okay. So now whatever DAG you are just writing here, it will just check for these DAGs in every 10 seconds, and in every 10 seconds, it will try to parse it. And once it has parsed it, it will be available at the localhost 8080. Okay, let's check then. If we just go to our Airflow UI, now if I just click on DAGs, I can see one DAG. Wow. Now, just a quick information. You will not see your DAG here if you have any kind of syntax error in your DAG. But sometimes you will not see your DAG here if it is not parsed. So how can you just confirm it? Whenever you want to just check your DAG here, if it is not here, there are two steps. Step number one, you should always, first of all, check your code. If it is parsed or not, it will be come here, and you can also see the date. You can see logs, DAG processor, and then this date, and then this folder. And then within that, you should see your DAG. It should be in the logs. Because if it is not in the log, you need to wait for 30 seconds. Sometimes it can be longer than that. So you can be patient in that sense. Do not be like, hey, where's my DAG? Where's my DAG? Where's my DAG? It is there. Okay. Once it is there, and even if it is not showing here in the UI, that means something is wrong in your syntax. You can just check your syntax. Okay. Do not worry at all. Okay. Perfect. So let's try to click on this particular DAG and let's see how our DAG will look like. Let me just click here. And perfect. This is my DAG. See, this is the first task, this is the second task, this is the third task. If you do not see the graph view, you can just switch it from here. This is the grid view and this is the graph view. Simple. Okay. Now you will see a lot of things here on the right hand side because now we have the DAG ready. Now let's try to run this DAG because let's see what will happen, right? So in order to run this DAG, by default, your DAG will be paused because that is for security reasons. You should never run your DAG right after your DAG is deployed. You can change this feature in one of the parameters I will just show you in the DAG, but it is always a good practice to keep it in the pause state. Okay, once you have like enabled it, then it will be like continuously running if you want to schedule it. obviously, right? So not worry, once we have enabled it, and if we have any kind of, you can say, schedule, it will be like automatically running. You do not need to enable it again and again. No. So this is enabled, and let me just click on this trigger button. And what will happen? It will simply say single run a backfill. No, we do not need to do a backfill. And by the way, we do not have any kind of date range, so it's fine. Click on trigger, and then it will try to trigger the tasks. And now let's see if it is triggering the task or not. Okay, queued. Okay, and then success, success, success. Perfect. Sometimes you can face error. Okay, it can say like it is failed, and if you will just check the code, it will say something like related to celery executor is not working, or the state was in the different state and now it is queued, something like that. In that particular scenario, just restart your container, okay, and just make sure like you have nothing conflicting. First thing. Second thing is you need to make sure that you have put that environment file, because sometimes if you do not have that particular environment file, there can be some issues related to permissions. I have seen those errors. That's why I'm just sharing it with you. I'm not saying like you will have to see those errors. No, I'm just giving you some tips and that's it, because I do not want you to see some errors which are like totally out of the box, which have nothing to do with your skills. So I'm just telling you that thing. Okay. So this is the first task, this is the second task, and this is the third task. Good. Now let's try to see the output of each task, okay? Because you remember we just put some print statements here. So if I just click on the first task, I will see the logs, right? And as you can see, my output, this is the first task. Simple. And you can see done, returned value was none. Perfect. Now what is a rendered template? Rendered template is very important when we are passing the OP arguments and OP Kwargs. What are these things? We will just talk about this when we'll be just talking about the context. We cannot directly talk about context. You will be totally confused. Okay. We can simply ignore it for now. XCOM is totally something which is not for you for now. We will just talk about this XCOM very, very soon. But currently we are simply focusing on the simple DAG example. Then we have asset events. We have not created any asset, so it is empty. Audit log, that means if you want to see any kind of errors in detail, you will see it here. This is an amazing section, code, where you see the code as well. Why it is important? You will say, Ansh, Lamba, we can just see the code here in our VS as well. So why it is a big deal? Let's say this. Do you know why it is important? Sometimes you make some changes in the code. Let's say I want to say this is the third task. And let's say this. Okay. What is this? Just write something meaningful. Let's say DAG complete. Okay, so let's say I have made this change here. So now if I just refresh it, so I need to make sure that this change has happened and it is changed here as well. Sometime it takes time, so you need to make sure like whatever change you are just looking for, it should be reflected here before expecting something else. Simple, good. Now if we just go to details, there are some details that you can see: start date, end date, duration. It took like 0.04 seconds. Map index, first task manually, because it was like manually triggered. All of the metadata that you would have for this particular task. Simple. Okay, very good. There is one more option that I want to show you. If you just go to your DAG here, not in your task, you will also see some things like audit log and code for DAG. So you can just check the things from here as well. And if you just go to, let's say, first DAG, okay, this is your first DAG. And if you just click on these 3 lines, sometimes it takes time to parse your DAG if you have made some changes. So you can simply click on reparse DAG and it will simply reparse it from your DAGs folder. You can do it manually as well. Sometimes it takes time, so you can do it manually. It will just speed up the process. Simple. This is the basic understanding that you should have about DAGs, and that's it. Okay, simple. Now let's talk about some other stuff. So this is all about DAG, right? And you have understood like how you can just do the things. You also understood like how to change the timeout period and all the logs. And here you will also see now different folders, because earlier we didn't have any kind of runs, but now we have runs because we ran our DAG. That is why we have DAG ID equals to this and all of the task IDs, because this task was executed, this task was executed, and this task was executed. And this is the run ID that it has created for us. Simple. So this is a log for the DAG runs, and this is the log for the parsing. Remember this thing. Simple, good. Now let's talk about the database. So I told you that all of this DAG is written in our database. Okay, let me just pull up my Docker. So as you know, like this is my Docker, Docker container for Postgres, right? Simple. Now I know that my DAG information is written here. I know this. Yes. But let's say I want to just check like where my DAG is. Let's say I'm curious to know like in which table it is stored, where it is stored. I want to see that. Option number one is you can directly open PG admin if you have available in your system, and you can connect to this particular database directly. Okay, if you have that. If you do not have that, we also have some commands that we can just run in this particular Docker, and it will help us to run an interactive shell, and we can then interact with that particular database. Okay, makes sense. So let me just show you how you can just do that. So if I go to this container, like you can just do it from your terminal as well. So let's go to this one, and we can just, yeah, let's do it in VS Code. It will be better. So this is our VS Code. Let me just open any terminal. Perfect. So this is our terminal, and this is our virtual environment. So you can simply say Docker and execute IT means interactive shell, and then we just simply need to provide the container name. I need to check container name because it is called Airflow Postgres 1. Okay, so this is my container name. In your case it will be like similar, but you can just confirm, and then you can say p SQL and then -u, which is username, which is Airflow, and then simply provide the password Airflow. Simple. Hit enter, and now you are inside the PostgreSQL. Yes, you are inside now PostgreSQL database. Like not inside, now you can interact with the PostgreSQL. Okay, now you can simply run the commands like \dt if you just want to get the information about all of the schemas and tables. So as you can see, I just wrote \dt, and I can see schema public, AB group, AB role, AB user, and all of the things. And as you can see, it has everything DAG. So this is the table where it stores all of the DAGs. Yes, in the DAG table. In the DAG, simple. Okay, and then you can just scroll down. So it will like keep on going because there are like so many tables. I think it is not DAG, it is serialized DAG. Yeah, it is serialized DAG. Just correct that. It is serialized DAG where it stores all of the DAG. But yeah, it stores some metadata in DAG table as well. So it is interrelated bus, but serialized DAG is the table where it stores all of the serialized DAG. But yes, some information, some metadata will also be available in the DAG table. Just make sure this thing. Okay, so you can just keep going, and this is the end. So there are total 65 rows. That means 65 tables are created in the public schema. Make sense? Make sense? Make sense? So that's how you can just do this thing. Okay. You can just see these tables, but obviously if you just open PG admin, you will get much more interactive shell where you can just write SQL commands, select asterisks, from, where, whatever. But I just wanted to show you like how you can just see everything within this table. Make sense? And let me just close this terminal because this is stuck, and this happens when you have like a lot of data. So perfect. So this is all about your behind the scenes, because now you know behind the scenes. Now you can just develop the things in a much more better way. Because if you do not know about like what's happening in the backend, you'll be like, okay, I'm just writing the code and I do not know how it is executed, how it is rendered, how it is serialized, where it is stored. I just know how to write DAGs and that's it. Bro, let me show you. If you just want to do that, let me just create a new file just to show you something. Let's say test.py. I can literally ask this agent to write that thing in just few seconds, right? So just make sure that you know the things which are required in this AI era. Okay, perfect. So this was our first DAG, and we have learned so many things within this first DAG. Now, let's talk about the DAG versioning. Okay, let me just create a new file. DAG versioning. This is a very small topic, but it is very important. DAG versioning. So let's say now we want to create this particular DAG. Let me just copy and paste. And let me just change the name. I will simply say versioned DAG. Okay. And DAG ID equals to very good recommendation, and good recommendation. Very good. So this is my DAG, right? This is my DAG. And let's wait for it to parse it. So currently, as you can see, it is not parsed. It will take 10 seconds to parse it, right? And the sync is real time. The sync with my Docker container is real time. Do not worry about that. But the parsing will take at least 10 seconds. So it scans the folder in every 10 seconds, and if it finds anything, it simply puts that in my DAG. Simple. Okay. As you can see, till now it is not parsed. So if I just go to the UI, I will not see anything. See, because it is not parsed. I will only see the DAG if it is parsed. Okay. So just make sure. It's like good practice. You should always wait for the DAG to come here first of all, and then you should look for the DAG in the UI. Otherwise you'll be like, why I'm not seeing the DAG? Maybe something is wrong in the syntax. No, nothing is wrong in the syntax. It's just about the time. It is not parsed. Simple. So as you can see now that this DAG is now parsed. Now if I just go to the UI, if I refresh, perfect. Now I will see this DAG. Now as you can see that this is the same DAG, right? And you can also trigger it if you want to. So this is succeeded. Can you see this DAG version v1? So we are only seeing the v1 because we just have one version, right? So now what will happen? Let's say if I make any changes to my code. So let's say I want to add another task. @task.python, and this is the version task DAG version 2.0. Perfect. And if I say fourth task version, makes sense. Now what will happen? Now when this DAG will be parsed again, obviously it will take 10 to 15 seconds, whatever. Then you should see version 2. In most of the cases, if you are making some minor changes, you could not see those changes and it will not tag it as version 2. Sometimes it skips those simple changes, but if you're making, you can say, significant changes, you are just modifying the entire DAG, then obviously it will just create a v2. But for smaller changes, it will not show you. So let's see if it will just create a v2 for this task. Otherwise, we can just make some significant changes. And let's see if it has successfully parsed our DAG or not. So how I can just confirm if that tag is parsed or not? I can just check the code for it and I can see if it is. Okay. Now, so this is changed, right? Can you see the v2? That means this is a new version for DAG. See, this is called DAG versioning. If I just click here, this is my v2, right? Now, that means every time I make any change to my code, it will create a new version. It will create what? New version. That means by default, it will only take the latest parsed version of your code. That means it will also tell you that, hey, I ran this DAG with the v2, with the latest version, v2. Makes sense? I can also make it as favorite, but you don't need to do that. And you can literally reparse the DAG if you do not see the updated code, and then you should see v2 here because we have literally changed the version. If I go to details, it should be here as well. if it has like some kind of metadata or in the overview, like it will just save that particular information. Makes sense? So that's how you can just take care of all the things. Makes sense? Now if I just trigger this, you will see all of the things here. Okay, this is queued. Okay, this is also success. So we have successfully run our DAG. Makes sense? And this was also like manual thing, and this was like v2. Okay, so just make sure that's how you can just take care of all the things. Now you can see runs and you will see all of the kinds of runs. Simple. Okay, all run times. Okay, all states. Okay, this is this. So there's nothing to show here for now. Okay, perfect. So this is all about like DAG versioning, how you can just take care of that DAG or versioning. It is not a very, you can say, critical thing or very important or very complex thing. It is a very simple thing. Whenever you just make a change, it will create a new version for it. Simple. If you now make another change, it will just create, let's say, v3 or v4 and so on. Now let's say if I want to check v2 or v1, like what is the difference between it, right? So you can literally go to, let's say, options here, and here you will see like v2 was created at this time. You can pick v1 and you will see the v1 state as well, and then you can just trigger it. So now if you just click on trigger, it will create the DAG according to it, because this is all about v1 now. So that's how you can just make changes. Okay. And by the way, we do not like do these kind of stuff in the real world. Like we are just running v1 and we created v2. It can just mess up the entire thing if it is like already scheduled. We do these things when we are just actually developing something, and if you just want to say, hey, the previous version was right, let's switch back to it, and like that. Simple. Okay, perfect. So now let's talk about the other topic that we have here, which is called operators. Now, as you know that we have so many operators. We have Python operator, we have bash operator, we have email operator, we have dummy operator as well, and so many more, right? So now let's say I want to talk about operators. So what I will do, I will now create a simple task with another operator. Let's say I want to create a task with bash, right? So now in order to create a bash operator, so what I will do, I will create a new file, operators, and I can copy the code from here. Perfect. So now in the third task, I want to use a bash operator. So there are basically two things. First of all, you can use a @task decorator because it is available for bash as well, or you can literally create a bash operator, and for that you would need to import that bash operator, and I can just show you if it shows us here. Create bash operator in Airflow, because I like writing with that particular decorator, but I can just show you. You just need to import that specific function, and then that's it. Let's see here the official documentation. See, they are also just asking you to use @task.bash, but we still have bash operator as well. So this is another way to define the task. Let's say run this equals to bash operator and task ID, that means the task name, and bash command, the command that we want to run. That's how you can just create a bash, you can say, task. Let me do one thing. Let me just define both the ways. Okay, so we can do one thing, @task, and I can copy this. Okay, or we do not need to copy, but yeah, simply. So I will just paste it here. Perfect. So now what it will do, it will create another task, and do you know what this time what it will do? So this is a kind of function that we create, and whatever we put in the return statement, that means we want to run this command as my bash command, because obviously bash is not a Python thing, right? It is just a bash command, but we still can integrate this thing, because whatever we return in the function, that string will directly go to that particular bash command. So you need to be very careful while returning something, right? This is one way of doing it. Let me just create another task, but this time I will not use the @task method. I will use the bash operator. Okay. Do we need to import it? Because I'm confused if we need to import it. Let's try to use it. If it will just show the warning, that means we need to import it. Yes. I'm so sure, like, we need to import it. So how to import it? What is the library? Let me just check. Import. If you are just creating a good documentation, you should just put imports at every page. Let me just ask this from. Perfect. So here it is asking airflow.operators.bash. That means we do not have airflow.operators. So import airflow.operators. Okay, by the way, it is not a big deal because it is just a warning, because we are not running anything locally. But if you want to get rid of it, you can install airflow.operators. Let me just try to do that. Airflow.operators. So So it is now adding it. And it is, I think, downloading all the operators. Perfect. Bro, just remove this now because now we have this thing. Okay, maybe it will just refresh it after some time. Yeah, perfect. Let's ignore that. So now we have this bash operator like this, and I will rename it as bash task, and I will say modern, and this will be my bash task. Oops, bash task old school. Make sense? Okay. And task ID will be bash task old school and echo. So what it will do, it will simply echo that particular thing. Bash task, okay. And then just remove third. Perfect. So now we have redefined our all the tasks, and we have redefined our dependencies as well. As you can see, this is our dependency now. Bash, bash, bash. Simple. Very good. And this is not a function. That is why we are not using any braces. This is just an operator. Simple. Okay, good. Now, let me just rename this DAG name as well. I will simply say bash DAG and bash DAG and bash DAG. Perfect. Now let's wait if that particular operators is parsed. Okay, this is already parsed. Let me see if the code is updated or not, right? Or I can also say operators. Why just bash? Operator is a good name. Perfect. So now let's try to check our Airflow. Let's go to DAGs, and here we have operators DAG. Very good. Okay, this is parsed. Let me just go to code just to confirm the code. Okay, this is good. Okay, it was quick. Okay, makes sense. So that's it. That is our code. Let me just trigger it. Let's see like if everything is fine. Okay, success. Bash task modern running, success. Perfect. So if I just click on this bash task, because we are already familiar with the Python task, here you will see airflow.operators.bash.operator attribute is deprecated. Please use airflow.providers.this. Okay, this is the modern way of it. See, I told you it will just give us a warning, and I would expect Airflow to just write this thing in the documentation. Yeah, perfect. So I can say from airflow.providers. Let me just install airflow.providers as well. uv add airflow.providers. Okay. And your project depends on Airflow providers. We can conclude that project depends on Airflow provider, Apache Airflow 2.0, less than 3.0, because your project depends on Apache Airflow. We can, oh, I see why it happened. So let me just say uv remove, maybe remove or uninstall Apache or Airflow dot operators, because we installed the deprecated one. Now if I just try to do that, maybe it will install it. No, because all version of Apache Airflow providers depend on Apache Airflow 2.0 less than. Oh, really? So it is saying all of the Apache Airflow depends upon less than 3.0. Okay, whatever, because this is like local environment, so it is not a big deal. Let me just use the earlier one, because everything will be running in the container, so it has all the dependencies, all the libraries, so it is fine. So now if you see that we have our running command here, that it is running this command, which is this one, echo https and this thing. So this will run this command as it is in the bash. What is bash? Bash is basically an interpreter to run all the GNU utilities that we use to talk to Linux kernel, right? So it will simply run this command in my bash, you can say shell, right? And I can also see bash task old school, same thing, right? And we are getting the same error here. Not error, it's just a warning that you can just use this particular operator from now onwards. Simple, but it is fine. Okay, makes sense. So that's how you can just use different operators within your simple DAG task. If you have Python task, if you have Bash task, you can just do it like this. And for Bash, you have both the ways, but I personally like the @task method because it is much more readable, but you can just do it whatever you want. Okay, perfect. Now it's time to learn more about the context or basically stateful DAGs. Now, in the real world, you need to build some DAGs which will just take care of the context as well. What type of context? For example, let's say you want to build a DAG which will, let me just go to my whiteboard. Okay, and oh yeah, let me just show you one more thing here because it will be very helpful. So as you can see that this is our source mounted to this particular destination, and I know like this can be a question in so many cases. So let me just show you where it is actually residing. So you can see that this folder is there, right? Let me now just take you to this folder as well so that this information is now completely done. So if I just go to Docker, let's say I just open any kind of container. Let's say I want to open, let's say this time scheduler. Okay. So now what can I do? I can simply go to exec command. Exec command will just take you to the terminal running inside the container. Right. So this is my container. I can literally write pwd, that means present working directory, and hit enter. So currently I am in opt/airflow, and I told you what is the location name, opt airflow and logs configs plugins DAGs, right? So if I'm currently at this location airflow, I should see all of these folders. Okay, let me just show you. So if I just say ls, you will see all of these folders. See, wow. And if I see cd and dot dot, and then if I say ls, you will see two folders, airflow and Microsoft. Very good. Now if I say cd and dot dot, and if I say ls, you will see all of these folders. See, Dockerfile, bin, clean, home, empty, proc, whatever. So these are the folders which are created automatically when you just use the airflow image, right? And this is our folder, and within that folder we have one more folder called airflow where we mount our all the folders. Make sense? So now you can simply say cd opt within airflow and then within DAGs. Okay, then say ls. You will see all of the DAGs listed here. See, first DAG, second DAG, third DAG, everything. So everything is in front of your eyes. Everything is in front of your eyes. Okay, now let me just paste this information here. Perfect, so that you can remember this. Okay, and you will know like how to just access this information, because this is important, bro. This is very, very important. Simple. Okay, good. Now let's talk about the XCOMs. XCOMs are very, very important. XCOMs in Airflow. When I'm going to just talk about XCOMs in Airflow, let's say we have a task, and this task look like this. Let's say this one. Okay. Now this task is doing something. Let's say this task is fetching some data or making some API call. Okay, let's imagine like this is just making an API call. I can write make an API call. So now let's say after making this API call, I want to run another task. Okay, not a big deal. Yeah, I know, not a big deal. But this time, do you know what? This time I want to use the output of this. Let's say the output of this particular API call, I want to use it here. Oh, this output. So this time obviously I want to run this particular task, but I also want to use the value which is residing in this task. Oh, so I want this output as well to travel along with the dependency. Oh, because my this task, which is to process this data, or let's say I want to clean this data, or let's say I want to use any kind of list comprehension, any kind of comprehension, right? So what I will do, I want to use this thing. Okay, I can say make an API call, or maybe render the text. Okay, and I want to use this as an input. Simple. Here this output will become my input. So let me just say input. Okay, this is the input. Let me just write it here, input, and like this. Simple. I hope it is simple. I hope you have understood it. So we have this output, okay, and we want to pass it as the input, and obviously this task will also have its own output, right? That the further task can use it, the, you can say, downstream task. Make sense this way? So if we want to travel our information between the tasks, we use XCOMs. Okay, we use XCOMs. Simple. Okay, now let's see how we can just do that, because obviously if you're just running DAG, we want to just make sure that our information is traveling between the tasks so that we can use it, right? So let me show you how you can just do that. It is a little bit complex one, but don't worry. So let me just create a new file. This will be called XCOMs. XCOMs.py. Okay, perfect. So first of all, let me just write some basic code. I can just copy and paste this one. Okay, so what do we have here? Let's say first DAG. Okay, so let's say this time I want to use something, or I want to pass some data, right? And I will just show you both the ways. Like there are total two ways how to access that. First of all, the default one, and then manual one, because manual one is actually a good one. Default one is also good, but it becomes messy when you have a complex graph. So I will actually say XCOMs auto and then XCOMs manual. Okay, let's see the auto one first of all. So what I will do now, I have the first task. Let's say I am processing, or basically fetching the data, extracting data. This is first task. Simple. Okay, so whatever data I have extracted, I will simply return it. Okay. Oh man, this auto suggestion sometimes actually irritates you. So I will simply say fetched data equals to, let's say, data and 1 2 3, or let's say 1 2 3 4 5. Perfect. Let's say this is my data and that I have fetched. Simple, just a hypothetical situation. Okay, makes sense. Then once I have fetched the data, then I want to use this data in the downstream, right? So now what I will do, I just need to use the traditional Python arguments. I will simply say, let's say fetched data. Simple. It can be a different name as well, don't worry. This is just, you can say, example. So let's say data. Simple. And let me just snooze it again because it is irritating, so that's why. So now we have second task, and I have this parameter called data. Make sense? I can also give the type hinting. I can simply say it is a kind of dictionary. Perfect. Now I will say transforming the data. This is my second task. Simple. Now let's actually transform some data, because when we have some data, so let's actually transform it. I will simply say data, or let's say fetched data equals to what? Data of data. Simple. Why? Because see, this is the dictionary, which is this information, and we have this key inside, which is called data. So that is why I'm saying data of key data. Simple. That's how you just access the dictionaries, right? Simple. So I have this fetch data. That means I have this list. Now let's say I want to multiply this list by 2. just for an example. Okay, so I'll simply say transform data equals fetch data into 2. Okay, I just want to multiply this list by 2. Simple. Okay, now I want to return it. Return transform data. Simple. Now let's say my third task is let's say again data first of all, and then I can say I want to load this data. Okay, I will simply first of all fetch the data. So I will simply say transformed data equals data dictionary, because I want to fetch the entire dictionary, this entire dictionary. Transform data, by the way, this will just return me a list. Okay, I can just create a better version of it. I can simply say transformed data dictionary equals, let's say this, because this is a better way to do it. Transform data and then transform data actual one, and I can simply return the dictionary, because we should always return the dictionary. It is better to work with. Okay, so now I have this dictionary which is called transformed data. Okay, transform data, and then this is the actual data. Perfect. Now I will simply load the entire dictionary. Okay, and I want to load the entire dictionary into my location, into my destination. Simple. So I'll simply say return transform data, or let's say loaded data. Okay, let's say load data and return load data. Simple. This is very simple, but do you know what? Now if you will use your common sense, we have this task, this will run without any kind of error. Perfect. Now when we need to run this particular task, we need to provide the argument, right? Data. Obviously, how we will just provide this particular argument? Let me just show you. So remember, we have all of these 3 variables written here. Now what I will do, I will simply say first equals to first task. Okay, and second equals to first task, and then I will write first here as an argument. So what will happen, whatever the returning value of this function will be saved in this particular variable. Let me repeat, whatever value this function will return will automatically be saved inside this variable, right? That's how we work with Python. Simple, nothing special, nothing out of the box. And I am simply passing the output of that function into the argument. Simple. That's what we do with Python all the time. And then second will go here. Perfect. Simple. That's how we define our tag. And do you know what? I do not need to write this. Why? Because Airflow is smart enough, at least in Airflow 3.0 plus, it will automatically create the DAG and dependencies, because this first variable is passing as an argument, is going as an argument here. So it knows that it needs to run this particular function before this function, and same with third as well. It needs to run the second function before third function. So it is smart enough. Okay, and let me just call it as XCOMs DAG auto. XCOMs DAG auto. XCOMs DAG and then auto. Simple. Now let's just wait for it to pass it, and then I will just show you all of the values. This is, you can say, a good method in most of the scenarios when you do not have a very complex task, very complex DAG. And it is an amazing way, because what will happen, you will understand in the manual notebook. So just wait for that one, because you do not know how it is just doing the things. Okay, so I will just show you how and what it is actually doing behind the scenes, because everything is now being done behind the scenes. You literally have no idea what is happening here, how it is just making the variables available in the following task. But I will just show you, don't worry. Let me just check the logs, and okay, perfect, we have this thing. If I go to DAGs now, I will go to XCOMs DAG auto. As you can see, it has automatically created my dependencies. I told you. See, now what I will do, I will simply trigger this thing and I want to see what will happen. Perfect. All the tasks are successful. Let me just go to only one task and let me just show you something. What actually I printed in this tag? This thing, extracting data. This is first task. Perfect. What value I returned in this function? This one. Perfect. Obviously, right? Now, do you know what? If I open XCOM, you will see something. Wow. What is this? Let me just show you. So if I just see the XCOM, I have a key. It is called return value, which is automatically created by Airflow, right? And I have this dictionary here, whatever I have returned. See, if I expand it, this is my value. That's exactly what I returned. If you remember, I returned one dictionary with data, key, and a list. Same thing I have it here. Wow. Yes. Now I will just go to the second task. So second task has printed filling up, not this one, has, because we didn't print anything in the second task, we simply returned it. So this is the returned value, list into 2. That means it will simply duplicate my list. Simple. Okay. Now, if I go to render template or basically XCOM, I will see the same thing, same key, but this time the value is different. See, transform data and that list. Wow. Yes. Makes sense? Now, if I go to the third task, I can literally see again returned value, this, and I can go to XCOM and I will see that dictionary. Simple. Transform data and that list and return value. That means whatever value you return in the function will automatically be available for the second task in the key called return value. And this task is automatically being done by the Airflow. Simple. Okay. So you just need to remember that there's only one key called return value. Okay. Makes sense? Only the return value that is being injected in each task. Simple. Good. Now let's just level up our understanding. Are you ready? Okay. Let me just duplicate this notebook and don't worry, it will be very easy. Don't worry. See, when I'm sitting here, just relax. Just relax. Relax. So if I just rename it 5 XCOMs and if I just rename, let's say manual, or I will say context or Kwargs. Kwargs is a very technical word for it and it is a very good way to understand it. Kwargs. Now what will happen? I know that Airflow is doing the work for me, but I want to take charge. I want more control. I want to know what is happening under the scenes because I want to make some customization. In that scenario, I have to use something called as Kwargs. Kwargs. So Kwargs, what is Kwargs first of all? Kwargs is basically the context variable, which is a dictionary that provides you all of the context variables in the form of dictionary. Okay, let me explain. For example, let's say you are running this tag, right? This complete tag. Now in this tag, there are some context variables. For example, the return value. For example, the logical date. For example, execution date. For example, some metadata, right? All of that information. So that information will only be available, or I can say will always be available for each task, but can only be accessed using a special argument that we can pass to each task. It's called Kwargs with double asterisks, right? Let me just show you what do I mean. So I will simply say, this is my DAG. Let's say first task is this one. And obviously in this particular task, I do not need to do anything, but still I will simply say Kwargs. Now you can use any keyword. To be honest, you just need to use double asterisks. You can also say context. You can also say state. If you are coming, if you're coming from AI engineering, if you're coming from LangGraph background, we just use state. And to all the LangGraph lovers, this is exactly the same thing. There as well, we have to use a special function, special variable called state. Why? Because it is already fixed in the backend. So in LangGraph, it is fixed. We cannot change the variable name, but in Airflow, we can just change the variable name. Simple. I think in LangGraph, we cannot change the variable name. Yeah, I think so. Yeah. I don't know. I didn't try, but I think so. It is not possible. So let me just keep Kwargs for now, just for your simplicity, just for your understanding. So what I will do, print extracting data. This is the first data, fetch data. Now, do you know what? Like I can return this data as well, but now I want to take charge and I want to manually push this data to the XCOM. Earlier, Airflow was doing it for me. Now I want to do it for myself, right? How I can just do that? I can use a special variable called TI. TI means task instance. I can just first of all fetch it, because in the Kwargs dictionary we have that variable. There are so many variables, and one of the most important variables is TI. You can access it right like this. Let's say extracting TI from Kwargs to push XCOMs manually. Perfect. Okay, so I will extract TI. TI basically is task instance variable. Okay, very good. Now I will simply say TI equals, and as I just said, Kwargs is a dictionary. So I will simply fetch that TI variable using a dictionary notation. Simple, like this. Once I have fetched this data, I know like I can just return this information. It will automatically push that data. I know that, but let's see. Let's say I want to manually do it. So I will simply say TI dot XCOM push. So there are two functions, XCOM push and XCOM pull. I will simply say XCOM push, and then remember we use I just showed you special key. Let me show you again. The key is called, if I go to first task, the key is called return value. That means whenever Airflow is pushing my context, it is using this key, return value. But let's say I want to use a different name. Let's say I want to use this time, let's say result. Just for fun, I want to just use a different name. So I will simply say key equals return result. Okay, instead of return value, I will simply say return result. Simple. And what I want to return, I want to return the fetch data. So I will simply say value equals fetch data. Simple. That's how you can just push this information to the XCOM manually. And I can just remove this because I don't want to return this information. Perfect. That's how I can just do it. Now, I want to access this information in the second task. Yes. Now, you will use the same argument called Kwargs. Okay, just remove this thing. Makes sense. And you can remove this thing here as well. Now, what will happen? You need to now access the TI variable, because within the TI variable, we have XCOMs, right? So I'll simply, first of all, fetch the TI same way I did it there. But this time, instead of using push, I will use pull. Pulling XCOMs, push by first task. Perfect. So fetch data will become ti.xcom pull, task ID equals to first task. That means this XCOM push, I want to pull it from this task, this first task, right? And key, what is the key? I need to use the same key, which is return result. Simple. Make sense? Okay, perfect. So this is a return result. Now just tell me one thing. We know that this is a kind of dictionary, right? Okay. So first of all, let me just remove it. Okay. I can simply say data. I can just do it later on as well. Perfect. So now I will simply say data. Like what is fetched data? Or I can just use it here as well, because this is just a dictionary. It will just complete the code in one line, because this is just a dictionary. Because once this thing is fetched, that means we can access any dictionary, any value, right? Perfect. So that's how we can just pull the information manually. Make sense? So this is my XCOM pull and XCOM push. Now let's say I want to push the same thing, the same way we did it above. So I'll simply say ti dot XCOM push, ti.xcom push, and key, let's say I can just keep a different key as well. It's not a big deal. I will simply say return result. Okay, this time as well, and value is this one. Simple. And I will do the same thing here as well. So that's how we can just do the XCOMs manually. Now let's test it. Manual. Perfect. Now let's see what will happen, and let's wait for it to parse it first of all. And oh, it has already parsed. Okay, or I will say Kwargs. Okay, Kwargs and Kwargs here as well. Perfect. Now if I just go to this particular DAG folder, I should see, okay, there's one syntax error. Very good. Let's see what is the error. See, if you have some syntax errors, it will be coming like this. Wow, let's see. So it is saying, let's click here just to see the error. It is saying too many positional arguments. Okay, makes sense. I know the error. The error is in the dependencies. So if I see now, I do not need to pass this particular dependency, right? Because we are not using any parameter. We are directly using XCOM directly. We do not need any kind of parameter. So here I can simply say first, second, third, because we are not using parameters. So we need to define the dependencies. Perfect. Now let's actually refresh it and it should fix the issue. Perfect. As you can see, XCOM DAG Kwargs. Let me just open it. And here, as you can see, it is rendered perfectly, but I want to run it just to make sure it is running fine. So let's trigger it. And success. Very good. If I just go to first task, okay, extracting data, this is the first task. That exactly what we printed, and we returned nothing, right? Very good. If I go to XCOM, instead of seeing return value, this time I'm seeing return result because I have manually created the XCOM. And what is the value? The same thing that I have provided, data and dictionary. Wow. If I go to second task, where is second task? Here. If I go to XCOM, return result, and this is the result. See, exactly the same thing. Then third task, XCOM, and this is the thing. That's how we can just create DAGs while passing the context between the tasks dynamically using the automated method and using the manual method. I personally like using the manual method because I know what exactly I'm accessing instead of just returning the results and just relying on that thing. But it's your personal choice. You can use the automated method as well. It totally depends upon the requirements. Data engineering is all about picking the best solution according to the requirements, because there is no hard and set rule. There is no, you can say, strict rules that, hey, you have to use this, no, you just need to get your work done by any tool, by any method, by any kind of thing. That is the best thing about data engineering. You do not need to follow anyone. You just need to follow your own development and get the work done. Some people will like it, some people will not, but that is not your work. You just need to complete the work. Simple. Just say, if you do not like my code, I do not like your code. There's no you can say a topic of discussion like you are senior and you are saying that, hey, you do not like my code. Okay, I'm junior, I don't like your code. What is the big thing? Chill, bro, chill. So this is also done, XCOMs. Now let's talk about the parallel tasks. Now if we just want to run some parallel tasks, how we can just run parallel tasks? Let's say you want to just run 1, 2, 3, or let's say so many tasks, right, in parallel. So in that particular thing, you just need to create task as you are creating right now, but you can just define the dependencies accordingly. Make sense? Like you can just define the dependencies accordingly. Let's say you want to run 3 tasks in parallel, and then you are just combining all the results and then you're just passing it to something else. Let me just show you with the diagram. Okay, so XCOMs is good, and I hope that you have got amazing understanding with this, because XCOMs is something like which makes you an outlier in the crowd, because not everyone is aware of XCOMs in detail, especially. Okay, and everyone is afraid of XCOMs except my data fam. My data fam loves XCOMs because I love XCOM. Okay, so now let's talk about the parallel tasks. Now, what is this parallel tasks? For example, let's say you have a workflow, a DAG, basically like this. Let's say this is the first task, this is the second task, or let's say this is the second task. Then you have third task, then you have fourth task, and then you have this task running after this. Make sense? Let's say 1, and then you have 2, and then you have 3, and then once all of these tasks are completed, only then you need to run this particular task. Okay, you cannot run this task if that task is not completed. So how can you just create this type of task? Task 1, task 2, task 3, task 4, and task 5. Simple. So first of all, you will run the task 1. Then you will run all of these 3 tasks in parallel. Then once all of these 3 tasks are completed, only then you need to run the task 5. But there is an amazing thing about this thing, that you also need to use the context of these things. Make sense? You just need to use the context as well. Now you already know XCOM, so it is not a big deal for you. Make sense? Okay, and to be honest, this DAG is also not a big deal. This is just about defining the dependencies, and that's it. Simple. Okay. Now what I will do, I will simply create task 1 quickly. Okay, let's do it. So let's create a new notebook, 6th and parallel tasks .py, and let's use this simple task. Perfect. So first task, as we know, and let me quickly change this thing, parallel DAG and parallel DAG. Perfect. So first task is very important. Let's say first task is data extraction. Let's provide a good name this time. Extract data. Okay, extract data. Second is, let's wait for, let me snooze it. So extract task. Okay, so now I'm extracting the data and I'm saying extracting data, tuck, and that's it. Now what I will do, I will return a dictionary. Okay, I can use XCOM push if I want to. Let's use XCOM push because it is a better way to do it. Kwargs, and I can simply say ti equals Kwargs of ti, and I want to push data, extracted data dictionary equals extracted data. Okay, and data will look like, let's say, extracted data. Let's create something else. Oh yeah, let me just do one thing. Let me say API extracted data. Let's say this is like extracted from API. The data is 1, 2, 3. Okay, and then we have DB extracted data. Okay, and then I can simply say 4, 5, 6. Okay, and then I have, let's say, one more extracted data, that let's say files, or let's say data lake. For S3 extracted data. Simple. Then we have 7, 8, 9. Perfect. So this is my extracted data, and I want to say ti dot XCOM push key equals, let's say, return value, the same one, because return value is like commonly used. So return value, and value equals extracted data dictionary. Perfect. This is data extracted. Now I want to create 3 tasks. Okay, and let me just use this, my boy, for that, and I will simply remove all of these tasks, and I will simply say task.python and Okay, I will say transform task, and this task is for API, right? And here I will simply first of all pass the Kwargs, then I will extract the TI, then extracted data, and here I will say API extract data because I just want to extract the API data. API extracted data, ti.xcompile, and perfect. So this way I have only pulled the API extracted data, nothing else, because I want to just you can say extract the API data. That's it, right? So I have just done this thing. Okay, now I will do one thing. I will simply say transforming API data. I will just pass it dynamically, and I will, let's say, transform this data by multiplying it by 10 of each number. Perfect. And then I will simply say ti.xcom push. The key is not key, like we will just keep the key same, return value, and key is this one. Wow. Let's create two more tasks same way, right? And this will be my DB, and the same thing for the third one, which is S3. Perfect. See, that's how you use AI. Not to just replace humans, but to make humans to work faster on the redundant tasks. See, so that's how we have just performed or created these three tasks. Now we just need to create final task which will use the value of all of the things, right? All of the things. Or you can do one more thing, which is a kind of senior thing, but I think it will actually okay, ti.xcom push and task id equals to this. It's fine. Okay, let's do it. Task.bash, because I just want to echo the final result. I will simply say load task, loading data to the destination, and I want to display as well. I want to return. First of all, I will load the data. So I will simply say Kwargs. Yes, you can use Kwargs in the bash function as well. And here I will use API data equals to this, and DB data, S3 data. Perfect. And print, or not print, return, because I want to echo. I will simply say return echo loaded data, and I can use fstring as well because this is rendering. Loaded data and bureau API data, DB data, S3 data. Perfect. So that's what I want to return. Okay, now comes the most complex part of this parallel tasking. So now we have all the tasks ready. Now I want to define the DAG accordingly. So if you just look at that particular thing, we have task 1, so we will just define this task normally. That is fine. But after task 1, I need to define all of these three tasks in parallel. Okay, I want to define all of these three tasks in parallel, and then after defining all of these three tasks in parallel, then I need to define this task 5. Okay, let's see how we can just do that. So I'll simply say defining the task dependencies. So first one will be, let's say, extract, and then transform, and then transform DB, all of these functions, and then load. So dependencies will be first of all first task, and then list of all the three tasks, and then the final task, because these tasks will be running in parallel. That's why we have to define it together. That's it. Literally that's it. See, this is so simple. Now let's see if our DAG is parsed. Okay, let me open Airflow. Parallel DAG, perfect. Perfect. I want to just check this thing if it is accurate or not. Yes, it is accurate. See, we have created our DAG in an amazing way. Do you know what? This is looking amazing because we have used XCOM and XPush. If you use the traditional method, it can just mess up with the you can say these strings, because this one can be directly connected to this one because this is directly related to it. So it can mess up in the diagram, but it runs fine. But it can just give a pseudo DAG overview. That's why I like using XCOM push and XCOM pull, right? Okay, good. So now I want to trigger it because triggering is important, because we want to make sure our DAG is running. Okay, perfect. So let's start with the first task, extract task. Extracting data, perfect. And XCOM is this one. Three items, DB extracted, S3 extracted, and API extracted. Perfect. Now if I just go to transform data, okay, transforming this data, very good. XCOM is this one, very good. Then second task, very good. Third task, very good. Third term transforming API data is 1, 2, 3. Okay. Okay, makes sense. Okay, S3 data is 7, 8, 9. Perfect. Now if I just go to the final task, which is important. So here we can see that our bash command is also running fine. Loaded data, first, second, and third. Perfect. And you can also see the render template. Render template is used to check the bash command. So this is the bash command that it will run. And this is the XCOM push. That means the final data. Perfect. Wow. Literally wow. Looking like a wow. This is amazing, bro. So that's how you can just run the parallel tasks, or basically tasks in parallel. Now, let's try to extend this particular DAG. Here, we do not want to run task 5. No. Here I will put a decider. Okay. Here I will put a decider. This will decide. Okay, decider. It will decide if you should run. This is too big, man. If you should run the task 5 or task 6. Okay, so this will be decide, or let's say if. Okay, let's say if. So now it will decide whether you should run task 5 or task 6. Okay, let's say task 5 and task 6. You cannot directly run task 5. No, you have to decide. This is a kind of branch now that you are trying to create. This is a branch, and branch we always denote it with the dotted lines. Perfect. So now these two are branches. That means it is actually dependent on the answer that it will return. Okay. So how can we just do that? Let me just show you. So it is called, first of all, the branch. Okay. Branch. It is also called as conditional task. If you would have heard about this thing like conditional task, but more or less what it will be just a function, just a normal function. But we need to define a decorator called @task.branch. Once we do that, we simply need to make sure that we return the node name. This node name in this one. Okay, makes sense. Okay, very good. Now what I will do, I will just show you with the help of code. Now let's actually clone this, copy and paste. Where is paste? Where is paste? Let me use my keyboard. Okay, 7, and let me just call it as branches. Okay, so now these 3 tasks are done, but now for bash we cannot directly run it, right? Okay, we cannot directly run it. Okay, now I would need to decide a condition. Okay, let's try to make a hypothetical condition that we can use. So what I will do now here in the extracted data, okay, I will add one more key, which is, let's say, weekend flag. Okay, weekend flag, and I will just make it as, for now, false. False, right? So the condition is very simple. If the weekend flag is equals to false, then run this command. Okay, that means it is a weekday data. If the weekend flag is true, then you need to run a new function that I'm just trying to write it right now. And the function is very, very, very positive. It is called no load data, or basically no load task, and Kwargs. Okay, and it's weekend skipping load task. Wow. Okay, if this, why it is like this? Kwargs. Okay, Kwargs. What is wrong? Oh, okay, makes sense. Out of excitement, I forgot that we need to use task.bash. Okay, def, and then we need to say no load task. Perfect. So no load task is done, and Kwargs echo no load task executed. No loading on weekends. We do not load any data on the weekend, bro. So just chill, right? So we need to run this task. But who will decide that we need to run this one or this one? Obviously flag, but who will decide the, you can say, condition of that flag? Right now, this one. So this is my branch, creating the decider node. Okay, so this will be a kind of branch, task dot branch, right? And here I will simply decide a function called, let's say, decider task, and Kwargs, and I'll simply say ti equals Kwargs dot Kwargs of ti, and weekend flag, obviously we can just fetch it, and now you are pro to fetch the data like this. So I'm here saying if weekend flag equals to true, then return this thing, no load task, otherwise return load task. Now this is very important. You need to make sure the value you are returning here should match with the exact function name. See, load task, no load task, no load task. That means we are returning the task name in the return value. That is also a task ID. To be more technical, it is a task ID. So you need to return the task ID in the return value. Otherwise it can just mess up, because it doesn't know. If I, let's say, write no load task weekend, it will just mess up because I do not know what is no load task weekend. So I have to say no load task. That's it. Make sense? Okay. Now it's time to just redefine everything. Okay. So now we have no load task as well. So now these are all of the variables. Now how we will be deciding it? Let me just show you. So first of all, we need to extract the data no matter what happens, right? Then we need to run all the 3 tasks in parallel. That is for sure, right? Then I need to run decider task, which is this one. And then I need to again define a list of both the tasks. Now this list is not equivalent to this list. Why? Because this list is saying that run all the 3 tasks. But this list is not saying run both the tasks. This list is saying that this decider task will decide which one to pick from this list. Oh, okay. So that means not all the tasks will be running here. No. Only that task will run from this list. The task ID, this particular task will return. Make sense? So this list is totally different from this one. Because in this list, we do not have any kind of, you can say, decider or whatever. We simply extract the data. But here we have a decider task. That means we are saying, hey, you just need to pick only that task whose task ID is returned in this particular function, decider task. Okay, cool. So let's say branches, or let's say branch DAG. Branch and branch. Let's see, bro. Let's see. Where is my coffee? Here's my coffee. Now let's go to DAGs. Let's go to where it is, branch DAG. Perfect. So let me first of all see the branch. Like I want to see the DAG. DAG looks perfect. Extract, and then we extract, transform, decider, and then load and no load. Perfect. Let's try to run it. Let's see what will happen. Fingers crossed. Why? Perfect. As you can see, our DAG ran successfully, and let me show you what happened. See, this task ran, all the 3 tasks ran, then this decider node ran, but only this task ran and this was skipped. Why? Because the weekend flag was flagged as false. Simple. This is skipped. Wow. That's how you create the conditional DAGs. That's how you can just pass the condition, the branches within DAGs. Make sense? Make sense? Make sense? I hope that you have everything clear in your super duper amazing brain. Okay. Now Now, congratulations, first of all, because you have covered almost all of the things related to tasks and branches. Now we need to learn the advanced, not advanced basically, let me just be honest, not advanced, but those things which are important for the operations. So now you know how to build the DAGs, now you know how to just work with XCOMs, now you know how to just do this thing, you know almost everything, everything. Now the thing is, now you need to know how to schedule your DAG. Because see, DAG creation is one thing, DAG scheduling is another thing. And obviously, if you're just working with Airflow, you need to take care of both the things, scheduling plus you can say development, right? So now we'll just talk about the scheduling. Okay, and scheduling is very easy. Scheduling is fun. Scheduling is fun. Scheduling is like very fun, and you will have fun. Don't worry. Don't worry at all, bro. Don't worry. Okay. Scheduling in Airflow. Flow. Oh. Should I start teaching in IITs? See, the thing is, I haven't seen any university, any big university teaching data engineering. I don't know why. I don't know why. So if they want to start any new subject, any new module related to data engineering, you can just tell them that we have a guy, okay, and yeah, he is not a PhD on paper, but I don't know, like how will it like how will it look like? I don't know. Okay, now let's talk about scheduling in Airflow. So now the very important concept within this, why I'm slipping. So scheduling is just about the scheduling the DAG. Let's say you have this DAG. Let's say you have this DAG. Perfect. Now it is built, tested, deployed. Cool. Now the real stuff. I want to schedule it. Okay, I want to schedule it. Everything is done, everything is amazing. I love my DAG, but now it's time to schedule it. Okay, now let's bring the clock. Do we have clock or timer? Just to give me a good icon for clock. I need to bring some more libraries for here. Okay, do we have no? Okay, let me just create my own. Okay, so now we need to schedule it. Okay, perfect. Now I want to schedule it. Makes sense? Like this. So now I want to schedule it so that this DAG now will be running automatically. I don't need to run it again and again and again. No, bro, not at all. Why will I do this? Okay. So now in this particular scenario, you can schedule your DAG. Now, whenever you just talk about scheduling, there are four very important variables. Some are optional, some are required. I will just tell you both the things. Okay. The very first thing, which is like non-negotiable, start date from, or you can say from which date you want to start your DAG execution. Okay, so there are some variables. Let me just write it for you. Variable number one is start date. Perfect. Start date. Okay, and this is, I think, required. Okay, this is required. Then we have one more, end date, which is optional. You can just skip it, because if you do not define any end date, it will just take the date as your current date and it will just keep on running. It is optional. Perfect. Then we have one more, which is amazing. which is called catch up. I think catch up is also optional. Yeah. Catch up is an amazing concept. Don't worry, we'll just talk about it. So this is also optional. And then we have schedule. This is required. Now what is this schedule? Now what is this schedule? Schedule is what is the difference between start date and schedule? What is this? Start date means from which date you want to start your execution. Schedule means timing, interval, day, date, all of those things. So start date is just like the starting point. Like let's say you just put start date as 1st of January 2026 and that's it. It will be like running after that. But schedule is the main thing. Schedule is the backbone of everything. Schedule variable. Okay. Okay, Ansh, what is catch up? Very simple parameter. Let me just write it for you because this parameter is important. So it is nothing but it is used to tell Airflow to run the DAG for the missed intervals. What does it mean, Ansh Lamba? It sounds very, very fancy. It means let's say you have defined your DAG to start at 1st of January 2026. Perfect. Don't worry, we'll just see the examples of catch up as well. Don't worry. So let's say you have defined the DAG to be executed to be like executing starting 1st of January 2026, and actually the date on which the DAG is deployed is 28th of January, right? So there is a gap of 28 days, right, between 1st of January and 28th of January. So catch up means if you want to catch up that interval, if you just want to catch up that missed interval, so you can just make it as true. That means it will just run for all the previous intervals. If you make it false, it will not run it for those intervals. It will simply start running from the current interval. That's it. Simple, 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 very simple. Okay. Now let me just show you how you can just use the schedule button, because start date is very, very simple. Start date is very, very simple. Okay. So now we have multiple methods to define or basically to write the value for our schedule. Okay, we have let me just create this start date or schedule. So now schedule, in schedule we have 3 ways. Okay, basically three in total 3. The most popular one is just one. Okay, Cron syntax. Okay. But we use some presets as well, and we use one delta trigger as well. So let's say the first method is preset. It is called presets. Presets means it is automatically defined for you by Airflow. Okay. Cool. Okay. Presets. Presets such as you can say hourly or daily, hourly, weekly, monthly, all of these things. And this runs your DAG daily at midnight. Okay, daily at midnight. So daily at 12 a.m, weekly at 12 a.m, monthly at 12 a.m, hourly means hourly, no 12 a.m, obviously. So these are the presets defined in Airflow for us. Make sense? Let's try to see the example for this before directly jumping on to the, you can say, cron syntax. It is not like very difficult like cron, but we should first of all simply see the cron syntax. Okay, or see the preset syntax. So now let me just open that particular VS Code editor for you. Okay, so let's open it and let's try to create our schedule. And don't worry, all of these notebooks, everything will be available to you. All of these notes that I'm building it for you. Just hit the subscribe button, bro. Please, if you want to support my hard work. A lot of you, I know, love me a lot, but sometimes out of that love, out of that particular magic in my eyes, you forgot to just hit the subscribe button. Just hit the subscribe button right now. Okay, do it right now, bro. Do it right now. It will be beneficial for you. I'm just telling it for you. Make sense? So now let's create our first schedule, or you can say preset, or let's say schedule preset .py. Okay. So now in order to do that, let me just quickly bring the very basic code, because here we are just learning about schedules. So we do not need to write very complex thing. So what we need to do it here, so everything will be exactly same. We simply need to change the parameters in the DAG decorator. I will simply say start date equals, let's say 2026. Okay. 01, and not 01, I will say 26th, because I will just show you something. Okay, just for now it is fine. Makes sense? Okay, now I can just do it like this, like start date and 2026, but it is not a very good way to do it, because it can just mess up. You can just convert this date. So the ideal way to use it, start date, is using Pendulum. Pendulum is a library which is well supported in Airflow to just work with the date times. Yes, we can use the default datetime library which is available in Python, but if you want to work with datetime library directly, you need to make all of the conversions. You need to take care of all of those manual conversions, but with Pendulum it takes care of all of the things, because we just need to pass the time zone and that's it. It will automatically convert the time zone for you. But if you're using the default datetime library, you need to do that. Simple. Good. So I will simply say from Pendulum import datetime, and here I can simply say datetime this, and this is not enough. The ideal way is this one, year equals to this, month equals to 2026. Bro, are you mad? So this is my date, 2026-01-01. And you know what, if I just pass this thing, it is not a wrong syntax, but it can mess up if you are working in a different time zone, because by default it will run in the UTC, and I am not in UTC. I am in where do I live? So see, currently today around 28th of January, almost 4 p.m. Currently I am in the America/Halifax time zone. Okay, currently at this moment. Okay, because Ansh Lamba is Ansh Lamba, so we need to say TZ, which is time zone, equals to the time zone that we have. So my time zone is currently America slash not New York for now, Halifax for today. Okay, so this is my time zone. Okay, for now. So I will define this thing so that it will automatically sync up all of those things. Okay, and why when do I need to run this DAG? I need to schedule it to run it daily. So I can simply say daily like this. Simple. Okay, if I will say first schedule DAG and first schedule DAG. Perfect. If I just run this, or basically if I just parse this, you will see this DAG. Currently it is not passed. Let's wait. So if we just parse this DAG, this will automatically schedule it, but it will not run anything because we have not enabled this DAG by default. We have to do it in the Airflow UI. We can also automate this thing. I will just show you. There's a flag, I think it's called is paused upon creation. So we can just make it as false, then it will be auto enabled. Okay, let's do it, because it is a option that you should know. Today the coffee is really good. So let's wait for it to parse it. Now if I see this thing, okay, 7, sometimes it takes time. Okay, sometimes it takes time, so you can just refresh it, and sometimes it will take more than 30 seconds. It can happen if you're just importing some more libraries. It can take time to render it. Internal thing, you have nothing to do with this, but you can just wait. Okay, because see, you are seeing that I am also waiting. It's not like something in your machine. It is like how Airflow works. By the way, I love LangGraph as well, if you feel that thing, because see, LangGraph is doing an amazing thing on its own. Okay, and you do not need to set up all of this complex architecture when you are working with LangGraph. You simply need to import the library and that's it, right? But Airflow is built in such a way where you can just scale to, I would say, thousands of DAGs. You can run the DAGs for the entire organization. But LangGraph is just like built for one LangGraph for one project. Simple. Makes sense, makes sense, makes sense. Okay, it is taking too much, bro. This is too much. 7 branches. Sometime it takes, so yeah, let me just fast forward it. So as you can see that my tag is finally parsed after so long. So it was taking so much of time. So then what I did, you can also do it if in your case you can see these kinds of issues. Go to airflow.config and just make it 30 seconds because sometimes DAG need more time to parse, because what would happen, it would try to parse the entire DAG in 10 seconds, and if it is not able to parse it, it will just try again, and then again it is not able to parse in 10 seconds. So it can happen, and it happens when we are just importing some libraries. So just make it to 30 seconds and then it will just try to parse the entire DAG in 30 seconds and it should be able to parse it. Just a pro tip again. So now it is parsed. Let's go to my Airflow, go to DAGs, and first schedule DAG or schedule. Oh, where is that? What? Why I'm seeing just 7 DAGs? Why? Let me just refresh. Okay, I think there's one issue, maybe 8 schedule preset. Okay, 8 schedule preset. Oh, okay. This name is fine for schedule DAG. Oh, I didn't change the name. Very good, Ansh Lamba. Very good. Slow claps. First schedule DAG. Perfect. Now let's see. Okay, see, it started running. Why? Let me just show you what actually happened. So this is my DAG 1 2 3. If I go to runs, you will see that it has automatically run for this particular thing. Why? Let me show you why. So if I just open my, you can say, DAG, it was saying that is paused upon creation. No, that means it was automatically enabled, right? And I have scheduled it to daily. That means it would run every day at 12 a.m. Makes sense. And today is 28th of January, and today, like right now, it is like almost 4:15 p.m. That means it has already surpassed that time, right? 12 a.m. So it needs to run the DAG. So that's why it ran the DAG. See, automatically. Wow. This is amazing. Yes, because now I have just enabled it automatically through my code. So I do not need to enable it. And you can also see the schedule timing. It is saying 00 asterisk asterisk asterisk. This is a kind of cron syntax. 0 means the first 0 means hour. That means 00. Then second 0 means the, I think it's like 12. Yeah, I think minutes and hours. And then it will just say day, week, day, and month, whatever. I will just show you the exact cron syntax. You do not need to remember it, but yeah, it is like very obvious. Like first one is, and then second one is, and then third, fourth, and fifth. So this is like minutes and hours and all those things. Make sense? So that's how you can just run all of those things in the schedule. If you want to use presets, okay. So now what if I do not want to use any preset and I want to use cron syntax? The same thing, because cron syntax allows you to just define or basically modify the schedule. So let's say I do not want to run my schedule at 12 a.m. Okay, I want to run it at 3 p.m, 4 p.m, 5 p.m, like this. Then in that particular scenario, I can use the cron syntax. Simple. Okay, so the first minute, then hour, then day, then month, then day of week, whatever. I will just show you, don't worry. So that's how you can just do it. But before that, I want to show you something which is called catch up. The same thing that we talked about. If I say catch up equals to true, because by default in the Apache Airflow 3.0 plus onwards, it is automatically, I would say, disabled. But in Apache Airflow 3, like before the version of 3.0, it was automatically enabled. So if we want to use catch up, we have to just make it true. So now if I just go to this thing, if I refresh it, and if I go to DAG runs, now let's say, let me just click here. Perfect. And for schedule DAGs and then runs. Okay, so it is saying that it is scheduled. Okay, because yeah, makes sense, because we have already run the thing. So now in the second schedule, now in the second run, it will automatically pick all of the catch up dates as well. So let me just do one thing. Let me just recreate this tag. So we will just make this catch up change in our next tag so that you can just see like it will just load all of the catch up is also called as initial load. So whenever you are just running the DAG, you need to make sure like you want to catch up everything. Make sense? And one more thing that you can see, the run type is scheduled. That means you are like you have run this particular DAG through scheduled, not a manual trigger. Because when you just run it manually, you see this thing, single run. And if you just trigger it, you will see the manual, right? But currently you are seeing the scheduled. Okay, now let me just take you to the second way of running it using a cron syntax. Cron. Now cron is the most, you can say, used syntax. Okay, so now if I just take you to the documentation, any guide, cron syntax, cron helper, you can just go to any, there are so many websites for it. And in the book it is also, or in the documentation it is written that you can just follow cron guru tab something, you can just follow that. But this is the thing that you can just follow. First asterisk is for minutes, and then hours, then day of the month, that means 1 2 3 4 5 6, and then which month, and then day of week. Make sense? Make sense? Make sense? Simple. Okay, so now let's say I want to define a trigger. Where is my, okay, let me just copy and paste it, and let me just rename, and I will say schedule cron. See, these things are very simple that you can just learn while just looking at the references as well, but still I'm just telling you everything so that you can just create one-stop solution for your Airflow practice and Airflow nodes. Okay, but these things are like very common. Like you do not actually need to write the code for everything, because when you will be actually scheduling it, you can just go to the documentation and you can just read and copy the exact cron syntax. This is not something that you need to remember. No one will ask you, hey, write the cron syntax for this. And if someone asks you this thing, just say like, bro, get alive, what are you doing? Like, what is the cron syntax for this? It is equivalent to ask someone like, what is 18 multiply 20? I know it is like 3600, but still, like, why are you asking me this question? Is it 3600? 18 into 30? Yeah. 18, yeah. 360, not 3600, 360. But does it make any sense to ask this question? We have calculators, right? I don't know, like, what's going on in the life. People are just asking stupid questions, and then they are judging someone like if the person is eligible or not for any kind of work. And then they say, we do not hire good talent, because you do not even know how to hire good talent. You ask stupid questions in the interviews, and you just reject the, you can say, the talented developers by asking those stupid questions, asking DSA questions, which is not even like important for data engineers or whatever. Then you say, hey, we cannot find the good talent because you asked DSA questions. You do not assign the person with any DSA task. You assign the person with actual development of data engineering, and then you say we do not hire, we cannot find good talent because you are dumb. The one who is hiring is dumb. We have a lot of talent. We have a lot of talent in the industry. We have a lot of amazing developers. Okay, you do not know how to hire them. You do not know how to just onboard them. Just keep asking those silly questions, just keep asking those dumb questions, those garbage questions, and then say, hey, we cannot find good talent, we do not have good talent in the industry now, blah blah. Bro, Ansh, Lamba, just do something, do something for this industry, bro. Allow me some time. So now let's try to schedule this particular DAG with the cron syntax. Okay, so cron syntax is very easy, but for that you need to import one special library. It is not library, basically a function that you can import using the class that we have within the DAGs. Okay, and it is called, I think, cron table something, cron trigger timetable, and this is the library for it. I can just bring it here from airflow.timetables.trigger. Again, you do not need to remember it, just get it from the documentation. Why? Because they keep on changing the functions, the class name, so you do not need to remember it, right? So once I have this cron trigger timetable, I can just use it in place of daily. So I will say cron trigger timetable, And now I need to define the cron. So let's say I want to run this particular DAG every day. So minutes will be approximately, I think, let's say, first of all, let me just put double quotes. Cron trigger timetable. So I want to run it at 4:00, right? Like 4 p.m. So it will be 0 first of all, and then hour will be 16 because the conversion of 4 p.m. into 24-hour format is 16. Then I want to run it on every day because the third option is for day. So every day, and then for every month, and then Monday to Friday. Let's say I just want to run it between the weekdays, not on the weekend. So I can just use this hyphen, Monday to Friday. Okay. Again, you do not need to remember everything. And start date is start date. Let me just reduce it to 26th. Simple. Okay. And we haven't put the end date, which is fine. Very good. Or let me just put the end date because it will be keep on running whenever I'll be just using this thing. Okay. Month is 1 and let's say 31st. Perfect. Okay. So now you can just refer to cron every time you want to go. So let's say I will just copy and paste the same cron that I have put it here just to confirm like what is the output of it. So this is the output of it. And nowadays we have bro ChatGPT or agent. Just say I want cron syntax for this one. Just try to learn how to work with AI. So see, it is saying minutes, that means 00, hours 4 p.m, day of month, that means all the 31 or 30 whatever days we have in the month. Then month, that means throughout the year. Days of week, we have Monday to Friday. Simple. Why it is not showing Monday to Friday? Because it is right syntax, we can just write it like this, Monday to Friday. And I'm so sure about this. And we have so many other things as well. See, we have cron syntax guide here as well. And then you can say cron hub. Okay. Oh, this was the tab which was mentioned in the book. So see, cron tab guru. And let me just paste my thing here. So as you can see, not standard may not work. Minute. Why? Oh, because I have put 0. Makes sense. I can just say asterisk. Because not asterisk. What is asterisk? I will simply say 0. Minute 0 to 59 values. Yeah, I have just put 0. Okay, step values and yearly standard monitor your this thing. Okay, let me just try to run this. Let's see like what will be the value of this. Let me just run it. So, or I can just simply ask this as well. I want to write cron syntax for running my job at 4 p.m. daily. Let's confirm, right? So it has also given the same thing. That means it is confirmed that it is the right one. Oh, okay. So this is 016 and asterisk. I can just put Monday to Friday. It's not a big deal. I know it is correct. And let's see. It can be, you can say minor changes, but I don't think so there's like major changes for Monday to Friday because we can just put all the days in the style of hyphen as well, like Monday to Friday, run every weekday, because this is like latest change, so maybe they are also not aware of this thing, but I am sure 99%, 1% I'm not sure, but let's see. Let me just run this particular DAG cron, perfect. Let's see if it is parsed or not. Yes, it is parsed. Now if I just go to my Airflow DAGs, okay, we have an error. Okay, no worries. Required key only argument time zone. Oh, that is important. So we missed one important thing. What is that? The time zone. Because we didn't pass any kind of time zone, right? So I need to just say, hey, time zone is this one. By default, obviously it is UTC, but that is a very good catch. Time zone equals to America Halifax. Perfect. Now let's see my Airflow. Okay, now it's gone. Very good. Now see, it has started running. Why? If you just see 2 runs, I can see 3 runs. Why this time 3 runs? Because I have enabled catch up. And the start date was 26th of January. That means 26, 27 and 28. 3 runs in total. Wow. This is amazing. And this syntax is absolutely correct. See, it is running. I'm so sure. All these websites are telling you wrong thing. I'm telling you it is right. Because I just saw this latest syntax in the book that I just showed you in the beginning of the video. It was written there. Like we can just use Monday to Friday like this. Right? And if I just write asterisk here, what will be the output? That means on every day. On every day. But when I write Monday to Friday, it will become only Monday to Friday. Make sense? Simple. So that is just like basic cron syntax. You can just spend 10 to 15 minutes and you will be able to understand all of the cron syntax. It is nothing magical. See, the first one is minutes. Second one is hour. Then date, on which date you want to run it. Then the fourth object is, you can say, month number, on which month you want to run. There are total 12 months. You can maybe run it on every January or every February. Then Monday to Friday. Simple. And we have enabled catch up. That means it ran for all the previous intervals as well. Perfect. That is the thing. That is the thing. Now, what is the third option? The third option is very simple. Third option is called delta. Delta or frequency. You will see this frequency word as well. And you will see delta as well. Why I'm using delta? Because the class and function name is delta. So that's why. Delta. So now what is in delta? So I can just write a dummy code for you. 0, 16, asterisk, Monday to Friday. Perfect. Perfect. Now in delta. Now do you know what? We can do a lot of stuff with cron, but there is still one thing that we cannot do with cron. What? Really? What we can do, like what we cannot do with cron? So let's say I want to run this DAG. Where is my DAG? See this DAG. I want to run this DAG on every, you can say, third day. Okay. On every third day. Or let's say after 3 days. Make sense? Okay. On every, or let's say after 3 days. So what will be the execution? Let's say I want to start this DAG on, you can say 1st of January. So the first run will be on 1st, then 4, then 7, then 10, then 13, then 16, then 19, then 22, then 25, then 28. Then the next one will be on 1st, 29, 30, 31. Like it depends. It depends. So 29, 30, 31, right? But let's say I said 31, 29, 30, 31. Yeah. Then I can just write it like this. I can just achieve this thing using cron very easily, because what I will do, I will say 0, 16. Let's say I want to run it for run at 4 p.m. every day. But on the day, I will not pick asterisks. I will put these dates 1, 4, 7, 10, 13, 16 and blah, 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 blah. Perfect. But now here comes the thing. So this is fine for 1 month. What about the next month? It will again start the date from 1st for February. Okay. It will fail after this thing because we do not have 31st for February. One problem. That is not the only problem. Let me just write the problem. So let's say February. It will start from 1st. Okay. And it cannot go beyond 28 or 29. Right. So this is problem number 1. Okay. Then one more problem. Why are you just going till 28, 29? Just check it here. Should your DAG run from 1st? No. Your DAG should run on the 2nd or 3rd, because 31st and then 1, 2 and 3. The DAG should run from 3rd. Right? Perfect. This is the right interval. Like this. And then obviously the whole thing will be changed. Let's say 3. The whole thing will be changed. Let's say 3, 6, 9, 12, 15, 18, 21, 24, 27. That's it. This is the right one. This is the right one. So we cannot achieve this thing with the cron. We have to just create a different cron for different month. We cannot do this. That's where the concept of delta trigger in Airflow comes into the picture. So delta trigger is like totally like almost same as your cron, but here we just use one special function called duration. Okay, duration. So here what you will do, you will simply say, you will go to your DAG, and let me just create a new DAG, and this will be called as 10th schedule delta. So here what I will do, I will not use this cron trigger timetable. I will use one more thing. I will use delta trigger timetable, and here I will use delta trigger timetable, and here is delta, and here is this one delta, and not time delta at all. So I will simply put it here. First of all, the duration, the date time. Duration equals, I think, date time, or basically you can say delta time pendulum dot duration. Yeah, pendulum dot duration. Pendulum dot duration. And I think if I have already imported pendulum, so we do not need to do it again. So I will simply say duration, and I can import duration as well. Perfect. So duration dot, or basically days, equals, let's say for 3. Yeah, perfect. And time zone is the same one. So now if you just run this thing, now do you know what delta schedule? Oh yeah, I know this. So now if you just trigger or basically schedule this particular DAG, what will happen? It will try to run in every 3 days, no matter what is the start of the month, what is that particular thing. Because now you are saying that, hey, the duration is 3 days. Now you do not worry about, hey, should I just put the date? Should I put the month? No. Now you are simply saying that I want to run this DAG. You can say in every 4th day, or in every 5th day, or in every 3rd day. That's how you can just perform this thing. Make sense? Now let's see our DAG here in the Airflow. If I go to DAGs, I can see 9 DAGs. Yeah, I think so. Yeah, 9th is schedule. Where's schedule? Where is schedule? Okay, so I think 10th one is not passed right now. So by the way, it is called delta schedule DAG. Is it parsed or not? No. So let's wait for, yeah, no, not now. Let me just refresh, and I hope it makes sense how to use delta trigger. And meanwhile it is just running this thing. I can just show you the documentation for delta trigger. Delta trigger Airflow. Perfect. So official documentation. So yeah, here it is the thing. Cron trigger timetable, delta trigger timetable, and multiple cron trigger timetable. I think they have added this one as well. And if we just see one example, do we have an example? No. So they have simply put the class, and that's it. And they are simply asking you to just define everything. So if you just want to add more and more parameters within your these classes, you can just come on this documentation and click on the source and just see whatever you can just add more, because it is all about the requirements, like what are you just trying to achieve. Simple. Okay, so now it is parsed. Now I can just go here and check, and it is called delta. Okay, one error. What is the error? Okay, who put the time zone? Who put the time zone here? We cannot put the time zone here. Who? Just remove it. Auto suggestion, not me. Okay, let me just refresh. Okay, perfect. Delta schedule, and you can see every 3 days at 00000. And if I just go to runs, obviously one run for 26th, and it will run next on 29th, as you can see, 3 days after. Perfect. And obviously now you can just make the changes here as well, like at what time you can just you want to run, and all the information will be here. Everything. You can see scheduling is like endless game. You will say, I want to run this DAG at this time and at this interval. Okay. Someone else will say, I want to run this DAG at this time, at this time. So it is like endless game. You can just play and just test and explore so many things with scheduling. Makes sense? But I wanted to just explain all of the 3 features that we have with Airflow. Now you are free to play with it. Just play. You have Airflow installed. Okay. You have all of the code listed here. You have all the fundamentals. Now just play. You should play. That's how you learn, right? Okay, so this was all about your scheduling, right? So next we are going to cover very important concept, which is called accessing the context date variables available for every DAG run. And it is an amazing topic. Let me just talk about it. So now let's talk about our next topic, this topic is like actually mix of 2 to 3 topics. First of all, this topic involves accessing context variables related to dates and incremental load and templates. So this is a kind of bunch of topics that we will be just covering within just one topic. Okay, because we have to cover these topics together, otherwise you won't understand anything. So what is this topic? Let me just put the heading. I can just put a very long heading as well because it consists of so many topics, but ideally I will say incremental load, okay, and templates, date templates, or just templates. Incremental load and templating. Do we have templating available in Airflow? Yeah, we have Jinja templating available in Bash operators and we have Python templating available for the Python operators using Kwargs. So let's talk about it. First of all, we need to understand why do we need this thing. Then only you will understand what is this thing. Okay, so let's say you are a developer. Okay, let's say this one. Let's say you are this developer and you are working on a solution. What type of solution? Solution is very simple. You have an enterprise where you work, let's say this one, and they have multiple, let's say your favorite company, XYZ. Okay, and this enterprise is a combination of so many subdomains, sub companies, so many departments, everything. So this is a kind of, you can say, enterprise data. Okay, perfect. Now what you need to do, you are loading the data for the entire enterprise. It can contain data for SQL, like SQL databases, right? It can have data from, you can say, files, right? Let's say some CSV files, and let's say S3 bucket, anything, IoT, anything. Just for the simplicity, let's take one example, like just one source, but it can be anything because it is applicable for any kind of source. So why did I just tell you? So that you will not feel like it is only applicable for one source. No, it is applicable for all the sources. Simple. So let's take an example of SQL because you relate with SQL more. I know that. So let's say you have this source for SQL. Okay, and let me just keep this organization here. So let's say you have the source, okay, and you are a data engineer and you need to perform the ETL or ELT, and basically you need to migrate the data, or I would say load the data from the SQL database to the data warehouse. Okay, let's say to the data warehouse. This is your end goal. How you will do it, that's not the point right now. You just need to load this data. So let's say in this SQL database, okay, you have all the data, like all the history. Let's say this organization was started in 2010, let's say, for example, and now it's 2026. So let's say it's been 16 years since the company is in operations. So now what you need to do, you need to load all the data. Okay, makes sense. So now we have the data since 2020 or 2010 till 2016. What? 2026 Jan, or let me just put a date so that it will be better. 0101. Simple. Okay, this is the start date and to 2026 0101. Simple. So this is the date. the data that we have for now. Simple. So now you are supposed to load all the data. That's not a big deal. You can do that. Simple. So what you will do, you will just build a pipeline and you will load this data here. This is called initial load. Initial load means you need to load all the data that you have, like the entire history of the data. Now this is done. Okay. Now on the second day, this SQL database received some data. Obviously, let's say today is 2nd of January. So now you have data from 1st of January till 2nd of January. Make sense? This is the new data, because obviously this database is being populated with the data every single day. So this is the new data. Now just tell me one thing. Will you load all the data? Will you load all the data? Obviously no. If you will be loading all the data, let's say like this, it will be wasted of resources. Why? Because you already have this data. Oops. You already have this data available here, right? So why you need to load all the data again? You just need to load this data, bro. Just this one. Let me just change the color. You just need to load this data. You do not need to load this data. So why are you loading this data again and again? So when you load only and only this data, that means only the new data, that becomes incremental load. Why? Because you're not loading all the data. You are only loading the data which is incremented. This is the concept of incremental load. Simple. And this is the, you can say, very, very, very basic requirement that any organization would expect from you as a data engineer, that you would know how to work with the incremental load. And you know what? Whenever we build our pipelines, it is the most important component of any pipeline, that how efficiently we can manage our incremental load. Okay. So how we will be just performing this incremental load in Airflow? So for that, we'll be using templates, or basically context date variables. Okay. What is the end goal that we need to achieve? The end goal is we need to get these dates. So for example, when I ran this pipeline for the first time, okay, I, let's say, performed some bulk operation. I just did lift and shift. That's it. But on the second day, on the new day, I want this date, this one. Okay, and I want this date. That means from date and to date, I want from and to. Okay, I want from and to. These are the two things I would need, because without it I cannot perform incremental load, right? And once I have these things, I can easily perform incremental load from and to. And you know what? Airflow, fortunately, Airflow provides us these information by default. Wow. Yes, Airflow provides us this information by default. But let me just tell you one thing before proceeding there. Being a data engineer, okay, I am a big fan of managing CDC on my own. I love managing my own CDCs. So what I do, I manage my CDCs in the data lake. So I create JSON file, okay, a kind of config file where I put last CDC, and I keep on updating it manually because I am fully responsible for it. That is a kind of approach that we follow with every single technology. You can follow that approach as well in the Airflow, because you just need to create a function which will write the data in the data lake and read the data from the data lake. That's fine. But Airflow just provides you this feature by default so that you can just use it. That doesn't mean that you have to use it, or you cannot perform incremental load without that date. No, it is not like that. If you would ask me, I will still prefer my own way of managing it, but sometimes you need to use this thing in Airflow. And I would say, if someone asks you in the interviews like how we can just achieve incremental load, then obviously you should know. But if you would ask me like how, Ansh Lamba, you will perform it, I will perform on my own. I will just write my own data using data lake APIs, and that is the perfect way to manage CDC. But in some cases, okay, because it's all about requirements, in some cases we can perform incremental load with Airflow as well. Let's say I do not have access to data lake. Let's say I do not need to involve data lake in my solution. I just need to pass my date directly in the source. I can do that. Simple. So let's try to see how we can access this particular incremental load data. Let me just show you. So let's go to our DAGs folder. Let's create another file, and I will call it as incremental load. Perfect. So incremental load. Now now you know the incremental load first of all, so that is a good thing. But now let me just tell you how incremental load works in Airflow, because that is more important. Let's say, let me just draw it for you. Let's say you have this timeline. Okay, you have this timeline. Now what you need to do, let's say you loaded all the data from the past till 1st of January. Okay, you, let's say, did lift and shift, you migrated the data using custom script, or you did anything, because there are so many ways to do the lift and shift for the history. Sometimes we also replicate the database in some cases. So there are like infinite ways to do it. So we are not talking about that. We are talking about the incremental load, right? So let's say we have loaded our data till January 1st. Simple. Okay. So this date is 2026-0101. Perfect. And this is the start date of our DAG. This is very important, okay? Start date. Start date of what? DAG. The entire DAG, right? Okay, not schedule date, start date. So now what will happen? My DAG will not run on this day. Why? So in Airflow, if we want to perform incremental load, we use a special kind of trigger, or basically not trigger, we use a special kind of schedule. It's called interval based schedule. So whatever schedules we have studied so far, they were all trigger based schedule, but this one is interval based. Why? If you just look at this example, just tell me one thing. Are we loading the data for a specific point of time, or we are loading the data for the interval? Ansh, Lamba, interval. Good. So that is why we work with interval based triggers. So what will happen in interval based triggers? First of all, this is your start date when the DAG is created, or let's say when we have defined like, okay, this DAG should run from this date. Simple. Very good. Now this DAG will not run at this date. Why? You know the answer. The answer is very simple, because it does not have any kind of interval, because we just have starting point. Okay, but on the very second day, let's say on the second day, now this DAG will execute, because now it has the interval. See, 2026-0101, 2026-0102. So do you know what? This is my interval. See, this is my interval. Oh, okay. This is my interval. Makes sense? This is my interval. So what will happen? My DAG will not execute on this day, because I do not have any interval. My DAG will execute on the end date of the interval. So let's say this is the interval. So my DAG is running for from 2026-0101 till 2026-0102, but it will just trigger, it will just start the DAG run on the end date of the interval, so that it can just catch up the interval. Make sense? Now on the second day, or basically on the next day, which is third day, now it will run on the 3rd of January. And what is the interval? 2026-0102 till 2026-0103. Make sense? This is the interval. Okay. Then so on. So just remember this thing. Whenever we create interval based triggers, and this can be an interview question as well, it will never start the DAG run on the start, or basically the initial point, because we have like two things, from and to, right? From and to dates. It will never start my DAG run from the, or you can say at the from date. It will always start my interval at the to date, so that it can just take care of the entire interval. Make sense? So let's say I have this, let's say we have just created this DAG to start the DAG runs from 260101. So just tell me one thing. Today is 3rd of January. Okay. How many DAG runs it will create? Today is 3rd of January and we started the DAG on 1st of January. The answer is 2, not 3, 2. Because the first DAG run will not initiate it at this point. It will initiate it at this point. Because it is loading the data for the interval called 2026-0101 till 2026-0102. Make sense? And so on. It will like keep on going. It will keep on going. That's how your interval based schedule work. And this is the backbone of, you can say, incremental load as well. Without it, you cannot work with incremental load because you will get 2 amazing dates. And you know what? The date name is interval start. I think it is called date interval start, but interval start is a good name to understand. Interval start and interval end. Like this. So we can access these 2 dates, which tells us that, hey, your DAG's interval start date is this one and your DAG's interval end date is this one. It tells us through the templating, through the context date variables that we can access through templates. Make sense? Okay. I know this concept is like a little bit tricky because obviously this is like a kind of thing that senior people perform, right? And you also need to become senior, so that's why you are mastering it. So now let's try to do it. So now what I will do, I will mimic the proper environment when we just want to perform the data or incremental data load. Okay. So first of all, let me just say Airflow or from Airflow. Let me say .py from Airflow .sdk import DAG and task. Okay. And we can import pendulum. Yeah. And we would need to import from Airflow dot, what is the class name? Let me just check. For incremental load, it's called Airflow dot timetables dot interval, and the class name is Cron data interval timetable. Yeah, this one. So this is the class that we are going to use, Cron data interval timetable. Make sense? Okay. So now first of all, I will create my DAG and I will say incremental DAG. I will just provide the properties later on because I want to show you first of all the tasks. Then we can just define the properties of DAG. Incremental load DAG. Perfect. So now in the very first task, I will perform the incremental load using Python operator. And in the second task, I will show you the same thing with a bash operator so that you know how to perform incremental load with both the things, Python operator and bash operator both. Okay. In bash operator, it is very much straightforward because we can use templates, Jinja templates in bash operator. In Python, we need to use Kwargs, but now you are well aware of Kwargs as well. So let's say @task.python df incremental data fetch. Okay, perfect. Now let's say I want to load some data, right? Okay, so obviously I will use some commands. Let's say select asterisk from table name, and after that I would need to pass the date, right? I would need to pass the date, like when this data should be fetched and after which date it should be fetched, before which date it should be fetched, right? So I will simply say Kwargs and date interval start equals to Kwargs date interval start. So this is a kind of function that we get with the Kwargs. Remember, Kwargs is the entire dictionary. In that dictionary, we have these 2 variables, date interval start and date interval end, which tells us that, hey, your DAG was, your DAG's interval was started at this time and it was ended at this time. Okay. Okay. Date interval start and date interval end. Simple. And I will simply say print fetching data from date interval start to date interval end. But in the real-time scenario, you can just pass these two variables in the select statement if you're using SQL query. You can pass the statement to PySpark object if you're using, let's say, any Spark notebook. So the entire goal is accessing these variables as it, because you can just access these two variables anywhere, and you can just pass these two variables anywhere. Okay, that is not the end goal. The end goal is just accessing these two variables. Make sense? Okay. So now, how can we just do the same thing with bash? Let's say I also want to access bash. Let's say I want to make an API call and I'm using any command within bash. So for bash, it is very simple, because we just use something called as your Jinja template. Okay. So in Jinja template, we have some macros built in, we have some variables built in, and we can just use those things. Let me show you. @task.bash. Okay. def incremental data, let's say process. Okay, let's say process. So I'll simply say yeah, we do not need to use Kwargs here because we can directly use the Jinja template. So I will simply say return echo processing incremental data from, and here I will use double curly braces, because if you just want to use any Jinja variable or Jinja macro, we have to use double curly braces, which tells Airflow, or it is a very basic standard for Jinja, that it is a variable. So date interval start to date interval end. Now you can ask me, how did it know that these are two variables? So these are automatically rendered for bash operators. Oh, so we do not need to like manually fetch these variables like in Python operator. No, we can directly use the Jinja variables. This is called Jinja templating. Make sense? So see, I'm not even using f strings, because this is not a kind of Python variable that I'm creating within the function. No, this is just the Jinja function, or basically you can say variable, that I'm using directly in my bash operator. Simple. Okay, good. Now we can just pass our all the parameters, or basically properties for our DAG. So first of all, I will simply define schedule equals cron data interval timetable. Now this is very important. So now what I will do, I will just show you a kind of basic example where I will run multiple times, like this DAG multiple times, so that you can just see. So today is, let's say, 29th of January. Okay, so 29th of January. So I will keep my DAG to run @daily. Okay, first of all, and I can just pass the time zone. Okay, time zone is this one. So now I will say start date. Start date is 2026 TZ Halifax. So now just tell me one thing, how many times this DAG should run, because it is starting at 26. The answer is 3 times, 27, 28 and 29. Not 4 times, just 3 times, because it will be running on the basis of the interval, right? And what we will see in those three, you can say outputs, we will see the first output as fetching data from 2026 to 2027, then 2027 to 2028, and then 2028 to 2029, like this. Simple. Very good. Now let's pass the end date as well, and then I will simply say catch up equals to true, because I want to backfill my data. Okay, that's only you will be just running this, you can say DAG multiple times, right? See, if I do not define catch up equals to true, it will not backfill. It will just run for this particular interval. If I want to run for these previous intervals as well, then obviously I need to say backfill equals to true, and here backfill means catch up. Simple. Like this is a concept that we have already discussed, but still just a revision. So catch up equals to true, and that's it. I think everything is fine. Yeah, perfect. So now let's wait for it to render our DAG, and then we can just see 11th incremental load. Okay, so it will not render it because we have not defined the dependencies. So dependencies are like this. Okay, and I can just run these tasks in parallel or in series. It's up to me, because it has nothing to do with the independent task, but just let's say run like this, and let's initialize the DAG. Okay, now let's wait. So as you will see that here it is showing 2 dates, because it is showing all of the DAGs till 28, like 28, and today it will show the DAGs for this one. So it is already rendered. Okay, so see, it also shows you the parsed DAGs by dates as well. Let me quickly open the Airflow. Localhost unauthorized, but very good. Okay, now it's fine. So now let me just go to DAGs, 11 DAGs, okay, and incremental load DAG. So now if I just go to runs, no DAG runs. Makes sense because obviously we didn't enable this thing. Let me just enable it, and perfect. See, now you are seeing 3 instances are started and all the 3 are succeeded. Simple. Now if I just open the very first one, I will see incremental data process, incremental data fetch. Let me just open this. So here I can see that it is written fetching data from 26 to 27. Makes sense. 26 to 27. Very good. Now if I just go back to the second one, then it will say 27 to 28. Makes sense. And the third one will be 28 to 29. Makes sense. That's how it works. And if I just open, let's say, bash command, and I can also see the bash command, this task, render templates, and see, this is the command. And see, it has successfully and perfectly rendered our, you can say, templated value. Simple. That's how you perform the incremental load using the context variables related to dates. And one most important factor in this is that particular interval based scheduling instead of trigger based scheduling, because you are not running your DAG for a moment of time. No, you are running the DAG for the entire interval. That is the difference. Okay, I hope it is clear. And see, this is like not a very simple thing. If you have understood this, that means it is a good one. Let me be honest with you. So if you understood this, then obviously you are doing some good learning. Very good. So this was all about our incremental load and tags and templates and all of the things. So now I think you are well versed with this. One small topic, which is like optional, but I think it is very fun to learn. So it is like, let me just ask you one question. Let's say, and it is like out of everything, so you do not need to worry about anything. So it is something like you should know. Okay, it is not like you have to know, because this is a very special requirement. Let's say you want to run your DAG which has nothing to do with any kind of interval, with any kind of, you can say, pattern, anything. It is like special dates. I just call it as special dates. Let's say you want to just run your DAG on the special dates. Let's say you want to run a DAG on your birthday. Okay, so how will you define the trigger for this one? Can you define the cron syntax for this? Like you can, but let's say there are multiple dates. Let's say you want to run DAG on your birthday, your best friend's birthday, and your family member's birthday, and that's it, right? So how will you just define that thing? Because it is impossible. And you cannot also define the delta because it is not following any kind of pattern. So in those particular scenarios, we have to schedule our DAGs using special dates, right? And it is called special schedules. Like I call it as special schedule. Okay. So how can you just do this thing? How can you just achieve this thing? So first of all, this concept is like very, very, you can say, critical. Like you will hardly see this thing in an organization, but sometimes you can. Maybe they have some, you can say, quarterly or special date events. Let's say they have some ceremonies in their organization. So you have to just do all of these things, right? And out of nowhere, it can be your interview question. Okay, so it is about special schedules. Special schedules, and we can also call it as events, because we do not know when it will come. Okay, it is very, very, very subjective. So in that particular scenario, what we do, we simply define a list of dates. So let's say you are this developer and you will be given, or you will decide some dates. Let's say I want to run this DAG on 26/01/01 on the new year. and I want to run this DAG maybe, let's say, on 02, or let's say 16th. Who is saying 14th? And then let's say I want to run this DAG on June 1st. Okay. And let's say on December 31st as well. Just a hypothetical pattern. So I have these dates. I have to just run my DAG on these dates, right? And there's no pattern, there's nothing. So what you do in this particular scenario, let me just create a new file. And how will you just define that thing? So first of all, let me just remove everything. Perfect. So first of all, you import one special class. It's called, I think, events table. Let me just confirm. Airflow, or yeah, it's called events, event table. Event table. So now you first of all define all the events, like all the holidays that you want. I will simply say special days or special dates. Okay. So this is like first date, but you can also use the date time function, which is pendulum. So I'll simply say date time equals to date time and 2026 1 and 1. Okay, simple. Let's ignore the time zone. Then let's say 15th of January, then let's say 26th of January, then let's say 30th of January. Simple. Let's say we have these 4 special dates. Simple. Now what you will do, you will simply pass all of these dates into, you can say, a function called events timetable. Okay, so I will simply say, or I can create another list, or I can do one more thing. I can simply pass this thing directly in the events table, events timetable. Okay, and then I will simply say events equals this thing. Yeah, like this. Like this, or they keep on just changing the names, man. Why? Events timetable. Let me just check the documentation. Wait. Event timetable. Okay, event dates equals to this. Oh, silly mistake. Okay, now it is good. Sometimes they just add s here, sometimes they just remove s from here. What are they doing, man? Like, this actually happens whenever you see a significant change in any technology, any framework. You will see these kinds of minor mismatches, but it is the part of the life. It is a part of the development life cycle. Okay. So now we have these special dates. So now what I will do, I will simply define the DAG, add the DAG, and here I will simply say schedule equals to special dates, and that's it. That means I want to run my schedule on these dates, and that's it. Okay, and start date I can just keep it like this, and end date is this, and catch up equals to true. Okay, and then this. Simple. And then I can simply define any kind of task, any task. You can say df, not incremental, because this is just a basic DAG, or I'll say special dates DAG, and here we have task. Yeah, perfect. Date interval start, not really. I can use one more date here. It is called logical date, which is a kind of execution date that we get. Okay, because this date is also very helpful, logical date, because you will see all of the you can say dates available for this particular execution, and this is called logical date. Okay, we can just access it, and this tag. Perfect. So now let's wait, let me just rename it. Special dates. Simple. Okay, cool. So now let's wait for it to process our DAG. Okay, it has processed it. Makes sense. So this is a DAG. Special dates DAG. Okay, perfect. See, it showed us 4 events. Why? Because we have 4 tasks. Obviously no runs, but I can initialize it, but I do not actually need to worry about it, because it will simply start some of the events which can be triggered, right? Makes sense. and then you will see just 4 events. That's how you can just create all of the tags for your special dates. It was like a very quick one, but it is very, very important when you're just preparing for any interview or anything. Make sense? Okay, so this thing is also clear. Now what's next? Now finally we need to talk about a very, very, very latest upgrade in the Airflow. It is called assets, and you have to understand it in detail. So it is a new thing, first of all. So yes, you need to put some of the extra effort in understanding assets. So let's see what are assets. Assets in Airflow. Let's see. So now let's talk about our very, very, very complex, the most complex thing so far is assets. So let me just take you to my whiteboard. So the thing is, this topic is very, very new. Okay, not like new, but kind of new. But do you know what? If you want to understand this, you just need to be more focused, because when I was also learning about this thing, I also was totally off, because see, okay, let me just tell you, because you will be afraid then. Okay, so now let's talk about the assets. Now what is asset? If you are coming from Airflow 2.0, it is very, very similar to datasets, but not exactly. There are many enhancements as well. Okay, and we are not talking about Airflow 2.0, blah, blah, blah. So if you are coming from Airflow 2.0, or if you are not coming from Airflow 2.0, just forget about it. Now let me just tell you what is an asset and what is an asset approach. Okay, now so far, whatever we have developed, whatever we have discussed one approach which is called task approach. What did I say? Task approach. Let's say I have this task number 1, task number 2, task number 3, task number 4, like this. Okay, so this is fine, nothing is wrong in this. Let's say this. Okay, this is the kind of task approach that we have discussed so far, where we are more concerned about if this task is done, okay, and if this task is done, if this task is done, if this task is done. Yeah, makes sense, because we are just simply concerned about, hey, if this task is successful, if yes, then move to the next one, if yes, move to the next one, and so forth. And so far we have just discussed this particular approach. That is fine, but sometimes we need to build DAGs which are not focused on tasks, okay, which are focused on the end result. Okay, for example, let's say, let me just remove other tasks. If I say you just have 2 tasks, okay, but these are big tasks, okay, or you can say work, or you can say goal. This is goal number 1, this is goal number 2. Okay, forget about task, because you will be confused then. This is goal number 1, this is goal number 2. The goal number 1 is, let's say, data extraction. Make sense? Cool. Data extraction. It can be from any kind of API, anything. Let's say any kind of API. Okay. Simple. It can be any kind of API. Cool. Now this task is data extraction, or basically this goal is data extraction from this API, and this goal is data processing. Simple. Data processing. Now so far the things that we have learned, okay, I'm not saying like it is not relevant, it is like a special use case, or you can say special kind of requirement that you can have, and don't worry, you can just blend everything together. It's totally up to you. So let's say you are extracting some data, okay, and just stay here for just a few minutes. Now I'm saying that this particular goal, this particular code will extract my data. Yes, some code here, okay, some code. Let me just write some code. Let's say a Python file, because we are using Python here. So let's say data extraction. Okay, simple. So we have this thing here. Okay, now I am saying that you can move to the second work or basically second goal if this data extraction is done. Okay, but do you know what? Now with the modern, or not modern, basically you can say this approach, assets approach, I will say you do not need to move to the second task if this task is done. Why? Because let's say I tried extracting the data, right? Code went fine, code ran fine, everything went fine, but the end goal of this particular work was not fulfilled. For example, the end goal was a kind of data storage, any kind of storage. Let's say I wanted to store some data locally in the folder. Simple data storage. This is my data folder. So the end goal was this one for this particular work. Okay, perfect. Now what will happen? Now I want to logically, if you will think logically, you want to process your data once the data is here. Yes, logically, just think about it. You will only run this particular work or basically run this particular code, Python code, if you have this data. Make sense? Good. Not after when this task is completed. Yes, if you will think from, you can say, a third person point of view, you will say, yeah, because this task is responsible for processing the data and loading the data into this folder. So if this task is completed, only then you will go to the next task. Not really, because sometimes what will happen, this data is not populated, this folder is not populated. This is scenario number one. Or scenario number two, let me just tell you, let's say this particular task is not populating this data due to any reason, due to any failure, due to any stoppage, anything. But this data folder can be populated by another DAG as well, right? Let's say this DAG is not working. Okay, this task is not working. So obviously data processing will not happen, will not take place. Makes sense. But there's another DAG, because there can be multiple DAGs. It also extracts some data, and let's say this extracts data from any kind of graph query language or anything. Okay, let's say this extracts data from the graph query language. Simple. Okay, now this went fine and this didn't break anything. So in that scenario, obviously we have some data, but just tell me one thing, will this data processing code will run? Obviously no, because we have dependency on data extraction task, and this task didn't run, or it ran but it didn't populate any data. So ideally we should shift our focus from the task approach to the data approach, or basically data set approach. That means I want to process this data, this one, when I have this folder data populated. Make sense? This is the data set focused approach, not task focused approach. Or you can say this is assets focused approach, because this is my asset, a kind of, what is asset? Asset is something which is useful, which has like some like asset. You can just check the dictionary for the exact meaning. But if you're if you're working as a data engineer, what is an asset? Asset is something precious, something meaningful. So this is something meaningful. This task is not something meaningful. This is just running a code. This is the end goal. Okay. So now what we do, we create something called as assets. So this will become data extraction step as my asset. Okay. This will become my asset, like a kind of asset. Makes sense? This is my asset number one. And this will be my asset number two, which is this one, like this. And this will be my asset number three. So now what is the advantage of this approach? Advantage is in front of you. advantage is in front of you. Let me just color it. Let's say this one. Yeah, perfect. Advantage is in front of you. So now what you will do, you will create this asset. Perfect. You will run it independently. You will run this asset. You will run this independently. You will create this asset which is dependent on this piece, this end goal. This is the dependency. Okay. Make sense? Make sense? And what is the, you can say, provider or basically the producer of this thing? These two assets, right? These two assets. So you can just link your dependency onto the data set instead of just linking the dependency on the task. Make sense? So what is a special thing about asset which is not available in task, or let's say what is that particular thing which is missing? So the missing thing is we always link our asset to a data set, or basically you can say we always link our asset to the end goal, to the piece of data. Make sense? So let's say this is asset number 1. Okay, so this asset is linked to this particular, or basically this is the asset. This complete thing is the asset. This is the, you can say, code, and this is linked to this asset. Asset is this one because this is something meaningful, right? I know this is confusing. Don't worry, you can just rewatch the section because it is confusing. I also took like so long to understand this. Do not feel frustrated. Hey, I'm not able to understand. It's fine. Just rewatch this part. So now I am saying that this particular asset is pointing to this data. Make sense? So this complete pointing thing is my asset, not just this code. When this code is pointing to this particular thing, that becomes my asset. Make sense? Make sense? Don't worry, it will be like more clear when you will be just making more and more practice with the code, and I will just show you everything. Don't worry at all. So this is my asset. So first of all, what I will do, I will simply provide a kind of definition which will say, hey, this is my asset. And what this asset will do, this will just, let's say, populate some data. It will do something. It will do something. Okay, it will do something. Okay, let's say it is populating some data in the folder, and it will just put some data in the folder and anything. Simple. Now I will say, I need to run this particular asset if this data folder is updated. If the, you can say, end goal of this asset is updated, only then. I will not create any dependency. Like I want to run this particular asset after this. No dependency. It will be a kind of automatic trigger when we have the state updated for this particular asset. Make sense? Make sense? You will see everything, don't worry at all. But this is a kind of understanding that you first need to understand. So now let's do one thing. Let's actually start the code, and then only you will understand all of the things step by step, because see, this is a new thing and this is a complex thing. So this is expected, don't worry at all. So let me just open my VS Code editor. So let me just create one file, and I will say 13th, and it will be called as asset.py. Perfect. So now I will simply import, first of all, .sdk, import DAG, task, and I also want to import asset with small a and with capital A. I think it is not required, so it is fine. Yeah, it is fine. From pendulum datetime. So now what I will do, I will simply create an asset. Okay, so in order to create an asset, you can simply use asset decorator, asset, like this. Now there are some things that you can just provide with this particular asset. The first thing is the schedule. Like when you want to schedule, like it can be daily, it can be like weekly, it can be monthly, same thing, the same thing. Okay, but the second parameter is dangerous. Schedule is daily. Okay, now it's called URI. Now what is URI? URI is not required argument, first of all, but it is recommended to always provide the URI. Now what does URI mean? So it tells like what exactly our asset is pointing to. So let's say I am trying to write into any kind of S3 bucket because I can just see this recommendation. So I am just taking that example. So let's say I am just writing something in my S3 bucket, right? So my asset, my end goal will become that particular URI. Makes sense? So let's say here I have this particular data folder. So I can just put the URI as a location of this folder. It helps the other developers and you as well to identify what exactly you're trying to do. Make sense? So let's try to pass it. It is not required first of all, but you should always pass it. So I want to write my data in the, let's say, OPT, Airflow, logs and data, because we'll be using, you can say local folder. Okay. So I have just provided this particular path and what type of, you can say file I want to create. Let's say I want to create data extract dot txt. Okay, so this is my URI. Basically I am telling that this is my asset that I will populate. Make sense? Simple. Okay, now I can also pass an optional parameter and I can actually write it here as well. This is where data will be stored. This is optional, but good to include for clarity about the assets data range, not data range, assets location, kind of location, because it can be anything. It can be table name, it can be database name, it can be anything. It is like for your readability, like where your asset is pointing to. Simple. And then I will provide an optional thing which is name, and I will just simply say extract data or fetch data. Let's say fetch data. Simple. Okay, now I'll simply say def and I will create one function and the name will be fetch data. So if you do not pass any kind of, you can say name here, it will take the function name as the name, similar to other things. Simple. Okay, now let's say I want to use any of these parameters. Let's say I want to. So in that particular scenario, you can just pass an optional parameter called self, because when you pass self, you can access anything here, self.uri, because the good practice is you should always define the path in the URI and you should access this variable within the function. That is a good practice, but it is not like mandatory thing. You can hard code this value in the code as well, here as well. Okay, so let's say I want to first of all create a directory. So I will simply say import os module. Perfect. And let's create the directory and see. So now I want to create the directory at this path. Okay, os.path.directory name exist okay equals to true. Make sense? You can directly create the directory as well. It's not a big deal, but I can just use that particular you can say URI if I want to. So now I cannot use this full link or basically path because I have the file name as well, but I will use directory name. Directory name will give me just this particular path till here. Okay, just os module fundamental. So self.uri exist okay equals to true. Makes sense. So now we have our you can say folder created. Okay, so now we can say like we have fetched some data, right? We can just write something on our own. So I will simply create, or let's say that was good. So with open self.uri wsf, perfect, and data fetched datetime.now and end, perfect. So now we have written this file in our you can say location here, because we have opened this file like this. Okay, simple. Which file? This file. This file, data extract.txt. Even if this file is not there, it will create it because we have opened it in the write mode. Simple. And then let's simply say print data return to this location. Perfect. This is my asset. This is my asset. So now what will happen? Now just wait for few seconds and you will see that particular thing in the Airflow. So let's wait for it to parse it. Currently I have 12 DAGs. Let's wait. And you can ask one very good question. Okay, now you will say, Ansh, Lamba, why are we just looking at the DAGs? Because this is an asset, right? Yes, you are right. Your question is right. But let me just tell you what actually happens, what will actually happen behind the scenes. So whenever we create an asset, so what will happen? This pink box is, let's say, asset. Okay. Okay, this pink box is asset. Let me just wrap it with this box. Okay, perfect. So this is my asset, right? Now, do you know what? This asset is not something magical. It is doing a very basic thing under the hood. What it does, it simply runs a DAG with only one task. Oh, okay. So remember this task, this is exactly your DAG, but DAG with just one task. Okay, so let's say this is your gray box is your DAG. Let's say this one. This is your DAG, but in this DAG, you won't find the, you can say so many things that we were just creating before. No, just one task. This is your task, the Python task, right? This is your task. That's how it works. That's how it works. Task. Okay, so this asset is nothing but it is running a DAG under the hood with just one task, and that's it. That is why asset is not something magical. It is your DAG. It is your DAG, but you have like learned how to build the dependencies efficiently between the DAGs by looking at the data set focused approach instead of task focused approach. Simple. Okay, I hope it makes sense, and let me just quickly do it here. Perfect. And let me just do it here. Perfect. That's how it works. That's how it works. Simple, makes sense. And when you will be just looking at the code, things will become more and more clear. So don't worry at all, because we all are learning here, not just you. So just calm down. Because see, we have just received this particular upgrade from Airflow. So what are we trying to do? We are just trying our best to learn, and that's it. So now let's quickly see if our DAG is parsed or not. Let me bring Airflow screen here. Okay, just 12. Okay, if I go to assets, okay, something is missing or what? I don't think so. Everything is fine. Maybe it will take some time. And 13 asset. Oh, it is parsed. And just ignore test 2 and testing. I was just playing with some things. Okay, so just ignore that. So yeah, now it is parsed 13. So now I can see my DAG, which is what was the name of it? What was the name of the DAG? Name is fetch data. Perfect. So as you can see, my fetch data, where is that fetch data? Here. So this is my DAG. Very simple, because we just have one task, right? And let me show you one more thing. If I go to Docker, I will show you something. Just open your any container, okay, and just click on exec. And now I will show you, first of all, pwd. Let me just check where I currently. Okay, so let me just go to the previous folder. If I go to cd ..ls, perfect. So now I am at the same location where you will be. Okay, so let me just check what do I have in the present working directory. I will simply say pwd. Perfect. So you will be here. Now let's go inside the, or let's say ls. Okay, these are the 4 folders. Now we know that we created the folder called data inside the logs. I will simply say cd logs and data. Perfect. Now I will simply say ls. Simple. You will see 2 files. Okay, and you won't see any files, because these are like my files that I created earlier for testing purpose before demonstrating this. So you will see nothing. Okay, you will see nothing. So this folder is empty, or even you will not see this folder because this folder will not be created in your case. Okay, so you can just ignore, but I'm just showing you that you will see the files here in the future. I'm just making you familiar with the environment. Okay, very good. Now what you will see is just say airflow assets and list, hit enter, and you will see asset. See, again you will see so many assets because I was just playing with it, but in your case you will just see one asset, which is this one, fetch data, which is this one. So that means you have created this particular data called fetch data, or basically this asset. Simple. And here is the URI for it, data extract. Simple. Very good. Now this is our first asset. Now we need to materialize it. Now what is materialization? Materialization is just a fancy name to run the asset, because we do not run asset, we simply materialize asset. But just for simplicity, you can simply say now we need to run our asset. Now let's go to our DAGs folder and just simply click on fetch data, and let me just click on trigger. And if I just click on trigger, it will simply trigger this task, which is a normal task, and it failed. Very good. Why? Function objectives, no. Oh yeah, I see. Let me just remove that thing, because we are just using some datetime functions and we do not have those functions pendulum. So datetime.now data fetched, let's simply say data fetched successfully. That's it. That's what you want to do. Perfect. Okay, because that function is not available in pendulum, so that is fine. Okay, makes sense. So let's see if I just refresh it, if I check the code, if it is updated. Yes, let me just trigger it one more time. Perfect. So now if I just open this, I will see data returned to OPT Airflow logs, because we printed the statement, right? Now we also need to check it. So now let me just go back to my Docker. Now if I say ls, I am here. Now you will see this file, data extract.txt, inside the data folder in the logs folder, right? The same folder that we just currently just investigated, right? This is a file. That means we have successfully materialized our first asset. Perfect. Now if I say I want to create one more asset, because that is the original requirement, and I want that asset to be dependent on this particular asset materialization, right? Good. Now I can just show you that particular thing in the same file, Python file as well, but you will not learn much things. I want you to create another file, because that asset can be a totally independent asset, right? So what I will do, I will simply create another file. Okay, and I can simply clone it. Rename 14, and I will say asset dependent. Okay, because this is a dependent asset. So now what I will do, I want to process this data, right? So now what I will say, I want to create a new asset. Simple. Okay, so and obviously URI will be different. I will simply say data extract, and now this will be data processed. This is my, you can say, file that I want to write. Okay, and I want to say data processed successfully, right? And data processed. Perfect. This is our different asset, but you know what? Here is the thing. Now we need to say, we do not need to just schedule this particular asset. No. We want to run this asset as soon as our previous asset is completed, or basically successfully materialized. So I will simply use the name of it, which was, I think, fetch data. Simple. Perfect. Now you will see this warning, obviously, because we do not have fetch data variable here. Now you need to obviously import that particular asset. How? Very simple. Simple Python import. You will simply say from this file name, or basically 13 asset import fetch data. Simple, right? Okay, why you are seeing this number? Because of the file name. So let me just say assets 13, because asset 13, otherwise it will simply say, hey, what are you just trying to import? Asset 13, perfect. We have imported this file, asset 13, very good. Now we have this fetch data available, perfect. And this is our new asset, which is called process data. And this is the name, this is the URI, perfect. Very good. Now let's check our Docker. How many assets do we have? We can just check the Docker, or much better way, we can also go to Airflow UI and click on assets. Here it should show all of the assets. So currently we just have one. Maybe the other asset is not parsed right now. So if it is parsed, it will come here. And if I just go to DAGs, yeah, it is not parsed now. So here I can just check the logs. Okay, yeah, it is not parsed. So what will happen? Everything that you have within this particular assets, obviously you can see the DAG as well, but we can create hundreds of DAGs and we hardly create few assets. So we have a dedicated tab for the assets. Here you can see all of the assets, and currently we just have one asset. That's why you are just seeing this thing. Simple. Okay, very good. Now what will happen, if you have the new asset, it will first of all come here, okay, and it will just also appear, it will be also appear in the Docker. Then what we gonna do, we gonna run this particular fetch data DAG only. We will not run the other asset, but the other asset will automatically be triggered as soon as this fetch data asset is materialized. That means as soon as it has just extracted the data, or basically fetched the data. Simple. Let's wait, and let's wait for it to parse it. It will take some time. Okay, so this is now parsed. Let me just go to my Airflow UI, and as you can see, we have both the assets ready. But now let's do one thing. Now I will simply go to fetch data, and I will trigger this particular DAG from here. See, I am now triggering it. Perfect. And immediately I will just go to the process data, and you will see it will be triggered automatically. Really? Yes. If I just click on this particular DAG process data, you will see the schedule is not any kind of number. It is called fetch data. It is called what? Fetch data. That means the asset. This is the symbol for asset. Asset, and the name of it is fetch data. Perfect. If I go to runs, you will see a lot of runs because I was just using or testing it for the previous example, and I just took the same name, but it's fine. This is the latest run, 1249. If I click here, okay, and you can see run type is asset triggered. I didn't trigger it. Simple. If I open this one, and if I just go to this particular task ID, and you will see everything here. See, everything. Makes sense. Now if I just go to Docker, now let's see what it has put it. Now if I say ls, perfect. I have this new file data process.txt automatically. I didn't trigger this asset. It was triggered automatically because of the dependency of the asset, of the materialization. Makes sense? This is your asset, which is the data driven approach. Now, just a quick tip or quick information. Now you will say, Ansh, Lamba, we can also achieve the similar thing by creating the dependencies between the DAGs. Let's say I create this DAG, I create this DAG, and I create this DAG, and I can also create the dependencies between the DAGs as well. What's the big deal? See, if you, so for this example, we have just taken the very basic example, but in the real world, you can also add some data validation steps as well for your assets, which will make sure that if the data that you have extracted is fine or not, you can just run some testing before triggering this asset. So all those particular things are not possible with DAG. That is the reason that we just use assets. It's not just about dumping the data. You can just also add some validation with the asset, you can say decorator. Make sense? But if you do not want to apply all of these validations, if you just want to dump the data and you want to run the next DAG after that, yes, you can use a traditional DAG and task approach as well. Simple. But I wanted to just let you know everything. Make sense? Make sense? Make sense? Okay, very good. So now at the end, let's try to discuss about one very simple thing, because see, in the real world, you'll be just creating so many DAGs. You will be creating, let's say, hundreds of DAGs. Okay. And let's say you want to orchestrate, let's say 10 DAGs. Okay. You have one DAG for sales department, then another for marketing and you want to make sure like sales DAG should run first, then it should go to marketing, like all of these things, right? Because so far we have just orchestrated the tasks, and we have also seen that how we can just build assets. So now let's talk about how we can orchestrate the DAGs. Let's say we don't want to use assets, we just want to use DAGs and task approach. How we can orchestrate it, right? DAGs orchestration. Perfect. So now we will just take a very basic example. So what we will do, we will simply build one DAG. Let's say this is task number 1, this is task number 2, and this is task number 3. Simple. Task 1, task 2, and that's it. Task 1, task 2, task 3. Simple. So this is your first DAG. Okay, this is your first DAG. DAG number 1, let's say for sales or anyone. Okay, makes sense. This is DAG number 1. Now you need to make sure that you will run this DAG first. Okay, and then you will run the DAG 2, DAG 1, and you want to run this whole DAG after this one, DAG 2, because obviously you would need to orchestrate these things, right? Okay, so for that it's not a big deal. First of all, it's very simple. Let's say perfect. So now let's try to orchestrate this thing. We'll just take a very basic example, don't worry at all. Okay, so this is my orchestration that I want to build. So let's go to our VS Code header and let's try to create some files. Okay, so now what I will do, I will simply create one DAG, this simple DAG. Let's say first DAG, and this is amazing, and this is second versioning DAG, right? Okay, so now let's say I want to create one file. Let me just say DAG 1. Okay, why DAG 1? Because DAG orchestrate 1.py, because obviously you know like it will not allow you to just import the package then. So this is my first DAG. Okay, simple DAG, and let's copy this one, and the second DAG is exactly same, but we just need to make sure it runs after that. So like this, simple. Now whenever we just create, you can say DAG orchestration, we always create a parent DAG. That means we simply create a parent DAG where we put both of these two DAGs. Like this is a very common sense thing, but still, let's say perfect. And I hope it is simple. Okay, so this is the parent DAG, this one. So you need to embed this DAG within these two DAGs. So basically you need to orchestrate these two DAGs from this parent DAG. So let me just provide a good name. Let's say parent DAG. Simple. Okay, good. So this is my parent DAG. That's how it works. Simple. Let me just bring it here. Perfect. This is my parent DAG. Now parent DAG is very easy. You do not need to do anything. Why? Because you just need to import the DAGs and that's it. So that is why the parent orchestration is very, very simple. It's very simple, but it requires you to be responsible, because you need to make sure that you are orchestrating the DAGs carefully, because the inner tasks are very, very important, right? So let's go to our DAG orchestrate parent. So let's try to create a new Python file, and it will be called as DAG orchestrate and parent.py. So in order to orchestrate the DAG, I'll be creating a parent DAG, right? So what I will do, I will simply first of all import my, you can say child DAGs, or you can say children DAGs, right? So I will say from DAG orchestrate 1 import first DAG, right? And then I can say DAG2. Okay, this name is also first DAG. Okay, I can just change it then. I can say second DAG. I can say first orchestrate DAG. Okay, first orchestrated DAG, perfect. And this name will be, this is not first, this is second. Second orchestrated DAG, and this is second. Okay, perfect. And here we have first orchestrated DAG, perfect. Now we can just do it. So this is parent. So I'll simply say first orchestrator DAG, and this is second orchestrator DAG, perfect. So these are the two DAGs that I have imported. So now I will simply do DAG and parent orchestrator DAG, simple, and I can simply say schedule, or even if it is like not required because we are not going to schedule it, we are simply orchestrating it. I'll simply say df, okay, DAG orchestrate parent, first equals to first, second equals to second, and that's it. Simple, right? But here, where are the tasks? Just to be more proficient, you can create an independent tasks as well. It will be like more proficient. Otherwise, you will not see the tasks. So you can simply say @task, okay, and you will say df first task or first orchestrator DAG, perfect, and this will return this thing, okay. Or we do not even need to return anything. We will simply say, hey, just call this function. Which function? The function name is first orchestrator DAG. Simple. This is our function, right? Simple. And same with task, @task, and perfect. That's it. And here we can just now orchestrate it. First orchestrate task, second orchestrate task, perfect. And let me just import airflow.sdk, otherwise you will see the warnings. So what we did, we simply created the parent DAG, okay, and in the parent DAG we simply created two tasks, one task for each DAG, because it gives you a better data lineage. And do you know what, when you're just building small DAGs, it is like not very important to see the lineage, but when you're building like huge DAGs, you need to see the lineage. So one task for each DAG, simple, okay. Now let's initialize the DAG, and now let's see how does it look like. And first of all, make sure it is parsed. DAG orchestrator, okay, children DAGs are done, and DAG orchestrate parent, let's wait for it. DAG orchestrate parent, okay. So as you can see that it has just passed this DAG. Let's see our Airflow UI. Perfect. So now if I just go to DAG orchestrate parent, I will simply see two tasks, and each task is for DAG. See, this is a DAG in itself. Makes sense? Okay. So now what I will do, I will simply go to this parent DAG and I will simply click on trigger. And this will trigger both of these two tasks. One task is done, second task is done. That means it has actually triggered that particular thing. See, it has actually triggered both the tasks, and each task is what? Just a function. Which function? Those DAGs. Wow, literally wow. See, DAG orchestrate. And what are the you can say pipelines that it has run, or basically DAG. First orchestrated DAG, as you can see, this is the first task that it has run. Obviously it will not come up here because we just ran this task from the other DAG. Make sense? That's how you can just orchestrate the DAGs from the parent DAG. Now I know you are curious. You will say, hey, can we just confirm, like, did it actually trigger the DAG or not? That's actually a good question. Let's do one thing. Let's go to DAG orchestrate 1 and let's create a task which will actually write something. Remember that particular file that we created in the asset 14? Let's try to do something like this. Let's try to write some data, right? Because then only you will say, okay, this has actually triggered the DAG. because this will give you some satisfaction, right? So let's go to orchestrate one. Okay, and I will, in the third task, I will put the code like this. Okay. 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 And okay, I can import OS, not a big deal. And just like this. So now what will happen? Let me just put the URI instead of using the variable, because this is not a asset. So directory name, as you all know, is OPT, and then Airflow, then I think it's logs, then data, right? So this is make directories. Okay, and then we can say output.txt. Okay, or output1.txt. Simple. Let's create this file. It will just give us a satisfaction. Okay, this DAG actually ran. Makes sense. Let me just copy this task in the second as well, in the second orchestrator. Perfect. And now I can say import OS here as well. Simple. Now let's see if it actually runs it or not. Okay, now if I just go to Airflow and if I refresh it, first let me just make sure that it has the updated code. I will just check the code. Yes, it has the updated code. Now if I just go to DAGs and if I just now run the parent DAG, now let's see trigger. Success, but we need to confirm it. I will go to my Airflow and I will simply say clear. And where am I currently? Okay, I'm in the desired folder. I will simply say ls. Did I see any kind of file? No. So that means those tasks are not actually triggered. Those tasks have not actually triggered my other tags. Wow. Because I wanted you to see this error. Why? Because whenever you're just trying new things, so obviously at some point of time you would just orchestrate the DAGs. But whenever you just want to orchestrate the DAGs, you cannot just create a simple function like this function. No. Because this is just a kind of, you can say, DAG ID. This is not actually the executor, or you can say operator, because whenever we just want to run any function, we need to run it through the operator. So for that, we have the special function in the, not function, you can say a kind of operator within the Airflow. So let me just show you what is that. I don't know if it is available with the task API. Let me just check. Task dot I don't think so. So we can just use that operator. And let me just check the class again for it. What is the class, bro? Class from Airflow dot operators dot trigger run dot trigger DAG run import. Yeah, this is the class. And why it is showing like this? Because this package is not installed, but that is out of the box because we are not running this particular thing within our system. We are running this thing in our Docker, and it has everything. So now within this DAG, we need to just create two operators. Okay, the first operator is, let's say, trigger first DAG. Okay, and we will just use this operator, trigger DAG run operator, and now we need to pass the task ID. Task ID means this task, this current task. Perfect. And it can be anything. And trigger DAG ID means this DAG ID that we are just running. Make sense? So that's how we can just run our DAG. Make sense? Make sense? Simple. Okay, so now we have just used these two operators. Just keep this thing in your mind. Okay, now let's see if we have the updated code in the Airflow. Just go to DAG, and if I just go to parent, where is that? What is the name of the DAG? Okay, DAG orchestrate parent. Makes sense. Perfect. If I just check the code, perfect. I'm just using this. Let me just hit run or trigger. Let's see. Okay, this time it is successful. And this time we are expecting that it should have run the tasks as well within the DAGs. Now if I say ls, okay, now as well we are not seeing this thing. Very good. This is not expected behavior, to be honest. This should have triggered it. Let me just check the this thing. Okay, so what happened? DAG orchestrated parent actually orchestrated everything, which is this one. Okay, these are successful. So this should have triggered our child DAG, right? So if I just go to DAGs, if I just go to first DAG, which was first, oh, I see. See, this is in the queued state because we didn't enable, or because we didn't turn it on when we just deployed it. Let me just click here and let me just turn it on, and I will not trigger it, but still it should have triggered it automatically. Okay, so now you are seeing it is already running. Okay, I didn't click on trigger, I just enabled it. Oh, I see. Okay, that's fine. That's fine. I was like, why it didn't like do anything? That is fine. And I can just also enable the second one, which is second orchestra DAG. It is also queued. See, this is saying queued. That means it was triggered, but it was not enabled, so it was queued. That is fine. That is fine. That is fine. Okay. Now I should just check my ls. Finally, yes, output 1 and process. Where is output 2? Okay, because maybe it is like still running it. Output 1.txt, or we are simply outputting the same thing. If I just go to orchestrator 2, what are we outputting? Yeah, output 1. Let me just say output 2. Perfect. And now if I just go to my DAG, if I just go to my, you can say, if I just trigger it one more time, because now both are enabled, now it should run fine. DAG orchestrate parent and trigger, and that's it. Now let's see. Let's see. Okay, perfect. Now if I just go to Docker, now if I just go to ls, perfect, boom, finally. See, that's how you learn, that's how you grow. And there's one small parameter I want to show you, because whenever we just create dependency within DAGs, I do not want you to be in the situation where you will be like, hey, what is like happening? Because both, like all of these tasks, or basically DAG runs, can happen asynchronously. So you need to say one parameter which is like a very good parameter, and let me just show you. It is called wait on completion. Wait for completion equals to true. You can just make this change. Wait for completion equals to true. Make sense? So this will, so this parent waits until child finishes. Make sense? So this particular one, this trigger, this one, this will wait, okay, until this whole, you can say, child DAG is completed. Make sense? Because sometimes you can just run things asynchronously. In the linear or simple lineage, it is fine, but in the complex ones, you can just see some suspicious errors. So this is a kind of a good guardrail. Okay. And just to test the final thing, because let's say output 3, and let's see if we just see this or not. If I say trigger one more time, perfect. Now if I just go to Docker, status running. So see, now it is running. Makes sense. Now just wait. Okay, that is a kind of, you can say, guardrail that you can add, totally optional, but it's up to you if you want to add. Okay, makes sense. So okay, the first task is completed, so now it is running the second one. Like, it can be slow, but it guardrails so many things. It's totally up to you. If you just want to add it, you can add. I can just say optional. Just here you can say optional parent waits for the trigger DAG to complete. Okay, and I can say optional. Okay, same here, optional. And I can also say this is slow. Okay, because it will not run your task asynchronously. Asynchronously means like it can use event loop to run your tasks. Okay, it will not keep your resources locked, but just a good thing to know. So now you can see all the things are done. Now if I just go to my folder ls and output 3.txt, perfect. So just come here. Now come here, it's time for like one-on-one talk. Our Airflow masterclass is completed. Now you are eligible enough to start building your Airflow, DAGs, assets, all of those things. Yes, you will see errors. Yes, you need to learn a lot of things after this, because when you will be now developing the things, you will learn more and more and more. Make sense? But this masterclass has made you eligible, or you can say has made you capable enough to explore and start building. Right? That was the entire agenda of this masterclass. And obviously, if you just love this particular masterclass, just hit the like button and just hit the subscribe button and just comment whatever you feel. And before just going, I will just also show you how you can just turn off your resources. Okay, because that is important. So what you need to do, simply go to your Docker Compose file. Okay, and just open the terminal in the integrated terminal. Perfect. Now simply write the command called docker compose down. Just wait, docker compose down. What this will do, this will just, you can say, close all of the containers that were running in the background. Okay, just simply hit enter and you can see stopping. Now removed. So all the containers are removed. If I just show you my Docker now, it has nothing. Why? Because all of the containers are removed. But if let's say you want to start it again, you can simply say docker compose up -d and it will be up and running within just few seconds. So it will take some few seconds and that's it. Okay. Because if you do not turn it off, it will be like keep on running in the background, but you can just turn it off now because it is not required. If you want to learn more and more things after this thing, then you can just enable it or you can turn it on again. Make sense? So that's how you can just manage your Airflow. Now just start developing with Airflow, and that's all about our Apache Airflow masterclass. I hope you loved it. I hope you liked it, and I will see you in the next video coming on the screen right now, and happy learning.